Hello, everyone, and welcome to the course. I'm your instructor, and I'm genuinely excited that you have chosen your programming adventure right here. This course is built to be your complete guide, taking you from knowing nothing about coding to confidently writing your own functional Python programs. Python is a phenomenal choice. It's powerful, high in demand, and one of the easiest language to learn. So, let's begin with our course goals, what we will achieve together. What's the end goal? By the time we are done, you won't just memorize syntax, you will understand core programming concepts, which is the truly valuable skill. You will write code that is clean and professional. We will solidify this knowledge by completing several mini projects, culminating in a substantial capstone project. This foundation is your ticket to pursuing advanced paths in data science, web development, or AI. So, you'll know all the core programming mastery, professional code quality. We will build real world projects, and we are ready for future ready foundations for data science or AI. Everything requires Python these days. Now, talking about who is this course designed for? This course is intentionally structured for absolute beginners. If you have zero coding experience, this is the perfect starting point. It is also ideal for aspiring developers looking for the best entry language, or for professionals who simply need to learn automation skills to make their current job easier. If you are here, learn how to code, you are in the right place. So, for absolute beginners, for aspiring developers, and for career, even if you want to switch your career, this is the perfect course for you, and we will be learning everything about Python in this course, and it is perfect for absolute beginners. Now, let us talk about the course structure. What will be your learning roadmap? So, here's the brief journey. From section 1 to 3, we will be building foundations, right? We'll master the fundamentals, including basic setup, data types, collections. These are your building blocks for going ahead. Next comes our section 4 to 6 static, that is logic and control. Here we will learn about functions, loops, and file handling. This is where your code becomes dynamic and powerful, right? How we have to organize it with functions, and how we can automate things, we will be learning in these sections. Now comes our section 7. Section 7 is object oriented programming. So oops, if you have heard of it, object oriented programming, that will make your code more organized, reusable, and professional, right? And the last section, section 8, comes our capstone projects. So this is the ultimate practical test where you will build impressive projects to showcase to your newfound skills. So it's not like any other course that we will just learn the syntax and the theory. We have special dedicated sections to build projects and real life applications, how you can use them. So let's move forward. Why Python is your perfect starting language? Let's talk about this because it is human readable syntax and it has incredible versatility. So, why Python specifically? First, readability. Python syntax is notoriously clean and often looks very similar to standard English, which significantly flattens the learning curve. Second, its versatility. It's unmatched. If it runs on a computer, Python can likely be used for it. Finally, it has a massive community and libraries, means there's a pre-built tool for almost any task you can imagine, right? So since a lot of people use this, they build libraries, and the community is very strong. So what happens is that if you get stuck or you get any bug in your code, there are a lot of people on the internet to help you, right? Now, what you need to get started, and trust me, you just need a good attitude to learn this. I love this slide because the requirements are so minimal. All you need is a working computer, a reliable internet connection, and most importantly, the willingness to put in the time and practice. Everything else, the software, the environment, the specific knowledge, we will provide and set up together, right? So your working computer could be any Windows, Mac OS, or Linux. Any will work, no worries about that. Reliable internet connection and some of your enthusiasm to learn, right? Now, let's talk about your learning strategies for success. Learning to code requires active participation. My number one piece of advice is to code along. Pause the video, type up the examples, and on your machine all the code which I will teach you, and see the results immediately. Trust me, it's very beneficial. What you can do, you could change the code, you could experiment it, and then you can see what is the result. This is how you learn the boundaries of the language. And remember, practice is critical. The exercises and the projects are where the concepts truly sticks. So first, what you have to do, you have to watch and understand, then you have to code along actively, and then you have to experiment fearlessly, right? You could change the variables, parameters, numbers, and see what happens if you change something. And you need to practice consistently. Now, let us talk about developing the programmer's mindset. How do you develop this mindset? Programming is essentially problem solving. We can take a complex issue and then decompose them into smaller, solvable steps. So, adopt the mindset of a debugger. When code breaks, don't get frustrated. That error message is a clue, helping you pinpoint exactly what needs to be fixed. Finally, embrace the iteration loop, plan, code, test, debug, and repeat. You have to become a detective debugger, right? So, errors are not failures. This is a very important line. They are helpful clues, right? So they guide you. Don't be frustrated if your code is not working. In programming journey it happens a lot, and people get frustrated and quit coding. So you don't have to do that. And then you finally have to do, you have to be iteration embracer. You have to plan, code, test, debug, and repeat. This is the cycle. This cycle is the heartbeat of programming, successful programming, right? Now let us see the section 1 roadmap, what's coming up. So first lecture was our welcome and course overview, which was this lecture. Next lecture we will be studying why Python, what are its real world applications, about that. Then we will be installing all the IDEs, all the environment where you will be coding, and then we will be writing your first Python program. And then in the fifth lecture we will be understanding errors and debugging, how you can fix your errors, right? So that's all. Now we are about to dive into the exciting world of Python applications and see what industry giants like NASA and Google, Netflix, how they use Python for their daily operations. Now you have to get ready for some incredible projects we are going to build. And trust me, hear from me it again, that you are at the perfect course, at the perfect place. And trust me, our journey is going to be amazing. So let's get started, and I'll see you in the next lecture. Welcome back. In our last lecture we covered the basics of our course structure. Now, before we install any software, let's answer the most important question: why Python? Why spend our valuable time learning this specific language? Today, we are going to explore the vast universe of Python applications and show you the real world impact of the skills you are about to acquire. So, data science and analytics. If you're interested in data, Python is the language you need. It is absolute industry standard for data science and analytics. Two tools are here critical, which are pandas and numpy. So pandas is like incredibly powerful spreadsheet tool for programmers, allowing us to clean, manipulate, and analyze massive datasets quickly. NumPy handles complex numerical and mathematical operations efficiently. If a business needs a new dashboard or financial model built, they often use Python. So these are the two key libraries which are very important: Pandas and NumPy. And advanced Python is all about this, and a lot more things. Let us see. In machine learning and artificial intelligence, Python is the undisputed leader in AI and machine learning development, trusted by tech giants worldwide. If AI is the future, Python is the engine driving it. All the major innovations you hear about: self driving cars, advanced image recognition, and powerful language models rely on Python. Frameworks like TensorFlow and PyTorch. So TensorFlow is from Google, and PyTorch is from Meta. Meta, the Facebook. They are, they are using Python to provide the user interface. This is what allows you to build algorithms. Also, if you have seen Netflix recommendations, so the image recognition systems and the predictive analysis that Netflix does, so it is also done using Python. So the Netflix recommendation system is based on Python, right? So as you can see, Python is used in majorly places worldwide. So web development backend powerhouse. Python handles the backend server side logic of dynamic websites, right? Uh, Here we have to see these two things: Django and Flask. So, as you know that Python is a fantastic language for building the web. It operates on the backend, the server side handling user accounts, databases, and application logic. We have two famous frameworks, Django and Flask. So Django, which is a comprehensive, full-featured system for larger sites, and Flask, which is lightweight, minimal framework, and great for just getting started. And yes, major sites you use like Instagram, Spotify, Pinterest rely heavily on Python, so to operate their services, right? So these all are your daily use, and Python is being used on them. Now let us talk about Python for automation and scripting. So Python's original use case is what? Writing simple scripts to automate complex or tedious tasks. So what is our goal? Our goal is to increase the efficiency by eliminating manual and repetitive work that wastes our valuable time. So this is the often the entry point for many programmers. Python is exceptionally good at automation. If you have a task that is tedious, repetitive, or takes a long time, you can probably write a small Python script to do it in seconds. Think about renaming thousands of files, automatically fetching data from a site. We call it web scraping, or managing a complex system administration tasks. Python turns hours of manual work into a few lines of code. So these are our common use cases, right? This is so for automation, Python is great. Now let us talk about cybersecurity and testing. So Python's clear syntax and extensive library make it go-to choice for security professionals worldwide, be it network analysis, penetration testing, or security monitoring. Everywhere Python is used, right? Now in game development and prototyping also, this pygame library helps you to create functional 2D games and interactive prototypes quickly and efficiently, perfect for learning game logic and mechanics before transitioning to more specialized development tools, right? So we usually use C++ or C for AAA games, but Python is perfect for prototyping the idea for 2D games. So this pygame library is very useful. Now, let us talk about who uses Python. Let us see some global examples. This list should solidify Python's importance. Companies across every industry trust Python. Google uses it everywhere, right from their search engine to cloud services. NASA relies on it for their scientific calculations and equipment control. Netflix. Netflix uses it to run their recommendation system and the entire file sharing service. Dropbox was built almost entirely with Python. When you learn this language, you are learning a skill that is used by the most influential tech organizations in the world, right? Now let us talk about Python's secret ingredient, the ecosystem, right? So first is the standard library. So it has a huge standard library. Thousands of functions are already built into the language, so you don't have to code it yourself. Second, it is open source, meaning a global community of developers constantly improves it, creating new tools and making it better every day. Finally, it's great at integration, acting as a glue that connects various software companies, even those written in older languages like C or C++ or Java. Now, here's a key takeaway: Python is a glue language. Focus on solving problems, not just syntax struggles, right? So Python allows developers to focus on solving the actual problem rather than getting bogged down with complex confusing syntax. So we will be writing code in our next lecture. Next lecture we will be installing all the softwares. So see, Python is very simple language to write, unlike C++ or Java, which has a very complex syntax. Python is very easy and and very, like, it is almost like English. Anyone who knows English will very quickly adapt to Python because it is almost English, right? Now, next up, getting ready to code. Next lecture, as I told you, we will be installing and set up our IDEs, like Visual Studio Code for optimal development, and we will also do hands-on preparation. Also, all the slide material you'll be getting in this with this all the lectures, and you can download the slides and you can study from it. And I'll meet you in the next lecture and we will be installing the IDEs. Welcome back, everyone. In the last lecture, we talked about the exciting things Python can do. Today, we turn that motivation into action by preparing our computer. This lecture is all about installing the IDEs and how to do our technical setup. So it is very crucial. So we need to install the Python interpreter, which runs the code, and set up our professional editing tool, the integrated development environment, or the IDE. The full form of this IDE is integrated development environment, right? Now let us talk about why an IDE, integrated development environment, right? So the reality check. You could write Python in a notepad, but an IDE is essential for serious development. What is IDE, this integrated development environment? If you have heard of VS Code, Visual Studio Codes, that is an IDE. So what happens is that beginners try to code in a plain text editor. While possible, it's painful. We use an IDE because it is a specialized tool built for programmers. It helps us with things like syntax highlighting, which colors are code to make it readable, auto completion, and most importantly, simple debugging and running our programs, right? So these are the key benefits. We can highlight our code gets auto completed. Also, we have easy debugging tools and simple program execution with one click, right? Now, what is our choice? Our choice is obviously the industry standard, the VS Code or Visual Studio Code. It is absolutely industry standard right now for Python. Why? Because it's free, it's lightweight, and it has incredible support for Python through its powerful extension system. Now, what we can do? We can first install Python the official way. So, how do we have to install it? We have to visit this site python.org/downloads. Choose your operating system, and we have to download it. Right? Uh, I'll just show you over here in my laptop. What we have to do? We have to go and search python.org. Once we search python.org, we have to go to downloads. Now, what kind depends? It depends which computer are you using. Is it a Mac? Is it a Windows, or is it a Linux? So since my it is Mac, so I will select Mac OS, and I will see the stable releases and the latest one. Like this is the one 3.14.0. It was released on October 7, 2025. So I will click on this, and it will, what will happen, um, here it will download it. Since I already have Python in my laptop, I won't download this, but you need to download it from here, right? So what will happen after downloading? You have to select first whether it is Windows, Mac OS, or then you have to allow everything, and you can just install it easily. Oh, come on, you guys are programmers. You are guys going to be programmers, so you could easily install this. We will not be coding on this because this is not good. So let us see if you are installing it in Windows. So this is essential. What you have to do while running the installer, look at the screen very carefully. You must check the box that says add python.exe to the path, right? So these are the installation steps. Then you can run the installer, right? And you can see, and you can also check if you have installed python correctly or not. Be it your, if you have, Mac OS or Linux, for this you need to open the terminal, or if you are using Windows, you need to open command prompt. Then you have to type this python hyphen hyphen version, right? And then you have to check the output. So since if we have installed 3.14, so you will get something like 3.14.0, something like this in Python, right? You will get a result like this. So this is the standard way you could install Python. And there are two things in this Python: shell mode and script mode. So what happens is that I'll tell you the basic difference, just so that you know that. So basically what happens is that in shell mode, you could write only just a single line, and when you press enter, the code will run, right? And in the script mode, you could write long lines of code, and then you could run all those lines at once. So this is the basic difference. We have nothing to do with it, but since it's a Python course and you should know little bit of the theory about it, so I just told you for that. Now download you could download for you could download the Visual Code. Visual Code is like the best. So what you need to do, you need to go to your laptop and search for VS Code download. When you will search VS Code download, here it, this download Visual Code, it will come. And for Mac, depending upon if you have Intel chip or Apple Silicon chip, you could start your download from here. Then what you could do, you could download the installer, like very simply, it's very easy. And then you could run installation. As I told you, you guys are going to be programmers, and I expect you that you could just download VS Code from it, right? Now what you have to do, once you have installed Python, so VS Code would open like this. Not exactly like this, but let's say you will get an option of new and open a file. Since I have already opened this Python folder where we will be coding, so just create a new folder in your laptop and open this. What you have to do, first you have to go to this part, extensions. Here you have to search for Python, right? Once you search for Python, what will happen, you will get this Python environment manager, or you could use this Python extension pack. So here I have already installed it. You will get an option of installing Python. You could install the Python extension, right? First you have to store this, and then you can create a folder. This is our second step in VS Code, creating a course folder. So every project needs a home, and create in a Python course folder, and you could open in VS Code, or you could directly create a new folder in VS Code. It will be stored in your laptop. It's vice versa, right? So our setup is almost ready. And what you can do, once your folder will be created like this, you could click here and create a new file, and you could name it any, like python dot. And you have to take care that you have to name it properly. So it will be like hello.py. So the extension must be of every Python file. Like for Excel we use some extension, for Microsoft Word we use some extension, for every kind of file. For example, any video that is mp4, so we use .mp4, like etc etc. So Python file has an extension of .py. So every Python file you store should be stored with .py extension. I will write it over here. It must be .py extension must be used, right? Now since we have this, so what we can do, we could just create a file, and I'll just rename this file to hello.py. So my Python file is created, and yeah, hello.py. So this Python file is created, right? So we could also check and write our first code. So we could write like this. The syntax is very simple. We will write print, and then we will put two brackets. Don't worry, we will discuss the syntax, like how we have to write. Just we have to check setup completed, right? And if we run this file from here, so we have whatever we have written inside these bracket and inverted commas, we have got it here, setup completed. I'll just increase the size, right? So this is how we could write our Python code, and setup is completed. Now you could also select the interpreter. That's really not important. It will run automatically on our terminal, right? So this was the recap of our steps, that you have installed Python interpreter from Python origin, and you have verified the Python version. You have also installed VS Code, and you have added Python extension and created the folder, right? Um if you are troubleshooting the path error, if you are having any error, what you could do in today's world, you could just chat gpt it and solve your problem like very easily in 2 minutes, right? So now you are ready for Python development, and since you have a Python interpreter, we you have an professional IDE. So in next lecture, we'll be creating our hello.py file and dive into basic Python syntax, and we will be writing, or we have already today written our first code. So that's great. That's great to start. And I'll meet you in the next lecture, and let's begin our Python journey. Welcome back. In our last lecture, we completed the crucial setup. Now we move from preparation to action. Today is a milestone, and we are going to write, save, and successfully execute our very first Python program. Uh, Obviously, it's not our first Python program. We have already, checked the Python program in the last lecture. Today is a milestone. Now, this final step confirms that your Python interpreter and your VS Code editor are talking perfectly to each other, like in last lecture we did setup completed. So your environment is ready, and today we are ready to execute. You will write first functional program, and you will be confirming the connection. Let's go. So let us review. You have all these three things, and you will be storing files with the extension .py files. You have to be very careful with this. Sometimes what happens, students write complete code, and then they forget to add this extension .py files. So you have to take care of this. Now the first or very first function, the print function, your first command, um, what it does, the print function is Python's built-in command for displaying output to the screen, to the console. Whatever you place inside this parenthesis, basically these bracket in coding we called parenthesis, right? Um, Whatever you place inside this will appear as a text output when you run the program, right? So what happens is that it is like the simple. If we write here in print statement, since we are writing a string, so we will use this hello world, right? And now if I run it, we will get the output hello world, whatever we place inside this. So if we I am using characters, I have to make sure that I have to use double inverted commas. So this is our string, and we will be learning about all the data types. For now you can understand like this: there are numbers and strings. For numbers, if we have to write any number, what we have to do, we don't have to put these inverted commas. We could directly write print 30, and so it will print 30. So the basic difference is that if we are printing numbers, so we don't need to use double inverted commas. We can also use them, but those numbers will be printed as text. And if we are using characters, which we call strings, so we have to make sure that we use double inverted commas. Now let us study the anatomy of the command. We have to see the function name, print. This tells Python which action to perform, right? And then the parenthesis, this, and this the then the argument, whatever we write here, like if we write print, then we put parentheses and double inverted commas. Mm, if we write print and then we put parentheses and here we write hello world and then we close it and like this. So what happens is that the print is the function name, the parenthesis and then the argument. So argument, since it is a string, so we are write it in double inverted commas. Else for number we could just skip those double inverted commas, right? So we have already written this code. You could open the file and type exactly this code. So what you have to do, since I told you that sorry, since I told you that Python is or any programming language, what you have to do, you have to code it yourself along with I teach. Else it will be very difficult for you at the end to code by yourself, right? So you should write the code first and do exactly what I'm saying. You could use any of this print command. You could experiment also, write anything else and you can yeah, you can write your name that will be printed, right? Now second step, you have need to save the file. In VS Code the file automatically saves, automatically, but it is a critical step. You could put command S on Mac keyboard shortcuts and there will be a visual indicator whether the file is saved or not. Now you could run from VS Code, which is an easy way. The run method, we have already done this, and the output, the result in the terminal, whatever you write, you will get the output, right? So this is how it happens, and we have already seen in our terminal that we are getting the output. What you could do, you could also run from terminal. You could write Python and your file name, but we will be skipping this method because this is just a method, but we don't generally use it in the industry, right? So this was the deconstructing terminal command. We are skipping this, and now common error one, there could be syntax error, any kind of error. For example, you have written print, and when you start you have added double inverted commas, but while ending you forgot to add those double inverted commas. So this will be an error and this will give you an error. So sometimes you have to take care of this also. Let us see the common error 2, name error. Name error, the print is not defined, right? The error occurs when you capitalize function names incorrectly. For example, you can see if you write capital P and like this is wrong. We have to write small p, right? uh, Python commands must be in lowercase, exactly they are defined in language. So it is a case sensitive language, right? Python is a, let me write it here, it is a case sensitive language. Case sensitive means what? Case sensitive means for Python capital A is different and small a is different. These both are different, right? So you have to take care and always write small p, like print function, right? If you write capital P, that will be wrong. Now let us see. We have already seen the case sensitivity, the fundamental rule. What happens is that if you write my variable and here v is capital and here v is small, these are two completely separate things, and this applies everywhere. It is the golden rule: use commands exactly as they are defined, no creative spelling or capitalization allowed. Now what if you need to write comments? How will you write comments? Now what happens is that sometimes codes are like really long, like thousands of lines of code, and mostly teams are working on big projects. So what happens is that if you are writing a code and anyone else on the team wants to read your code or understand the code, how will they understand the code? For example, if you are using variables or if you are naming something, you are writing in short form, how will the other guy understand? For example, if you have written a is equal to 5, now what is 5? You have used a variable a is equal to 5 like we use in mathematics. So it will be really difficult for anyone else to understand what is a. So there we add our comments. So comments are basically, comment is a line of code that Python interpreter completely ignores. We use them to leave notes for ourselves or for other programmers who might read our code later. To create a comment, you just need to start with this hash thing, right? I will show you here. For example, if I write print 30 over here, then I put a hash and write this is a comment. So as you can see, it is coming in green color and this is a comment. If I run it over again, the second line will be completely ignored, right? It will be completely ignored. This you can write in line comments over here, right? And if you need to write like multiple lines of comment, what you can do, so you could do like this. You could write three inverted commas over here, and you could use three triple quotes over here. In older versions of Python, this wasn't like Python does not much allow much multiple line comments, but now you can write multi-line comment in Python. You could use these three single quotes, triple single quotes, and you could write any of the multi-line comment, right? Now you could use comments effectively. So as you can see, the best practice is you need to explain the why behind your code, not what the code does, right? You have to explain why, and you also need to think of others. How will they understand your code? So for them. Now let us talk about the key takeaway execution flow. First, sequential execution. The Python interpreter reads and executes your commands from top to bottom, one line at a time. Then it complete each step at a time. Each print command runs completely and finishes before interpreter moves to next line. So each line is executed one by one in Python, right? Predictable order. The sequentially flow means your output will appear in the same order you wrote the commands. So in some other languages, what usually happens is that if you line 10 lines of code, so what will happen, for example, if I write 10 lines of code over here, some multiple lines, so all this code will be compiled first and then it will go to in the interpreter. And now for example, if I have a error over here in this line, the whole code will be it will give an error. Whereas in Python, first this line will be executed, then this line will be executed, then this line will be executed. If by chance I have an error in this code, so it will give me an error and the code will stop over here. So it is efficient, as it executes line by line, and wherever there it is an error, it stops. For example, if there is 1,000 line of code and there is an error in the second line of code, then it's like great if it stops at the second line. Else time will be wasted in big code. First it will get compiled, then it will go to the interpreter, and then if it gives error, it will be very loss of time or valuable time. Now congratulations, you have written your first program, uh, and you have understood the basic syntax. So next lecture will be errors and debugging, basics, essential skills. And from the next section onwards, we'll be studying Python from basic, all the variables, data types, and then we will be moving forward to advanced core of Python. So this was it for this lecture, and you have successfully written and executed your very first code. You have understood this print statement, print function, basic execution flow, and how Python processes your instructions. Now be ready for more. Next lecture is our errors, and from next section onwards, we'll be doing all the variables and data types, right? And all the basic things about Python from the next section. So I'll see you in the next lecture. Thank you. Welcome back. In our last lecture, we successfully wrote and ran our first program. Today, we tackle the most crucial skill in programming, debugging. If you get one thing from this lesson, let it be errors are not failures. They are necessary built-in communication tools. The computer is giving you a clue about what's wrong, and a good programmer learns to read those clues. There are two main types of errors we will see. The first one is syntax errors, and the another one is runtime errors. So syntax error means that mistakes in rules of the language, like grammar errors in writing. Python can't even run your code. And runtime errors, what happens is that code runs initially, but something goes wrong during execution. The program stops abruptly with an exception. So these are two main types of errors: syntax error and runtime errors. So syntax error, if you can't write your Python language properly, so it will be runtime error. And in oh sorry, it will be syntax error. And in runtime error, your syntax will be correct, but there will be some exception, and it will crash. Sometimes it will not work. So let us understand syntax errors first. What are they? Violation of Python's formal structure, missing colons, incorrect quotation marks, or improper indentation. Right. For example, if you are writing like this print, and here you forget closing of the double quotes, so it is an error. So this is an syntax error. Or if you use like capital P, like I told you in the last lecture, this is wrong. You always need to use small p, because Python is case sensitive, right? Next, what we can see, the missing parenthesis. If we write just print hello without these, it will give me an error. It will give me an syntax error. Why? Because it will give me missing parenthesis in call to print. And how we can fix it? We can fix it like this: print hello. We can also see like what will happen if I write over here. Like for example, if I use capital P first and I write print hello, will it run? No, it will give me an error because it is giving me an name error. If I fix this, if I put small p, it will run. It will give me output hello, right? Now, um, if I forget this, so VS Code C, the beauty of VS Code is that it gives me here only that we are having an error. You can see the red line which is underlined in hello. It is telling me that there is some error in the code. Whereas if you write in notepad or somewhere, you won't even know where is the error, and you'll just run it and you'll encounter any error. Sometimes unintentionally, or you just forget something, so this will give me an error. See, this is giving me a syntax error: undetermined string literal. This is what happens, right? Now, indentation error. If I give space in front of the print, indentation means leaving four spaces. We will study about indentation in loops, or in like control flow and logic statements, what indentation means. But print has to be begin from the very first character. If I write a print somewhere in between the line, it will give me an error. See, first there is an indentation error because I have left space over here. But if I fix the space over here and I also add this, so it will perfectly work, right? So let's come back to our slides and see, this is incorrect indentation, this was wrong, and this is correct. So indentation is very critical in Python. Every space and tabs matter for proper code structure. So the first column must the Python code must be started from the very first column. Right, now let us understand runtime errors, which are exceptions. Your code is syntactically correct, but an issue arises when Python tries to execute a specific action, right? So Python's response provides a traceback, a detailed history of what happened when the error occurred. So runtime errors are different. They occur after Python starts running the code, and often they happen because of the mistake in logic or data handling. When a runtime error occurs, the code will halt abruptly, and Python prints something called a traceback, which is a history of crash, right? Like it could be a name error, as I have already shown you. If I use capital P in this print statement, so it will give me name error. It is a name error, and you could fix, you have to write like this is wrong, right? Because why? Because this is case sensitive. Now type error, let us see a preview. The problematic code is what? Print hello plus 5. So hello is a string, right? It is a string, and 5 is a number. It is an integer, so both cannot be added. Like 5 plus 10 could be 15, but 5 plus a, what will be? We can't add any letter or word to a number, right? That's basic logic. So it will give me a type error. Text and number cannot be added, they are incompatible types, right? Now we have to read the traceback. You have to start from the bottom, you have to do the last line analysis and the line above it. What went wrong? You just have to find in these errors what went wrong. Right now, the basic debugging strategy: first you have to read the error, which type of error is that, syntax, name, type, etc., and carefully read the description Python provides. It gives you like where the error is. You have to identify the type and the description. Second, find the line. Use the line number provided in the traceback to locate problematic code, right? And step 3 will be check your code. Compare your code against the correct syntax and logic. And finally, the fourth step: isolate and test. If you can't find the bug, comment out large chunks of code until the error disappears. Then zoom in on the last piece you commented out, right? So you could isolate and test. You could just delete some of the part and run, then delete some of the part and run. You could do that also. Now debugging in VS Code, the stop sign. So basically, red underlines, as I made you saw in VS Code, the red line like this, it comes, when you write some text. So this is red line. Red circle icon appears next to the line number to flag exactly where the line is detected, right? And hover for ends. If you move your mouse, so it will tell you where the error is. And nowadays, since ChatGPT came, after that GitHub Copilot came, and GitHub Copilot is like AI in coding. It completes your code automatically, like not the VS Code auto completion, it writes your whole code. So that's like crazy, but we are not using that initially because our purpose is to learn Python properly. Else ChatGPT could give like the whole code whatever we ask for, but we need to learn the language, we need to understand it, because if we need to develop AI, we need Python and we should know coding. That developing of any AI, Python won't give us. So we have to learn the language. Now talking about the power of print in debugging. So you could do the progress tracking. Let's just skip this. This is not important. Python is literal, not smart. Python doesn't try to guess what you meant to do, right? You need to understand this. Python doesn't try to guess what you meant to do. It only executes what you wrote, following its rules rigidly. So print capital P and small p are not same. You need to clear that. You have to mind your spacing and indentation and check every punctuation mark carefully, right? Now the typo trap. Sometimes what you do, uh, print the word Python correctly. If you write something like this, there will be no error, but typos can't be fixed. You must write your output yourself. Now the final debugging mantra: computer is always right about the error message it provides. Programmer is responsible for interpreting and fixing the code. Practice makes perfect, right? The computer is always right. Machines don't make mistakes. We have to take all our responsibility if we get an error in our code, that we must have written it wrong. Right? So debugging is twice as hard as writing the code in the first place. This is a very famous code and you will remember this. So if Trust me, finding errors and fixing errors is much like difficult. Instead, you could write code from scratch and run it. So section 1, we have completed section 1. Congratulations, it's a wrap up. And now in the next section we will be studying Python fundamentals, and in the first lecture of section 2 we will be deep diving into variables and data types. These are like the building blocks, the basic of Python, right? So I'm excited for section 2 and I'll see you over there. Thank you. Welcome back, everyone. You have successfully completed section 1. You have got your environment set up and you know how to debug. Now we dive into section 2, which is Python fundamentals. This is where we build your core understanding of how programming works, what is programming, logic, and flow of execution. Today we focus on philosophy behind programming, what a program really is, and how its instructions are executed. So, what is a computer program? A computer program is simply a set of instructions given to a computer. These instructions tell the computer exactly what to do and when to do. Um, let's take an analogy. Think of it like a recipe book. The recipes, the programs contain detailed steps, instructions for the chef computer who follows. Right? So you simply put a computer program is just a set of instructions. Think of it, like a very detailed manual you give to a worker. These instructions tell the computer exactly what action to perform and the precise order in which to perform. And the best analogy is the recipe book, right? Uh, So, what is the role of computer? Computers are incredibly fast, but they are fundamentally lacking intuition. They have no common sense or ability to fill in gaps. But now AI is coming and they are able to fill those gaps. Now, golden rule, you must be 100% precise in every single instruction you give to a computer. Computers never go wrong. They have zero common sense. If you tell a computer to go left, it won't stop to ask, is there a wall there? It will just go left. Therefore, the single most important rule in programming is that you must be 100% precise in every instruction, right? Now, there are two things, typing and programming. So, simply entering text into a document or word processor. Programming is basically creating logical instructions that solves a specific problem through sequenced commands. Programming isn't about typing skills, it's about logical thinking, right? So anyone can type a recipe, but programming is about designing the whole logical sequence that solves a problem. It is the difference between writing down words and arranging those words into commands that successfully manipulate data and resource to achieve a specific goal. Another core concept, logic. Programming is applied logic. Logic is what a set of principles that govern reasoning and systematic problem solving. Also, the translation process. We translate our desired real world process into step by step logic path that computer can follow. Right. Now, we could take a real world logic example, like for example, getting coffee. Let's look at a simple everyday example. If you want coffee, you don't just say make coffee, you apply logic. Is the pot empty? That's a decision point. If the answer is yes, you follow follow a instruction A, that start brewing. If the answer is no, you follow instruction set B, pour, right? For example, if we have a coffee pot, as you can see over here, so first we have to check if this is empty or not. If this is empty, then we will brew fresh coffee. If the pot is already full, then what? Then we will just, um, we will first empty the pot, first empty the existing coffee, and then we will make another coffee, right? Okay. Uh, Now let's talk about the next thing, that is flow of execution, top to bottom. So, sequential programming, just a second. Yeah, thanks. Flow of execution, top to bottom. First is the sequential processing, the basic way Python run code is sequentially. In Python, the basic way a program runs is called flow of execution. By default, the flow is sequential. Python starts with first line and then executes that instruction, then moves directly to the second line, executes it, and so on until it reaches end of the line, top to bottom, line by line. So for example, there are multiple lines of code. First it will go here and then it will go down, right? This is the default behavior. Now let us see the example of sequential flow. For example, if we type these three statements over here, that is get out of bed, brush teeth, and go to kitchen. So the output will be like this. We can check also. Let's start typing. So we will write print. Here we will write step 1, that is get out of bed. Right, this is our first statement. Second statement we will write, that is step 2, and that is brush teeth. And we'll type the third statement, print step 3, that is go, mm, that is go to kitchen, right? So if we write these three steps, these three print statements, and I told you you should also code along side by side. And now if we run this, so what will happen? It will print all these statements in the same order in which I printed it, right? So as we can see, each line executes completely before the next line runs. Now when flow changes, control structures, we will be studying this. We have a special dedicated section for this control flow statements, but for now we are just understanding the basic fundamentals. So we will study here conditionals and loops. So if statement are there, they skip or execute instruction based whether a condition is true or false. So if all programs run straight to bottom, they won't be very useful. Programs become powerful when we can change the flow, right? It's not necessarily that the program should go down like this. It could also go like first like this, then this, then this, then this, then this, then this, then this, if we can change the flow, right? So we could do this by control structures. For example, it happens like this. If we have to make a decision, so here is a decision making thing. If the program it if it says yes, so we will do this thing. If it says no, we will do this thing, right? Usually it's top to bottom, so yes for down one, and if it's no, we will go towards right. So this is the decision making point, right? So this is done on the basis of if statement. We'll just take a sneak peek of the if statement. So for example, has money. If someone has money and we have set it true, so if has money is true, print buy a coffee. So buy a coffee, this will only be executed if this is true. If this is false, this line won't be printed. uh, I will just show you over here, right? Now if I write here has money equals to true, right? And here I write in the next line, if has money, and then I put this, and when I press enter, now this line will be automatically indented. Indented means there will be four spaces, right? There will be four spaces. And if it is true, we have to like print buy a coffee, right? So this will only be executed by a coffee if this is true. Now if I run this, so it will give me buy a coffee. Now if I change this to false and if I run it, nothing will be printed. Why? Because this statement won't be executed. because this is false. So this is a decision making thing, right? Now let's see the algorithm, the programmer's plan, right? The programmer's plan is based out of two things: the algorithm and the program. So what happens is that an algorithm is the detailed step-by-step procedure used to solve a specific problem. Every successful program starts as a well thought out algorithm. So algorithm is very necessary. You must have heard data structures and algorithm, DSA, which is like very famous. And many company hires on the basis of the problem solving skills you have, and how these companies test your problem solving skills. They give you some algorithm questions, and you need to solve it, and they hire you. So before we write a single line of code, we first need to define an algorithm. An algorithm is the complete detailed step by step procedure, the conceptual plan used to solve a problem. The algorithm is the logic. The Python program is simply coded implementation of that logic. Never start coding before you have an algorithm or a plan. So you must have a definite algorithm, like what you have to do, and then algorithm is the logical plan and reasoning, and program is the coded implementation of that logic. Right. Now let us talk about the power of abstraction. What is abstraction? It is a key concept in programming. Abstraction, this means hiding complex details from the user. Think of like driving a car. You only interact with the steering wheel and the pedals, the essential functions. You don't need to know the physics of the engine, right? So in code we use functions to abstract complexity, allowing us to use command like print without knowing exactly how Python implemented it, right? So this is how abstraction works. Now, what does the interpreter do? I have already mentioned interpreter at a lot of times. So the Python interpreter takes your code, which is readable by humans, and translates it into low-level machine code, which is nothing but binary ones and zeros. The computer's central processor then executes this machine code very quickly. It's a two-step process: translation and execution. So basically, we can read English or any other language. We can write and understand Python, C++, or any other language, but the computer does not understand Python. Computer works on binary language. Binary language is what? Binary language is zeros and ones. So basically, if you have done something, for example, if I write any text over here, right? So computer does not read that text. It will convert into binary like 0 1 0 1 1 0 0, something like this, and then it will read it. For example, if I have to write 3, so 3 will be 0 1 0 1. This is binary code of the, sorry, it will be 0 0 1 1. 3 will be that. So we will not go here. How do we transform this binary to our normal decimal and decimal to binary? We are not going into that, but I'm just telling you that it works in binary, right? Okay, now let us talk about the key takeaway: precision and logic. So your job as a programmer is to define a precise logical step-by-step process. The default execution flow in Python is sequential, top to bottom, and we use control structures to deviate from that flow to build complex useful programs. Now there is a knowledge check. First question is that what is the default flow of execution in Python? It is sequential, top to bottom. The second question for the day is what type of structure allows code to be repeated multiple times? That is loops. And we will be studying in much detail. Next up, storing information. Next lecture will be variables and data types, and we will be learning how to label and store information inside our programs. So get ready to learn how programs can remember and manipulate data, and I'll see you in the next lecture. Thank you. Welcome back. We are diving into the first true building block of programming: variables, the program's memory. Today, we are going to explore how to store and remember information effectively. Now, the question of the hour: what is a variable? A named container designed to hold a single piece of data securely. If the computer is going to follow our instructions, it needs to store information like username, a score, or a price. A variable is a like simply it's a container, and whatever we name this container is our variable, and whatever we put inside this is what is it is its value, right? So um you can think of this analogy that the label represent its name and whatever inside is its value, right? Now let us understand how to create a variable. Defining a variable. So assignment operators magic. We utilize this assignment operator, which is equal to, and this is used to create and assign values effectively. The syntax is very clear: variable name is equal to value. For example, there is a variable x and its value is 10, so x is equal to 10, or maybe y is equal to 15, or we can write something like a is equal to some text in double inverted commas. This is how we can store some value in a variable, right? Now let us talk about the variable assignment example. The username is Alice, so our variable is holding a text data. Score is equal to 100, a variable holding a number data. Now we can also print this username, and we can also print score. So what you have to understand here is that Python automatically understands that Alice is text and 100 is a number. This intelligent behavior makes Python exceptionally beginner friendly while maintaining powerful functionality, right? So let me just show you too um, how you are going to do. Don't worry, we also have to do some how to name variable and the rules. So let's say username is equal to Alice, right? And next we are score is equal to 100. These are two things. Now if we want to print username, we can print username, and we also want to print score. Okay, so now if I run this function, so as you can see, first Alice is printed and then 100 is printed. This is how you can store any like text or number or alphanumerical things, and then you can print it. So this is how variables work. Now comes a very very important topic, that is variable naming rules. These are you know the basics, but the fundamental is really important. So Python has a few strict rules for naming variables. Your name must start with a letter or an underscore. The first rule, uh, whatever you name, like for example, if we write x is equal to 10, so here x is the variable name. We could also write something like student is equal to Bob. So student is a variable here, right? So function it must start with either a small letter or a capital letter or an underscore, right? We can write like this: name underscore count username, something like this. But the second rule, we cannot start the variable with a number like 101 underscore var is illegal. Python will throw a syntax error immediately, right? We can keep the rule something like az is equal to 10, but we cannot keep something like 1 oak is equal to 2. We can't do this, right? Now it cannot contain spaces, right? Username, we can't put spaces in between them. And also it cannot be a reserved Python keyword. For example, for now we have done the print function, or we have studied if, and there are for loop, while loops, so such words, the reserved keywords, we cannot use them, else they will throw an error, right? Now naming convention, snake case. Python's preferred style. In Python, the standard convention is snake case formatting. Words are lowercase and separated by underscores. This promotes readability and follows Python's course philosophy. For example, we write like this: customer age. Instead of writing like this customer and then we write age, we could also name like this, but instead we use customer and underscore age. We write like that. So this means snake case. Now let's move forward. So Python is dynamically typed, no type declaration. You don't need to specify the variables type when creating it. Python handles this automatically. What do we mean by this? We mean that this means when you create a variable, you don't have to tell Python, hey, this is the number. Python is smart enough to look at the value and say number 5 and automatically determine its data type is an integer. This saves us a lot of time and makes the code very readable. Uh, for example, if I show you in other languages, for example, in C++ or Java or any other language, we have to write like this: int x is equal to 10, like in C++. But in Python, we can directly write x is equal to 10. Python will understand that 10 is an integer, right? We don't have to write like this int x or string stry. We don't have to declare the type, right? So now let's move forward and talk about the data type 1, that is integers. So integers are whole numbers basically. For example, age is equal to 35, temperature is equal to -10, student count is equal to 150. Integers are used for whole numbers without any decimal points. They can represent both positive and negative values effectively. It is perfect for counting, indexing, and mathematical operations. Right? So you use these integers for things that cannot be divided, like age, count, or scores. So this is our first data type, and this is we don't have to declare that age is an integer here. It automatically understands that 35 is a number which is an integer, right? Now let us talk about the second data type, that is float. So float, these are used for numbers that contain a decimal point. The word float refers to the decimal point floating in the number. You use these for prices, measurements, or any calculation that needs decimal precision, like our pi example. So here, this is pi is equal to 3.14159. So since there is decimal, so it will be a floating number, right? Temperature is 36.8, so it is floating. So it is essential for calculations, and that's why we use float. Now the third data type comes is strings. Textual data powerhouse. String handle all textual data, including words, letters, sentences, and even symbols. So whatever you have to write, they must be enclosed in single quotes or in double quotes. Whatever you have to write, you have to write either between this or between this, right? Now there are some practical examples, like city is equal to London, greeting is equal to hello there, message is equal to welcome to Python programming, something like this. Now comes our fourth data type, that is bool. Bool is basically two things. It could be true or it could be false. It only tells us it is true or false. And sometimes in binary, for true, we have this value 1, and for false, we have this value 0. Just remember this, and we will be using this a lot at a lot of places, right? So it represents either true or false. So these are the fundamental units of decision making. A Boolean variable can only hold two values, true or false. And you must note in Python that true and false. So the T and F must be capital. The starting letter T and F must be capital. So is admin is equal to true, is empty is equal to false. We can write like this. This is the variable name and this is its value. So value can be of different data types. We are discussing those data types, right? Now next comes the type function, built-in detective. Python provides a powerful built-in function to check any variable's data type instantly. To reinforce this, If you ever need to confirm that what type of data is stored in a variable, you simply pass the variable name to its function and Python will tell you. For example, we have something like this: age is equal to 10, and then I write type age. So it will return me, the output will be for this, it is integer, right? So this is how you can do. So it is also a debugging tool, invaluable or for troubleshooting and understanding your data, right? This is how we could do this. Now you can see the type function example. What will happen here? My data, it is 25.5. So as we have discussed that this is decimal, so this output will be what? It is a floating value, so it will be a float. And this is true. Now print type is logged in. True is what? It is a bool data type, so it is boolean, right? It is boolean. And then we have Alice. What is Alice? It is a string, right? Like we have studied over here, we can also write the strings, right? Any text. So this is how what type function happens. Now let us talk about the variable reassignment. For example, we have this value x is equal to 5, and in the next line we write x is equal to x plus 1, right? For example, see, in memory what happens is that we have this block in memory, and this is named as x. So now if I write here x is equal to 5, so 5 value gets stored in the x container. In the next line, if I write x is equal to x plus 1, so what will happen? 5 will be erased uh, from that, and in this box what will happen? 5 plus 1 is 6, so now it will be 6. Now if I write here x is equal to hello, so now 6 will be removed and hello will be written as value, right? So this is how we could reassign it. Now if I print over here, print x, so my output will be hello. So we could reassign also. I would also like to show you some examples also for data types, like age is 10 and capital age is 15. These both are different. So if I print here age, and if I print here print age, so these are both different things. So as you can see, it is 10 and 15, so it is dynamically typed. That's why it is giving like this. Now if I want to show you this example, x is equal to 5, and then I write x is equal to x plus 1, then I write x is equal to hello. Now if I want to print x, so it will give me the output as hello. So we can also reassign this variable also into different data types. Like from integer, we converted it into string. Now let's move forward. And there is a practical use case of swapping the values. So let me just show you this also. For example, we have this value a is equal to 10 and b is equal to 20. These are two values, right? Now if I print over here, print a and then print b. Now if I swap these values, it means a is comma b will be equal to b comma a. If I do this, and now if I print a and b, the values will be swapped, right? um, so if I run this, so first the value of a is 10 and 20, and then it is 20 and 10, right? So this is how it happens. Now let's see the key concept, that is memory allocation. So we have to understand this core concept of memory reservation and naming to address mapping, value storage, automatic management. So memory allocation, just to clarify what's happening behind the scenes when you create a variable. Python allocates a small piece of your computer's memory. The name you choose, like score, acts as a label pointing to that specific memory address. When you reassign the variable, the name just points to the new value, potentially new spot in memory. So what happens is that, for example, in our memory, there could be something like this, and it would have a random number like 2145, something like this. And if I have x, so x will be pointing to this memory number, and if I write x is equal to 10, so 10 will be stored here. Now if I change later that now x is equal to 15, so what will happen? Most probably there will be a new memory, which would be maybe 2147, and now x will be pointing to this and 15 will be stored over here, right? This is what we are trying to do in memory allocation, right? Okay. So I hope you would have understood variables and data types. What are the variable naming rules? You have to be very careful with the case sensitive ones. So let us review our core data types, that is int, float, string, bool. Int is whole numbers, these are decimal numbers, string is text data, and bool is logic or false logic, right? And next we have a very important lecture, that is operations on data. Variables are just the beginning, right? They are great for storing the data, but a program needs to do things with data. In our next lecture, we will learn how to manipulate these variables using operators. We will cover math operations, compression checks, and logical statements. Great job today mastering variables, right? So get ready to bring your variables to life with powerful operations. So these are all the type of operations we will be doing in next lecture, and I'll see you over there. Thank you. Welcome back. In our last lecture, we learned how to store data using variables and identified the four core data types. Variables are useful, but a program is defined by the actions it performs on that data. Today, we learn about operators. An operator is a special symbol like a plus sign or an equal sign that tells Python interpreter to perform a specific mathematical or logical action. Arithmetic operator, right? And there are various kinds of operators. So operators actions on data, so it helps in data storage mastery, taking action, and we'll be now seeing what's an operator. So arithmetic operator, the mathematical foundation. Purpose: perform basic mathematical calculations on numeric data types. See, the core operators are these: plus, minus, multiply, divide, and there we have modulus, this, and this. I'll explain you all these types. What are they? So you must be knowing the basic four: addition, subtraction, multiplication, and division. We will also be discussing these three operators over here. So as you can see, addition is simple: 5 plus 3 is 8, 10 minus 4 is 6, that is subtraction, 2 into 6 multiplication, that is 12, and 10 divided by 3, it will be 3.333, and it will be a float value, right? If we divide 10 by 3, so it will be 3.333. Now let us talk about the advanced arithmetic operators. These operators provide more sophisticated mathematical operations beyond basic arithmetic, right? Now, the modulus operators give you the remainder of a division. This modulus operator gives you remainder. For example, if we divide 3, so it will be 3, 9, and 1 will be remainder, right? So modulus operator give me the remainder. So 10 modulus 3 will give me 1 remainder, right? Now there comes floor division, that is this 10 floor will be 3 integer division, right? So when we used to divide 10 divided by 3, so it used to give us 3.333. That was a float value, right? But if we do 10 floor division, so it will only give me 3. Floor is basically, if I a floor of anything, if I write something like 3.333, floor of this will be only this number, and this part we have to reject this. So floor of this will be 3. Or let's say if you want to calculate the floor of 2.5, so for 2.5 it will be only this number, that is 2, right? So this is how it works. And these are all the modulus operators and floor division. Now the two double stars that is used for exponentation. For example, if we have to write 2 raised to the power 3, so how will we write in our computer? So we will write like this: 2, we will use the multiply symbol 2 times, so this means 2 raised to the power 3, right? So these are the three advanced arithmetic operators which we use. Now let's move forward, and here's the assignment operator. Efficient variable modification, small shortcuts. These operators combine an arithmetic operation with variable assignment. Right? We can store using this is equal to sign. They combine the arithmetic operation and the assignment operator into a single clean symbol. This is very common in professional code. Now there are some assignment operator examples. For example, the shortcut, we can see the shortcut. Instead of writing x is equal to x plus 5, we can directly write x plus is equal to 5. This is same as x is equal to x plus 5. So we can use any of the assignment operator like this, be it addition, subtraction, multiplication, or division. If you want to perform the operation on the same number, like we are not doing something like this, x is equal to y plus 5, right? If these both are numbers are same, for example, if you want to do x is equal to x plus 5, so we can write like this: x plus is equal to 5. So first we have to write the operator, and then we have to write the assignment operator. These two we will use, and we have a shortcut to write this. This will be used in many places, right? Now let us see the comparison operators. Comparison operators, why we use comparison operators? These operators compare two values and always return a boolean value, that is true or false. Right. This is a program how your program asks a question like, is the user logged in, or is the score greater than 100? These are the question it asks, and then it returns, is it true or false? So the very common example, that is equals to, we have these two equals to. So 5 equal to is true, right? And exclamatory mark and equal to is not equal to. 10 not equal to 5, right? 10 is not equal to 5. 10 and 5 are two different numbers, so the result is true. Now we have this greater than symbol. Now here we have written 7 greater than 9. Is 7 greater than 9? No, 7 is a smaller number than 9, so it will return false. Now similarly, less than, is 5 less than 8? Yes, 5 is a smaller number than 8, so it is true. So these are some comparison examples. Now there are some compound comparison operators also, which is greater than or equal to. X is greater than equal to 10. True if x is equal to 10, right? For example, if I x is greater than equal to 10. If x is equal to 10, then it is also true. If x is equal to 11, then it is also true, right? Now similarly, we can solve for less than or equal to 2. Y is less than equal to 5. False if y is equal to 5. Y has to be either 5 or smaller than 5, right? So this is just basic maths. And now comes our logical operators, that is combining multiple conditions. The purpose for these logical operators is to use to combine multiple boolean expressions, true or false, in complex conditions. There are three operators which are and, or, not. These are three operators, you must remember them: and, or, and, not, right? Now let us talk about and operator. So and operator, it returns true only if both the conditions are true, right? So we can also create a table for this. For example, here we write the first, the second, and here we have the result. Now if both are true, the result will be true. If one is true and two is false, the result will be false, because for the result both has to be true, right? And if one is false, two is true, then also it is false. And if one is false and second is false, then it is also false. So it is only true in one condition, when both these are true, right? So age is greater than 18 and has id is also is equal to true, then it will, the result will be true. If either this or either this, any of this is false, then it will return false, as we can see this table over here, right? Now let us talk about or operator, the flexible one, right? Is a student or is senior. If at least one condition is true, it is true. For example, if I write over here like this, I'll make the same table for first, second, and some result. If both are true, the result is going to be true. If one is true, two is false, it is still going to be true because it is saying at least one, right? If one is false, second is true, it is going to be true again. If both are false, then only or will be false. So or operator, if we use like this, so one is this and two is this, and this is the table. You can see what will be the output, right? Now let's move forward to not operator. So not operator is the reverser, the negation operator that simply reverses any boolean value. Example, not is raining reserves the value of is raining. Logic, is raining is true and not raining becomes false, right? So not is a simple negation. If is raining is true, then not raining must be false. If for example, we can check if it is logged in or it is not logged in, right? Now let us talk about some operator precedence. How you must follow the operator order of operations. Just like in maths, like we used to follow BODMAS, Python follows order of operations like precedence. Multiplication always happen before addition, for instance. A good rule of thumb is to remember PEMDAS, right? PEMDAS is what? This is this triangle PEMDAS. When in doubt, use parentheses to force order you want. So this is the priority. First, you have to follow this parentheses, then exponents, then multiplication or division, then subtraction, addition, and then logical operators and or not. Right. Now, for example, we have this precedence in action, and without parentheses it is 10 plus 5 into 2. So first multiplication is to be happen, so 5 into 2 10, then 10 plus 10, the result will be 20, right? With forced order, what? As you can see, we have parentheses here, so 10 plus 5 will be 15 and 15 into 2 will be 30. So these are two different things. So this is without parentheses and this is with parentheses, right? Now let's move forward. The equality versus assignment trap. Assignment setting. Single equal sign x is equal to 5 stores the value 5 in variable x. And we can also check uh, if we have to check, so we have to use x is equal to 5. Here we are asking the computer if x is equal to 5, and if we write here x is equal to 5, so this means that we are assigning the value 5 to x. So students, make this critical mistake. Sometimes they use single equals to and mean double equals to. This causes bugs and that are hard to find, so you just need to take care of this, right? Now string operations preview. The next lecture is going to be like strings, and we are going to do operations on strings also. Concatenation, repetition, uh, right? We will be doing this. Currently we have achieved the strings, not the strings but the operators, and next we are going to do strings, all the indexing, slicing, etc, etc. For now you could just understand the basics. The addition in string is known as concatenation, first plus last. So if I concatenate two strings, so it will be first and last. For example, there are two words, let's say a is equal to first and B is equal to last. So now if I concatenate these two strings, this will be something like this: first, last, without any space, right? But and we can also repeat a word. So repetition, if word into three. If I write any word and I write, for example, if I write A into three, so first, three times it will be printed. Now there is also an example. If we write like this, hi plus a space plus there, so the output will be hi space there, right? So this is how strings work, and in the next lecture we'll be studying strings in detail. What we can do for this, right? So that's all for this lecture, and I'll see you in the next lecture, and we will study strings there. Thank you. Welcome back. We have successfully covered variables and operators. Today we dedicate our entire lecture to string data type, that is str, string. Right, strings are foundational because every program, from a single script to a complex web app, involves text, taking input from a user, displaying results, and formatting messages. Mastering strings is essential. Now let us see some string basics, defining the text. So we could also use single quotes for strings, and we could also use double quotes. If we use multi-line strings, we could also use like that. So we have to use triple quotes for longer text blocks, right? If you need like multiple lines and it preserves all the formatting, you use triple quotes like the example is shown over here. Now, multi-line string example. So this preserves, the entire text, like line breaks and spacing, exact formatting. This makes them perfect for longer messages, documentation, or preserving text structures, right? Now, we have also seen some string operations in the last lecture, which I would like to show you practically this time. The first one is concatenation. So if I write here greeting, and greeting is equal to first is hello, then we will add some space, and then we will write, then we will add, let's say, mm, world, right? So if I write like this, so it will be hello world, right? If I run this, and now if I want to print greeting, let's see what does this print. So we have got a syntax error. It's an invalid syntax. Okay, so the problem was that we were running that in the Python shell mode, and it was not selected as script mode. That why it was giving the problem. Rest the code is fine. So here we have printed the hello world like this. We could write like this, or now even we could directly write something like this, like greeting is equal to hello plus world, right? Now if I also run, so hello world will be there. Concatenation has no like spaces inbuilt. If we have to put spaces, will have to add spaces in it, right? Now let's take another example. For example, stars is equal to, for example, if I say this star is my string and then I want to print it 5 times, so I'll do this and I'll write print stars. Now if I print this, so 5 stars will be printed, right? So this is how it happens. Now let us get back to string indexing. Very, very important topic. Strings are ordered sequences where every character has a specific address called an index. So indexing always start at 0, the first character, and it is the index 0, not 1. You have to remember like this. So for example, we have this string which is Python. So you know what? Python will be divided like this. and it will be something like pi. So if I show you over here, so it will be something like Python, and this string indexing will be done. So string indexing begins with 0. So it will be here 0, 1, 2, 3, 4, 5. For example, sorry, if this is our word is Python. Now if I want to access any of the character, like the first character, which is Python, so I can write like this: word 0. This means what? This means P, right? If I write over here word 1, so it means it is Y. So every character has its own address, its own syntax, right? This is how indexing works in Python. Now you could also access the third character, like the third character word 2 gets T. Let me just show you also, demonstrate you live example. So word is equal to Python. Now if I want that first letter, here is word and then it is 0. So, and if I want to print first letter, so let's see, it will print P. Now if I change this to third, so the third index is what? 0, 1, 2 and 3. Third is H, so it will print H. This is how indexing is done for strings, right? Now let us move back and see if we have understood all this, how we can access the character and how we have do the indexing. Now we also have this negative indexing. So negative indexing starts at -1 for the last character and -2 for the second to last. For example, if I have to do negative uh, indexing for this one, so what I will have to do, so -1 starts over here. -1 will start here. Then this is -2 and this is -3. This is -3, this is -4, this is -5, and this is -6. This is how it works, right? So I hope you would understand. So -1 starts over here and then uh, it goes up to -6, like whatever the last number is. And here it starts. This is the positive indexing. This is the positive indexing, and the above one is negative indexing, right? So this is what happens. So indexing is done like this, and so you have understood positive and negative indexing. Now let's move forward. Negative indexing could be done like similarly. As I've shown you over here, Python from 0 to 5 and -1 to -6. Right. Now let us talk about the length function. That is returns string length. For example, hello, the length of hello is 5, and for example the length of Python is 6, so it will return like this, right? We could also use in some steps, like if I show you about the length function. For example, I have this word Python. Now I will write a is equal to length. A will contain length of the word, right? And if I want to print a, so Python is of 6 letters. So what happened first? Python is 6 letters. The length of this word Python is 6. So A has stored the value 6. Then I wanted to print A. So it has printed 6 over here, right? This is how it works. Now let us see about the string slicing. So string slicing extracts a portion substring from a larger string, like cutting a slice from a loaf of bread. So what happens is that the this is the syntax: string start end step. Slicing is non-inclusive of the end index, like whatever we write over here in the end is not inclusive. Right, let us see some example. For example, we have this name programming, and if we write 0 to 4, so it gets programming. So programming also is divided into indexes, like programming. So let me write the index number, that is 0, 1, 2, 3, 4, something like this, right? For and so on. Now, if I want this name to get like 0 from 0 to 4, and so the syntax was start, end, and stop. So stop, start, stop, and step. Sorry. So step is optional if we write, if we don't write. Start is also optional. So if we don't enter the value of start, so it will automatically take start value default as 0. So now if I write over here, so we will get only prog, PROG, that is 0 index, first index, second index, and third index. So fourth index is not included. We have to take care of this. So the substrings get this, but stops at 4, right? It's easy, and I hope you would have understood that. So syntax is start to end, includes the start character at start index is included, excludes end, and you have to stop before the character at end index. Now slicing defaults, you could slice it like name to 5 from start to index 4. We could do like this. We could also omit the end. So if we don't put the start value, so it will take index 0, and if we don't put the end value, it will assume that it will go to the end of the string. Now slicing with step. So if you want to take like every other character or something, so what we can do, the default step is 1, like we have to move one by one. But if we choose step 2, for example, if I have A, B, C, D, E, F, G, so the index number will be 1, 0, 1, 2, 3, 4, 5, 6. Now if I put here 0 to 6, and the step should be 2, so you know what will be printed? 0 will be printed. Then it will take 2 steps. So first step and then second step. So now we land here at C. So next will be C. Then again it will take 2 steps. Now it will land at E. And since now next we will be landing at 6, but 6 is not included. So only ACE will be printed. So the step is 2. We can also increase the step to 3, 4, or whatsoever. So this is how we could slice the string with steps. So this lecture is all about string slicing and string indexing. So as you can see, the word program, if we have 0 to 7, 0 is the start value, 7 is the end value, and 2 is the step value. So what will happen? First, it will take 2 steps from here. So P will be printed, then O will be printed, then 2 steps will again be taken, then R will be printed, then again 2 steps. This is 6th, but we have the end as 7, so we can go till 6, and then M will be printed. So as you can see, PORM is printed, right? So this is how PORM is printed. This selects characters at position 0, 2, 4, and 6, skipping every alternate character. This is how we do. So we could also, string reversal trick. What we can do, if we don't put the start value and the end value, so by default the start and end value will be same. And if we put step to -1, so what it will do, it will start from the backward and it will print it. Like for example, for Python, if we do, so it will be PYTOHON, but in the reversed order. So here we have also reversed the string. So this is one method to reverse the string, but we won't be using this method to reverse a string. It is just a method, right? Strings are immutable. Immutable means strings cannot be changed after creation. If you try to modify a character directly, Python will throw an error. Yeah. uh, you cannot change any other, like if you have a word like something like cat, so you cannot say I want change this C to B. You cannot do this. You have to create a new word with bat, but you cannot change a particular alphabet, right? So string are immutable, and if you try to change, it will throw an error. Now this is a great example, like the cat and the bat is made use of. And next, what we can do, immutability example, if this is cat, and what we can do, we can slice the string whatever we need, like A and T we need, so we'll start from 1 and it will go to the end. So AT we have selected, and then we have concatenated B to it, so now the string is bat. We can create a new string by combining B with a slice of original. This is how we can do. Next up is user interaction and IO. So in this lecture, we have learned how to work with and manipulate text strings in Python. We know how to print and display data to users. And the next challenge is that learning how to get data from users with the input function. For example, you must have seen when you use comments or you fill a form, so you enter your own details. So it accepts your details and prints it. So we will be seeing, and it also stores in its databases. So we will be seeing how this happens, right? And I'll see you in the next lecture. Thank you. Welcome back. In our previous lectures, we learned about variables, operators, and we have been using the print function to get information out of our program. Today, we close the loop by learning how to get information into the program from the user, making our applications truly interactive. So programs that talk back. So we'll master the input function and finalize our understanding of professional comments. So let's see the output review, the print function. The core purpose of print function serves program's voice, displaying the information from your code to the console where users can see it. It has a versatile display, right? And as you can see, you can print anything, you can show variable contents, you can print calculations. So print function is great. Now let's talk about the input function. It has an interactive pause, always returns text, and it has helpful prompts. For example, if you are filling up a form, the form asks you your name. So you enter your name over there, right? In Facebook, Instagram, Twitter, you write something. So you write something, input is taken by the user, and then it is printed over somewhere, right? Any of the Instagram comments, any of the tweet, and any of the post where you write, so input function is taken. So the key is that whenever the user that text is returned by the function and stored in your variable. Now this is a great example. Variable name, you put input and write your prompt message here, right? So what happens is that you must have seen in placeholders it is written that enter your name over here. So what you can do, you could write variable name input your prompt message, whatever you have to write over there. Like for example, use that is a great example. It says username input, what is your name? You can then print hello, the name of that particular person. I'll show you how you can do this. For example, this is a user name, and then we have to input what is your name, right? Then I can print hello, and then I can print whatever he entered, right? So first, if I now run this program, so what will happen? First it is asking me what is your name, so I'll enter my name. It's Harsh. Now it is saying hello Harsh. If I don't even put space over here, then it will also work perfectly fine. So first is it asked my name, then it is taking my name and printing it over here wherever we have to use this. So now it's a two-way conversation. First, in print function, what was happening, we were only just printing. Now we can ask the user also their input, and then we can print according to that. So critical rule is that input is always a string. The input function always, without exception, returns data as string data type, even if the user types numbers. So if you are taking in age or some phone number. So make sure you convert it, right? You convert this. Now, for example, your age, and we will skip this for a while and then we will come over here. Now, type conversion, convert to integer. What you have to do, you just have to put int over there. Like for example, if I get age is equal to 25, but this age will be in string. So now if I have to convert this age, what I have to do, I have to write like this int, and then I have to write like this age. So this age, the string will be converted to numbers, right? Integer. And if I have to convert it into float, I will write like this float and age. So the basic difference is that in int it will be 25 and in float it will be 25.0, right? This is the basic difference. Here it is 1, it is 1.0. Now conversion. So as I've just shown you this example, now I will demonstrate also. So first we have the age that is to be recorded in string, that we have to take input. We will write enter age, right? Once we have once the user has entered the age, what we have to do, we have to convert this. Now we are taking a new variable, that is age int, and we will convert this age, the string one, to integer. Now our age is converted. Now we can add also next year. Next year he will be 1 year older. So what we can do, next year is equal to age int, what is currently, and now we can perform mathematical operations on this as it is integer. We can't perform mathematical operations on age underscore str because it is a string over there. We have to make sure this, that only integers add integers and string don't add, it will give you an error. Now I can write like this, next, over here, next year you will be, and then I can write next year. mm, yeah. Now if I print this, so now what will happen, first it will ask me enter age. If I enter my age 25, then it will tell me next year you will be 26. Right, now you can do the maths. So it's very simple. First you have to collect the input, you have to convert the type, and then you have to perform the operations. This is how it works. Now conversion example float, similarly you can add float also. So for example, we have any price, input price, then we convert it into float, and then we add 18% GST. So for adding 18% GST, we could just multiply it by 1.18. GST is the tax. So now print total with tax is this much. I will also show you this. For example, we have this price str is input, enter, I forgot the double quotes, so it will be enter price, right? Next we have to convert this string into float. So we'll take a new variable price float, and we will convert it into float and price str, right? Now the total price is supposed to be added with tax, and there is 18% tax. So what we can do, we can do this price float. Now it can be operated with any of the number or floating value. I will multiply it with 1.18, since we have to add 18% GST, right? So this is 18% GST, the tax. Now if I will print total, right? So this is it. And now if I run this, so first it will ask me price. If I enter the price over here as 100, so it will give me the total price is 118, which is 18% GST is also added. Now let us talk about the nested conversion, the elegant way. There are old way, and there is New way. In professional code, you rarely see the conversion done in two steps. The cleanest way to handle numerical input is to nest the conversion function directly around the input function. This is efficient and keeps the code tidy. Like for example, it means that instead of writing all these two lines, first we are taking an input as a string, then we are converting it. Instead of this, what we can do, we can instead of this we could just input, like we don't need price str. Now what we can do, we'll take float and then we will enter input and write enter price. Now see what happened. First it took input enter price, so whatever price we enter, it is taken in as string. Then we converted to float, like we put float and brackets, so it converted float, the string, into the float. Now if we run this, so if we enter the price again, let's say 200, so it will be 236. 18% is added. So this is the new way of adding. I told you to make you understand how we convert the data types, and I hope you would have understood this. Now I've already shown this example. It is clean and efficient, and it is the best practice you could do, and you must try this. You must pause the video and code along this and see what result you are getting, whether your code is working or not. Now comments, the programmer notes, we have already discussed about this in, I guess, fourth lecture. So while discussing the Python fundamentals, so comments are lines of text that Python completely ignores during execution. They exist solely for human readers and for your future self. So this is the single line comment, which is hash. So it is completely ignored by the interpreter. It does not read. Then we also have some inline comments. So what we can do, we can write our code, and after that we can put a hash and write our comment, whatever we need to write. Since we have already discussed comments initially, so I am skipping it right now. There are also multi-line comments, which are known as doc strings. So we use triple quotes. Either you could use double quotes or single quotes, and you could write whatever you want to write in this. They are conventionally used to document files, function, and complex molecules, and the text remains intact. The font and anything does not change. No line breaks and nothing changes. Everything remains exactly. You could preserve it. Now, the best practice when to do a comment, when you have a complex mathematical formulas and calculations, business logic, and the reasoning behind code decision, temporary code that's been disabled for debugging non-obvious variable names or magic numbers. Do not comment add 1 to score for score is equal to score for 1, because this is like very obvious. You don't have to comment for every single line of the simple code. Most of the code is understandable, but whatever is not understandable, or if you are using some variables or anything else, or exactly the gist of it, so you could just add it. So this was the review. We have understood how we can take the input function and how we could do the output, how the print function works, how we can do the input, and since the input is always in string, we can do conversions. So this is it for this lecture, and I am very excited for the next section too, and congratulations, you have completed this section. So you have now a solid foundation built. You have mastered the core building blocks: variables, data types, operators, input, output, and professional commenting, how to do everything. So this was the fundamental, and now section 3 and section 4 are also the fundamentals. Then we will eventually go to advanced Python, and we will be building projects. But if you understood this was your core, your building blocks. Also logic flow and control flow are also your building blocks, but for now it's very great, and be proud of yourselves that you have completed this section. Next section will be exciting world of collections, string, list, dictionaries, and powerful data structures. More data structures, how we can work upon them. Then we will be going towards advanced programming. These tools will transform you from writing simple programs to creating sophisticated data driven applications. right? So the next section, section 3, is strings and collections. So we will pick up right where we left off with strings and dive into data structures, lists, and dictionaries, which allows us to store not just one piece of data but many pieces together. Fantastic work, and I'll see you in the next section. Thank you. Bye bye. Welcome to section 3. We are moving beyond single variables and into collection data structures that let us store multiple items together. We will start by concluding our work with the string data type. Today, we focus on string methods, prepackaged actions that make manipulating text incredibly easy, and the modern standard for professional string formatting. So, now let us see what is a string method. Method definition. A method is like a function, but it is attached to a specific data type, a string in this case. A method is essentially a function that is attached to an object like a string. You call it using dot notation. For example, this variable dot method name. When you use a method on a string, the action is performed only on that specific string's data. We will be seeing some examples too, then it will be much clearer. Now let us see some case manipulation methods. So these are simple but essential for cleaning user input. The dot lower method turns everything into lowercase, and the dot upper method turns everything into uppercase. And title is great for names, headlines, capitalizing the first letter of every word. For example, if user has let's say input the word John. If for example this is our string is our John. Now if we use this str dot lower, so what will happen? This John will be converted to small j like this, right? All characters will be converted to lowercase, and whichever are lowercase, they will still remain lowercase. In the uppercase, what will happen if we do str dot upper? So now everything will be converted like this. So these are the case manipulation methods and some methods which we can use on strings. Also, there is title. So for example, if we have a line, so every word of the line, the first letter will be capital. So it's great for like headlines, you when you are using a title or something. So it is great for that. Now let's move forward and see case manipulation in action. As I just told you, the dot lower, the upper, and the title thing, right? So there are some practical applications that email address validation, user input standardization, database search operations, text formatting for display. So it's look neat and clean. Let us now see also. I'll just demonstrate you everything. For example, this is my text, right? And it contains by I am deliberately writing in different thing. Now if I have like this my text, now if I use over here my print my text dot lower, so everything will be converted to lowercase, right? Let us run this. So as you can see, this Python course, everything is converted into lowercase. Now if I want to do the same with uppercase, so what I can do, I can write here upper. So it will, everything will be in capital letters. And if I use title over here, so as you can see, only the first letter of every word is capital, rest all are small, like we used to do in um, for titles, for headings, etc. Right? Now let us see checking string content, some Boolean methods. These methods are incredibly useful for validation. They don't change the string, they simply ask a question and return a Boolean answer, true or false. We use isDigit to check um, if a string contains only numerical digits. For example, if a string is something like this, that is 0 1 2 3. So if I use is.isDigit method on the string, so it will tell me, it will return me true or false and tell me whether the string has only digits or not. And here comes is alpha. So it verifies if the string contains only alphabetical characters like small letters or capital letters. This is essential for name validation, right? Now you can see like here is the password 12345, and if I say print password is digit, it will return me true. If I write hello and if I use is alpha, then also it will return me true, right? And for example, here in high, we have what? We have exclamatory mark. So it is returning me false for is alpha because exclamatory mark is not an alphabet. Let's just see this too. For example, if I have this password and this is 12345, and I write over here print password and we'll check for is digit, right? If we check for this, then it will return me true because all the characters in the string are digits, right? Now if I want to check for something else, let's say I have this word hello and I want to check if all the letters are only alphabets. So I'll write this word dot is alpha, right? So we can run it over here. So it is again returning me true. True is first for this one is digit, and for is alpha it is also returning me true. Now if I change the word and make it to high with exclamatory mark, now exclamatory mark is not an alphabet. So if I run this over here, so it will give me false, right? Now let's move forward and see stripping white spaces. Data cleaning is critical skill in programming. White spaces handling separates amateur code from professional application. Now what is white space? You must have seen sometimes when we write something like for example here. So here there might be some white space, here might be some white space, or if two words are written and in between there is a lot of white space. So this doesn't look tidy and clean. So we can remove white space in Python with dot strip method. It removes leading and trailing white spaces from both the ends. For example, we have written something over here. Here is a white space, here is a white space. So it will eliminate these both, right? And we also have directional variants, that is dot L strip, which removes only from the left leading white spaces, and from the R strip, which removes only the right trailing white spaces. Trailing, for example, if I have a word written over here, so this is trailing and this is leading white spaces, right? Everything that comes before is leading and everything that comes after is trailing. And if I only want to remove from left, so I could use L strip over here, right? And for right, I could use R strip, right? So this is how we can do. Now we can also see some examples over here. For example, if I take a word name and it has, I give some spaces first, then I write Alice. Now, if I want to remove the trailing, the left white spaces, so what I can do, I can create a new name, clean name, and I could write it as name dot strip. And if I want to print this, I could print clean name. Now, if I run this, I will get only Alice over here, right? But if I wanted to print only name, so you can see what will happen. White spaces will still be there. As you can see, here are white spaces, but here are no white spaces. It eliminates all the white spaces. Why this matters? Because if we are taking, any input and we want that contains unwanted white space, so we can remove that. CSV file imports, API responses, copy paste operations, a lot of places it is necessary to remove those white spaces. Now let us talk about the finding and counting substrings. dot count substring and dot find substring. So dot count returns the total number of times a substring appears within a string, essential for frequency analysis. For example, if we have a string, a long string, let's say a paragraph, and if I want to check how many times a particular word has occurred, so we can use this dot count, and I will put my word over here or any of the substring. And if I am using dot find, so it will return me the index position of the first occurrence, and it will return -1 if the substring is not found anywhere. Right, so we can count and find substrings of our choice very easily. So for example, we have this data banana, and if I want to count how many times a occurs in banana, so 3 times it occurs, so we can do this like data dot count. And if I want to find the position of n, so it will be 2, be- because it is 0, 1 and 2. It will return the first occurrence. And if I want to find z, z is not there in banana, so it will return me -1, right? Let us see also. We have this data which is banana, and here if I want to print data dot count, and I write over here a, so 3 times banana a comes 3 times in banana, so we can print it over here. Now if I want to find something like if I want to find n, so it will return me 2, because n is the at second index, the first occurrence of n is there at index 2. Now if we talk about if I want to find z, since z is not there, so it will return me -1. You can see over here, right? Now let us talk about replacing substrings. So the replace old and new replaces all occurrence of the old substring with the new substring thought of the entire string. And it has this immutability principle. The method returns a new string rather than modifying the original. Strings in Python are immutable. You must remember this. Right, now here's an example. Like for example, here is I like apples. So what I can do, I can create a new string, and in that string I can write copy the same string, but if I want to change a particular word, so I can change this apple to Python, so from old to new. Right, so now if I print this, so it will be I like Python. So let us see this also. For example, we have this phrase that says I like apples. Now if I create a new string and see, so it will be phrase dot replace, and it will be, if I want to change a particular word, so I can change like apples. First we'll write the old one which we want to change, then we will write the new one. For example, if I want to say Python. Now if I print this new thing, new phrase, and if I run this, there's an error. Oh, just because it automatically went into shell mode. So let's just remove this and run it again. So now here it will be I like Python, right? So this is how it works. Now let us talk about string formatting. Why is it essential? String formatting, why it is needed? Let's talk about presentation. When you print complex output with variables using just commas, it gets messy. So our goal with formatting is to create a clean, professional looking message where we can precisely control where our variable values are inserted and how they look. So we can also see some introduction to f strings. So f strings are the easiest and most readable way. So you can create an f string by putting the letter f immediately before opening quotation mark. Then you can insert any variable, expression or function call directly into the braces, right? So you can use these braces, and let's see. For example, we have this laptop and its price is this, and there is 0.05% tax on it. So now if I want to make it better, so what we can see we do, we can write f over here, then we can write item, then here will be the item, whatever the item is, and its price, right? So for example, the price was 1200 and we want to add dollars to it. So like this we can write, but usually we don't do such things, but we can also do. So you must know the f string example. Now it has numerical precision control, formatting specifiers, add special formatting codes inside the curly braces to control number appearances and precision. 2f formats as a float with exactly two decimal places, perfect for currency and measurements. For example, if I have to write 3.14, so this 14 we have to write like this, 0.2f. You can try this on your own. Now there is a transformation example. For example, we have this a long number, there are 6 decimal places over here. Now we only need 2, so we can do automatic rounding for professional display. If I only want to write this 2, so we can round it off also. So it can be done using the 0.2f. So now we have studied both the methods and the operators. So operators are symbols that act directly on data using mathematical or logical operations, and these are all the operators, and we do some calculation using operators. But the methods are named actions attached to a specific objects that perform specialized operations. So we have done all these examples, right? Now next up we have lists, a very important topic that is Python's workhorse. So we have completed the strings, and next lecture will be list. So now the major transition will be that lists are mutable, they are changeable. All the data types which we were studying till now were immutable. Now we are next going to study lists which are going to be mutable. So I'll meet you in the next lecture. Thank you. Welcome back. We are well into section 3, focusing on collections. Today we meet the workhorse of Python, lists. A list is an ordered sequence of items, but its key differentiator from a string is that it is mutable, meaning that it can be changed after it is created. Even better, a list is extremely flexible. It can hold different types of data, such as strings, numbers, or even lists, all in one container. So now we will see how to create a list. So it is great that we have these mixed data types and they are mutable. Now let us see how we can create lists. So it is very simple. We just have to write the list name, and then we have to use these square brackets, and in between we have to separate with commas, and we can add our items in the list, right? Now here you can see a few example of the mixed list. For example, we have a string over here, we have an integer over here, here we have a floating value, and here we have a boolean value. Now we can create list of mixed data types, list of names, and we can also create an empty list ready for future items. So let me just demonstrate it to you. For example, we have this mixed list that is, we can store over here apple. We have written an integer, let's say 42. We have a floating value, which is 3.14, and we have a boolean value. Boolean value does not require double quotes, and sorry, these also don't require double quotes. This, and we have, let's say, true. So a list is created over here. If I want to create a list of names, it could be something like this, which is Alice, let's say Bob, and we can also use Charlie. So these are the list of names which could be created, and an empty list also could be created like this, which is ready for future items if you want to store anything over in this list, right? Now let us see about accessing the list items. Similarly, it has same indexing for like we used to have in strings, but here indexing is for every item. So it has zero based indexing. It starts from 0, and second index is 1, so on. Negative indexing is similar also. From the last we start from -1 and go till here. And we can also use this length function for list to calculate how many items your list contains. So for example, we have this indexing. So this index is red, green, blue. So it is 0, 1 and 2. If I want to print colors 0, so the output will be red. If I want to print colors -1, so it will be blue, because negative indexing is done from here: -1, -2 and -3. This is how list indexing is done. Now mutability, the power to change. Unlike strings, lists are mutable, meaning you can modify them after creation. This flexibility makes list incredibly powerful for dynamic programming, right? You simply use the variable name, the square brackets with the index of the item you want to change, and the assignment operator. So here what you can do, if we have a list created, so we'll take the list name and we'll use the index and we will write a new value. For example, in this names list, if I want to change the second, I want to change Bob. So what I can do, I can do Bob and I can write index 1 and I can change it to, let's say, Harsh. Now what will happen, if I want to print this names list, so I can print it over here like this. Now the list has been edited. So as you can see, lists are mutable, and this is how we can mutate the list. So we can also have seen this example. So let's move forward. Now slicing list, extract portions. So just like strings, list can also be sliced. It is similar to strings. String basically contained only characters, but here we have different items, and these items can be sliced the same way it used to slice the string. So start and then step. If you haven't seen that string lecture, so you must go there and see. So for example, here are some numbers: 10, 20, 30, 40, 50, 60, and we want to slice some middle numbers. So let me just create, we have this, right here we have some numbers that are 10, 20, 30, 40, 50, 60, right? Now it has index number 0, 1, 2, 3, 4, 5. We want numbers from 1 to 4, right? This is what we want. So 0 is not included, so we will take 20, we will take 30, we will take 40. Since the end number is not included, so we won't include 4, and what's included is these three numbers which I have shown: 20, 30 and 40. So this is how string slicing could be done. Now we could also add items to your our list. How? We just have to use this function dot append item, and if I want to insert at a specific position, so what I can do, I can first write the index number, then I can write the item. So for when we append, so it always add at the end, but if we use insert, so we can insert at a specific position we want to choose, right? So we will just be seeing an example now. So for example, we have this list A, B. So if I want to append C, so C will be inserted at the end of the list. And if I want to insert at a particular position, so we can write the index number and then we can write whatever the item is. Let us see this. For example, I have a list, my list, and it says it has two things, which is A and B. Now, if I take my list and I use the append function and I append C over here, now if I print my list, so as you can see, it will be appended and it will be A, B and C. Now, after appending, if I want to insert at a particular position, so what I can do, I can do my list and I can write dot insert and I can write over here 0, comma, start. So at the first position, like at 0th index, start will be inserted. start is inserted over here. So this is how we could append and add items in our list. Um, Now, removing out items from the list, we could remove value, which removes the first occurrence of a specified value from your list. Right? For example, if we have a list, we will see the example in the next slide. So if we have like 10, 20, 10, 10, something like this, and if I want to remove 10, so wherever 10 comes at the first position, it will be removed from there. And if I want to remove from a particular index, so I will use this function, that is pop index, and it removes and returns the item at specified position. If no index is given, if I just run something like this dot pop, so it will remove the last item. Now we can see the examples. If we, for example, we have 1 2 3 2. If I want to remove 2, we can write data dot remove 2. And similarly for pop, if I write pop 0, so it will remove the first, that was 1. So let me just show you this. For example, we have this data which says 1 2 3 4, and if I want to remove 2 from here, 1 2 3 2, let's say we have two twos over here, and if I print my data now, so what will happen, it will remove the first occurrence of the 2. So the first occurrence of the 2 is this, the first one, right? So now if I print, so it will give me 1 3 2. The 2 between 1 and 3 will is removed. Now if I talk about pop and I say data dot pop and pop the 0th index, and then I ask to print the data, so what will happen here, 1 is popped which was at index 0, and 3 2 will be printed. So remove method, it finds and eliminates the first matching value, leaving the rest of the list intact. And pop method removes the by position and gives you back the removed item for further use. And we could also do searching and counting on list. So if we want to put dot index value, so it will return the position of the first matching item. It will throw an error if the value is not found. And we can also use dot count value. It counts how many times a specific value occurs throughout your number in a list. So value in a list, it could also return true or false, a simple way to check if something exists in your list or not. So for example, we have this fruits which says apple, banana, apple. If I ask banana in fruits, so the output will be true, right? This value in list, this is the syntax. So it will give me true. Now if I want to count how many times apple occurs in the list, so it will give me output 2. Let's see this also. So if I have this list fruits which says apple, you have to use double commas, which says apple, banana, and again apple. So now what will happen, if I want to print, I want to check if banana is present in fruit, so I'll write banana in fruits, so it will return me true. Why? Because banana is present in fruits. Now if I want to check how many times this occurs, so I will write print fruits dot count, and it will say, let's say apple. It is case sensitive, so you must write the same in the same cases, uppercase or lowercase. So now it will return me true. Why? Because apple occurs 2 times. Apple occur 2 times and it is true, right? So this is how we can done, and this is about list. Now let us see the sorting method. So dot sort method sorts the list in place, permanently modifying the original list order, and sorted function returns a new sorted list, keeping your original list completely unchanged. So alphabetical for text and numerical for numbers. Yeah, we can do both. So for example, if we have a few numbers 5183, and if I write dot sort, so now the numbers are like this sorted. And for reversed order, what we can do, we can write numbers dot sort reverse is equal to true. So this is how sorting could be done in ascending and descending both orders, right? So this is all for this lecture, and in the next lecture we have tuples. Tuples are immutable sequences that offer stability and security for your data. So we will be studying them, and in this lecture we have studied list in depth, how to create them, access them, and perform the most common operations. Next we explore another ordered collection that is immutable, meaning it cannot be changed. Join me for tuples in the next lecture, and I'll see you over there. Thank you. Welcome back. In our last lecture, we mastered the list, Python's flexible mutable workhorse. Today, we look at its close relative, that is tuple. A tuple is also an ordered collection of items, but it has one vital difference. Tuples are immutable. Once a tuple is created, its contents cannot be changed. Understanding the distinction is key to using tuples effectively. Now let us see how we can create tuple. So it is similar to list. The only difference is in list we used to use those square brackets. In tuples we have to use those curved brackets. And similarly we can write tuple name and insert all the items in the tuple. Right. Now let us see how we can create tuples like coordinates 10.0, 20.5. Tuples can also be, we can put any type of data type in the tuple. So it could be like a string, boolean, integer, float, anything, and we can create tuples like this. We can just have to write the tuple name. We have to use the assignment operator, and then we have to use this. Now accessing tuple elements. So similarly, like we used to do in strings, now since you have understood let's list properly, so what happens is that in tuples, uh, it is similar to list. The only difference between tuples and list is that these are immutable, right? So it also has zero based index. It starts from zero. Negative indexing works at the end. Slicing creates new tuples from ranges, right? So here are like weekdays: Monday, Tuesday, Wednesday, Thursday, Friday. And we could print weekdays. The zero is Monday, 1 to 4. So we have this indexing: 0, 1, 2, 3, 4. So if I was asked to do this 1 to 4, so 1, 2, and 1, 2, and 3 will be printed over here. The first element, index 0, retrieves Monday from the beginning. Slice range and negative indexing could also be done. It could be done from the end. Negative indexing will be done -1, -2, -3, -4, and -5. And positive indexing is this 0, 1, 2, 3, 4. Right. This is how we could do. And it is similar to lists. The immutability principle. So now the main rule, immutability, because tuples are fixed, you cannot use any list method that would modify the contents. There is no, like we used to have in list, no dot append or dot remove. Such methods we don't have in tuples because they are immutable. So no adding, no removing, and no modifying, right? So once tuples are created, they are frozen in time. Data is locked. So common mistake, people attempt modification. So this will cause a type error. If we use this user profile one and we want to change this 25 to 26, so we cannot do this as modification is not allowed. The correct approach is to create a new tuple, and here we can use updated profile, user profile 0, then 26, then user profile 2, right? Let me just show you this also. For example, we have this user profile, and this is Alice, and next is 25, and next is developer. So we have this, and so I cannot change anything, but what I can do is I can create a new updated profile, a new tuple. And what we can do with this is that we can add user profile, the 0th index, then 26, then user profile, that is 0, 1, and 2, right? So now if I want to print my updated profile, so updated profile will be, yes, so as we can see here, it is Alice 26 and developer. So we had to create a new profile to do this. We cannot modify the tuples as they are immutable. So the comma mystery, why does Python need a trailing comma for every single item tuple? Without it, Python sees regular parentheses around a value and not a tuple structure. So it's important that even if we are, creating a single item tuple, so what we have to do, we have to add a comma. If we, create like this, so this will be uh, treated as a string, whereas this class will be treated as a tuple, right? Now operations that still work, length will work, value in tuple will work. We can check something is present and not, like we used to check, banana in fruits. So something like this would membership testing would still work, and concatenation will work. We can add up two tuples, right? So tuple 1 and tuple 2 creates a brand new tuple containing both the sequences. So these are the functions that work. So small but mighty, there are some methods also. We can find the index value and the count value, what we did in lists. Similarly, we can do the same for this in tuples. Now, why choose immutability? If this is such a tough data collection that it is not mutable, why do we choose it? So data integrity protection. We use a tuple if a list can do everything a tuple can do and more. The answer is data integrity. If you have data that should never change, like a database primary key or the fixed color values for red, green, and blue, a tuple guarantees that stability. They are also marginally faster and crucially can be used as keys in dictionary, which list cannot, right? Now real world use case function returns. So these are function, this we will understand much better when we will be studying functions. So let's leave this for now and we will study this in functions, right? So packed tuple, unpacking process, and separates variable. Multiple values are stored together in one immutable container. Python automatically distributes tuple elements to individual variables. Then these separated variables, each value has now accessible through its own variable name. So this is how we can do the tuple unpacking, elegant data distribution. So this is how we can, you know, do this unpacking. X comma y, we can write coordinate points. It unpacks. So x will be for 5 and y will be for 12, and we can use it further where we want to use that. Now, converting between data types, flexible transformation. Python provides built-in functions to seamlessly convert between list and tuples when your data requirement. Yeah, this is a good thing about this. So if I have a tuple over here and if I want to create it into a list, so it creates a mutable copy. What I have to do, I have to write like this list, and then inside that I have to write my tuple name. For example, it could be my tuple. And if I have a list named as my list, and I could convert it into tuple, right? So it creates an immutable version. So whatever kind we need, we can convert it according to that. Now some practical conversion examples. You can see this is some immutable score. Now we could convert lists for modification. We can create into list, and then we can append, then we can sort, and then we can again convert back to tuple. So this is a great method for mutating tuples. First you convert that tuple into a list, then you add, insert, or whatever function you want to use in list, you can use that because lists are completely mutable. Then you convert again back that list into a tuple. So it's good when we need data integrity and we don't have to change like every day, and so it's great. So it provides us security and data integrity. Right, now let us see this comparison between lists and tuples. Mutability: lists are mutable, they are changeable. Tuples are immutable, they are fixed. Syntax: square brackets, lists have these brackets and tuples have these parentheses. Performance: lists are slower because they have more overhead, and tuples are faster and optimized. There are many methods for list, but only two methods for tuple, that is index and count. Use case is that it is dynamic collection, and when data is changing we should use list, and when we have fixed data record we have to use tuples. Dictionary keys cannot be used in list, but it cannot be used in tuples. When we will be studying dictionary you will understand it, right? So we have understood tuples properly, and we have completed the immutable sequences with tuples and their practical applications. Now the next is dictionaries, key value pairs, and we have explored strings, list, and now tuples. Keep practicing. Um, and in our next lecture, we move to our final core collection data type, dictionaries. This is an unordered collection based on the concept of key value pairs, which is a fundamental to almost all programming, modern programming, right? So I'll see you over there. That's all for this lecture. Thank you. Welcome back. We are wrapping up our study of collections. Today we meet dictionary. Unlike lists and tuples, which are ordered by numerical position, a dictionary is unordered and stores data using key value pairs. Think of a dictionary like a real world telephone book, where the name is the key that uniquely identifies the phone number, the value. So, key are our unique identifiers, and a unique identifier used to look up the data like a word in dictionary. It must be mutable types, string, numbers, tuples. Lists don't work as key, right? Values: the actual data, the information associated with each key, like the final definition, can be any data type, list, strings, number, even other dictionaries. Right. So this is the basically key and value pair. For example, there is Bob. There is a man named Bob, and he has some phone number. Let's say 9999, and some X. So Bob is the key. It is a unique identifier, and the value here is its phone number, the actual data, right? So let us understand. Let's create our first dictionary. So the basic syntax to create our dictionary is that we have to use a dictionary name, then we have to use these curly braces, and inside this we write the key, and then we write the value like this, and then we put comma and write another key, another value. This is how it goes on. So wrap up everything in curly braces, connect keys to values with colons, separate pairs with commas, right? So this is how we can create a dictionary. So user data stored by key. User profile: name is Alex and his age is 30. Is he active? Yes. Hobbies are what? Reading and hiking. So this is how we can write. So we can whenever you see a page like this and something, so for every person the data is stored. What is its name, and what is its age, what are his activities, and something like this. So this is how we can create. Now let me just show you how you can create. You can write user profile, and then you have to put curly braces. Now here what you can do, name is the key, and here what you can do, you can write Alex, right? Next up we have age, and let's say we put that 30, and then we have is active, and we can write true as a boolean thing, and then we can write its hobbies, and hobbies could be stored in a list. So here we have created a list, and here I have written his hobbies as reading and let's say hiking. So our dictionary is created like this, right? Now if I want to print user profile, so I can print this, but so you can see the name is Alex, age is 30, and so on. Now we will see more methods how we can access the value, right? So accessing value, no more indexing. So what we can do, we can list use numbers. My list 0 first item and my list 1 second item. Dictionary use keys. We can write dict name and key name. We can get direct access. For example, we can write the profile name and we can write it gets Alex. If you only want, like for example, if I show you, if we only want user profile and then I write just the name, I just want the name, I don't want, so I'm writing at the wrong place. If I want user profile and if I just want the name, so if I could just print it, so it will only return me Alex. If I just write age over here, or something, any key value, so what I can get the data. This is how we can access. um Now we can get a name, age, and what if the key doesn't exist? If the key doesn't exist, it will give an error, right? Now dictionaries are mutable. You could access the new key, you could assign the value, and if the key value pair is created. So this is how you could do. Also, you could add new data profile, and you could also, add city. City is equal to London. So new key is added. Now if you print profile, city London will be added over there. Now you could also modify existing values since it is mutable. So we can write profile age and we can update the age from 30 to 31. We can do it, or any age, whatever the correct age is, we can update it. So since they are mutable, so we can modify the existing data too. Now talking about the key value pairs using the del word Python s- built-in deletion operator. We could specify the exact key and the pair disappears completely. Both key and value are removed. For example, if I want to delete the, let's say age and its age, so the key age and the value of age both will be deleted using the del word. So we could do like this: del data b, whatever the dictionary is. For example, we have this dictionary where it is a1 b2 c3. So if I write over here del data and I write the key, that is b, so both the b and 2 pair will be deleted, right? Now safe access with the dot get method. The problem is that using square bracket throws a key error if that key doesn't exist. The solution is that if we write key default, method returns a value if the key exists or a default value. So it won't show an error, but it will show you a default value. So this is how we can use dot get method. So we have this profile, and this profile said if we write like city and the default value is not applicable, so the output will be not applicable instead of city. Since it won't throw an error, but it will give you a default value that it's not applicable, right? And it throws error if the bracket access is used. If you use these square brackets, so it will throw an error. Now getting all keys with dot keys. So if we want to return all the keys of the dictionary, what we can do, we can just put dot keys in our dictionary name and it will return all the keys that are present in the dictionary. We are going a little bit quicker because this is very easy and now you have understood, and since this is our last topic and we are almost done. So getting all the with dot values. Similarly, like we did for dot keys, we could also do for dot values. This will return all the keys and this will return all the values of the keys. It is useful for data analysis, extract all values for calculation and processing. It is great for loops, iterate through just the data, ignoring the keys. And there are some dynamic updates, right? So this is how we could do. Talking about getting everything with the items, so we could also get all the items, profile dot items, and here we could get name, Alex, age 30, and all the items could be given. It returns each key value pair as a tuple, so giving you access to both pieces of information simultaneously. This method is essential for advanced dictionary operations and is commonly used in loops where you need both the key and value. So we can use dot items. So we have till now done dot keys, it will only return keys. We have done dot values, it will return all the values. And here we have dot items, so it will return all the key value pairs in a tuple, right? Now checking key existence, the in operator still works and it returns boolean. For example, if we write name in profile, so it will return true. If we write city in profile, it will return false, because false, the city doesn't exist as a key. Now your dictionary generally continues. Dictionaries we have completed. Next we have sets and operations in this lecture, and after that we have a mini project, that is word counter. So you could apply your collection skills in a real coding challenge. And that's all for this lecture, and in the next lecture we will be studying sets and operations, and I'll see you over there. Thank you. Welcome back. We are covering the final specialized collection type, sets. A set is a collection with two key rules. First, it is unordered, meaning the items do not have a fixed position. Second, and most importantly, it does not allow duplicates. Every item in a set must be unique. This makes set perfect for cleaning data and performing mathematical comparisons. Now let us see how we can create a set. So set is something like, in curly braces, and we have unique value for everyone. So use curly braces to create a set with initial values, quick and readable for most cases. So this is the set function method. What we can do, first we can empty set, there is a set, and then from list we can make any set also. So if there is any list or something, so we can just put the list inside this set. Now, remember, this curly braces creates a dictionary too. So we have to use this function set, right? Now, sets are self-cleaning. It means automatic duplicate removal. Python automatically discards duplicate items when creating a set, only keeping only unique values. So if we put, a lot of numbers that are duplicates or repeating, so Python will automatically repeat, cancel this two, cancel this three, and it will only keep 1, 2, 3, 4, right? So this is how sets work. Now sets are unordered. There is no indexing. Since sets are unordered, you cannot access items by index or slice them. So something like my set, if we write, index 0, so it is not possible, right? Uh, Now set items must be immutable. The allowed types are only strings, numbers, which includes int and float, integer and floating values, tuples, booleans. Lists are not allowed, dictionaries are not allowed, other sets are not allowed, any mutable objects is not allowed. So every item that we add in the set should be immutable, like strings are immutable and these tuples are immutable, everything is immutable. We cannot change it. So now we can see how we can add and remove items. So it is very simple. Now what happens if we have any set and we use dot add item. So add a single new item to the set. If the item already exists, nothing happens. And if we want to remove an item, what we can do, we can use this dot remove, and inside the bracket we could put the item, and that could be it throws a key error if the item doesn't exist. And instead of removing, we can also use this discard function, which is it safely removes an item, won't throw an error if the item isn't found, right? So if we want to see if the item is removed or not, so remove function is good, as it tells us whether the item exists or not. And in discard, it removes the item if it exists, but simply does nothing if it doesn't, avoiding a crash. Now we can see how we can add or remove items. Let's say we have this set, and if we say add C, so we can add. If we want to say, let's say remove Z, so it will throw an error over here. Why? Because we are using remove. Instead, we should use here discard. So nothing will be done, right? Now data cleaning made easy. First, there is an original list. We can convert it to set, and then we can clean the result. So the most practical use of sets is that converting a list to eliminate duplicate instantly. For example, if we have data sets which have many duplicates value, or they are repeating, and we want only the unique values, so we could convert any list into a set, and only unique items will be present over there. Now conversion example, for example, before we have this like data in this list, apple is occurring 2 times, banana is occurring 2 times. So original list contains duplicate fruits. But if we use this set data and then print it, so we can get only the unique items, duplicates automatically removed. Let me demonstrate this also to you. For example, we have a set that is a list that is data, and it has apple, banana, and we have again apple, then we have cherry, and let's say then we have again a banana, and then we have date. Now if I want to remove all the unique elements, what I need to do, I need to convert it into set. And how can we convert it into set? We can use this unique data. We will create a new set variable, then we will write set, and we will put this data into this, and then we will print unique data. Now if I print this, so let's see. So only the unique values are occurring over here. As you can see, banana, apple, date, and cherry. This is how it works, and this is very good to if we only want the unique items. Now let us see set operations, mathematical power. So set A and set B. Uh, it requires basic mathematics if you have studied about sets. So let's see. For example, union. Union means combines all the unique items from both the sets. If we have 1, 2, 3, and 3, 4, 5. So 3 is common here. So as we can see, this if I draw the Venn diagrams, so this is set A and this is set B, right? This is set A and this is set B. So I have 1, 2, and 3 in set A. 3 is also in set B, so it is common. Now if I talk, B also has 3, 4, 5. These are the sets. So union means we will get all the unique elements only. So I will get 1, 2, 3 only once, not twice. 4 and 5. So as you can see, the union over here is 1, 2, 3, 4, and 5. And what we could do, we could use this single line over here. If we want a union of A and B, so we can write like this: A, put a line, and B union A union B. Or there is an alternative also, that we could do result A dot union B, and this is how we could get the same result 1, 2, 3, and 5. Let me show you this also. So how we could do this? First we have this set 1, 2, 3, and we have this B set 3, 4, and 5. Now what will happen if I have this result and I say A and then union B, and if I want to print the result, what I can see, I will get 1, 2, 3, 4, 5, only the unique values, as you can see. So this is how it works. And now we have this alternate method also. We could also do A dot union B. And if we print this, so we are getting the same result over here 1, 2, 3, 4, and 5. Now let us talk about the intersection operation. Intersection operation only returns us the common one, right? In this example, as 3 was the common one, so like here, if I show you this again, this was the thing which we had, and we have copied this. Let me paste it over here. So as you can see that in intersection, 3 is common here, right? So the common one, intersection means the common one. Here, 3 is the intersection in both the sets A and B. So we have got the result 3. So this is, so real world use, what can be the real world use? Common friends on social media, shared interest between users, and overlapping inventory items. So if something is overlapping, we don't need to duplicate and make our databases very heavy. We could use this intersection. So there is difference operation also. Difference operation means what? That returns the items in the first set that are not in the second set. For example, we have 1, 2, 3, and 3, 4, 5 in this. Now, if we want to do only in A, so what we can do? We can do A minus B, which gives us the difference. Now, it will return only, it will, since B is present, 3 is present in B. So it will remove just 3 from A, and we will get the result 1, comma 2. So order matters here, which is very important, because A minus B gives different results than B minus A. If we do B minus A, so 3 will be removed from A, and the 3 will be removed from B, and only 4 and 5 will be remaining as we have here. Right, so this is the difference operation. This is basic maths, so I'm not demonstrating it again and again because this is simple maths. You must try it on your own. And now let us talk about the symmetric difference. The symmetric difference returns items that are in either set, but not in both. It's like union minus intersection. For example, we have this symmetric difference, which has this symbol. So what it does, like we have 1, 2, 3 over here and 3, 4, 5 over here. So unique to each. We don't have to print common element this time. We only have to print the only ones in A and only ones in B. So it's like union minus intersection. You must remember this. It's like union minus intersection. For example, we have a set A and we have a set B. So this is A and this is B. So it is 1, 2, 3, 4, and 5. So if I do this, so what will happen here? Unique to each. If I want to perform this operation, A symmetric difference B. So now what I have to do here, I will pick only the unique ones, 1 and 2 from here, 3 I will not pick, and I will pick from here 4 and 5. So as you can see, the output over here is this, uh, 1, comma 2, comma 4, comma 5. These 4 elements are only there, right? So practical use, what we can see, users who joined or left and items added or removed. So this is how we can do. Now lightning fast lookups, checking membership in an extremely fast, much faster than searching through a list. It makes sets perfect for frequent lookups, right? So what we can do, the so searching for membership, checking if an item is present using the in operator. So if user ID inactive users, we can check, grant them access. So it is extremely fast in a set. If your main goal is to check thousands of times if a user ID or an item exists in a large collection, storing that data in a set is the most performant approach, right? So this is how we can look up. And if we use list over here for looking up, so it goes in linear time and it goes in constant time. So it is much slower for large lists. So we need to take care of this. Now let's talk about collection data types. We have studied list, tuple, dictionary, and set. These were all the collection data types. List is ordered. It also contains duplicates and it is mutable. Best use is general collections ordered data. For tuples, it is ordered, it has duplicates, but it is not mutable. Dictionary is ordered, but duplicate has no keys and they are mutable. Sets are not ordered, they don't contain duplicates, but they are mutable. So this is all the comparison of all the collection types. Now you have mastered all the collections and you now understand all four Python core collection types and their unique strengths. Next adventure is that you have to apply this knowledge in a hands-on mini project. We will be creating a word counter in the next lecture. So you must see, and you'll see some application and we'll build something. So it will be really nice in the next lecture. So I'll see you in the next lecture. Thank you. Welcome to section 4. We have transitioned from collecting data to controlling what our program does with the data. Today's topic is control flow, the order in which instructions are executed. We start with the conditional statements, which is if, elif, and else, and then we'll move on to loops. So these are the decision maker statements in any program. They let us tell the computer if this is true, do A, otherwise do B, right? So this is the control flow, and today's focus will be on conditional statements. Now let us talk about the if statement, the core condition. So what it does, the simplest decision structure that executes code only when a condition is true. The condition must be an expression that evaluates to a boolean value, true or false. So this is something like this. If the condition is true, so we have to write if, then we have to write our condition, then we have to put these two dots. After this, what will happen are, now we will start writing code from here, because now we have indented this code is intended. Now what happens is that here, how much space is there? Here it is 4 spaces. 4 spaces is intended and this much space is left over here. So this is how it works. And this is the if statement. So if this condition is true, do A, else do something else. um, the colon if statement rule is that first you must follow the conditional statement. This syntax is mandatory in Python. And second, the indentation, which I just told you, usually 4 spaces. The code must be indented. Python uses indentation to define what belongs inside of the if statement and what is outside the if block. So it gets easy, and it only works when it is intended. Now let us see some example. For example, the score is 90. Now if I say if score is greater than 90, print excellent work. This line is intended. Now you can write you got an A, print end of an program. This line is not intended. It will always run. Why? Because it is out of this if loop, uh, this if space, right? So if the score, let's say if the score was 85, so this condition would become false and these both lines won't be printed, but this line will still be printed. Why? Because this is outside the if block. Let me show you also this. For example, we have this score. Let's say we have the score 95, and then I say if score is greater than 95 and put the colon and write print excellent work. So this will be printed. Oh, I've set the score to 95. Let the score be this should be 90 and this score should be 95. Now if I print it, it will print excellent work. It was not printing because in the both condition I have put 95 and 95 is not greater than 95, which was giving an error. So this is how it works. And if I print a line over here, something like this outside this if block, so it will be print end of the program. right? So both statement will work. Now if the score is 80, so this line won't be printed because the if condition is not fulfilling over here. Only this line will be printed, which will always run, right? Now let us move forward and see the else statement. So this is the default path. Purpose is that provide a default block of code to execute when the condition is if condition is false. The important rule here to follow is that an else statement is optional and does not take a condition. So if condition is true, run this. If it's false, run this. Right? So we can use else also. For example, is logged in if it is false. So if is logged in is true, you have to print welcome back. Else you have to print press please log in to continue. This runs. So both things will work. Like as we saw in this, if the condition was false, it wasn't showing any statement. But here what will happen, if something is true, this will happen. If something is false, this will happen. We will always get an output, right? So I will show you this also. For example, we have this is logged in is equal to false, and we have if is logged in. If this is true, so you have to print welcome back, something like this. And if I write over here else print please log into continue, right? So since this is false, so this is statement is printed. If is logged in was true, so welcome back would be printed. Now let us see about the boolean context. Truthiness, falsy values, the anything like 0, none, empty, these are false values. So if I have like written 0 in instead of false, or there is nothing written, or there is an empty collection, so it will be considered as false. Truthy values, true will be any non-zero number, non-empty collections, and non-empty strings. Python treats many non-boolean values effectively true or false in conditional statements. Now the elif statements, it has multiple alternatives. Elif definition, short for else if, right? We used to write else if or something. So instead of writing else if, we have shortened it, and Python takes elif. Flexibility is that you can have any number of elif statements between if and the option else. So till now we were having only two conditions, either true or false. So we had only two options, but what if we want more options? So for that, what we can do, we can use elif. Now for example, we have this condition if run, if this is true, do this. Elif, if this is true, do this, else do this. For grade checker pattern, right? For example, if marks are above 90, give A. If marks are in between 80 to 90, print B. If marks are between 70 to 80, print C. So this is how the grade checker pattern works, and we will be seeing an example too. Yes, here, so here's the example. Grade is 75 over here. If this is greater than 90, print A. If grade is greater than 80, print B, right? And if the grade is greater than 70, print C. Else print fail. So this is how we can do. With grade 75, the program checks each condition and stops when it finds grade greater than 70 is true. So we will be seeing this example now, right? So let me show you. For example, we have grade 75. Now I will write if grade is greater than equal to 90. So it will be print A. Now I will write elif grade 80. So print B. We can also take input from the user whatever the grade is. It's not necessary we have to write every time. Since I am teaching you right now, so I am taking this to make it a little easier. Now if elif grade is greater than 70, so print C, and next will be else print fail. Now if I run this, so the grade is greater 75 and it has printed C over here, right? So this is how it works, the grade checker example. Now sequential testing order matters. Grade is 95 if grade is greater than 70. So program will stop here and it will print C over here. Elif was statement was below. So it's important, like if we put this 90, so we should have placed it above. Else it would have stopped here and it would have printed C. So once a condition is true, all remaining elif and else blocks are skipped. Now we can also use logical operators combining conditions with and or. So we can create complex logic conditions by combining multiple symbol conditions. Like for example, age is 25 and it has ticket true. So what we can do, if age is greater than 18 and he has ticket, so entry granted. We can do like this. Both conditions must be true for the code block to execute. So and had I made you show the table in operations that both conditions need to be true if and has to be true, and or any of the one condition if it's true, then the result will be true, right? So let me show you this example also. For example, we have age is equal to 25 and has ticket is equal to true. Now if age is greater than 18 and has ticket, so I will print over here, print entry granted, right? So since the age is greater than 18 and has ticket, both conditions are fulfilling, so it will print entry granted. If any of this, for example, if the age was 17, now it will not print entry granted, right? It will print nothing because we don't have a default value here. If we could write else print entry denied. So since age is 17, so entry is denied, right? This is how we can do. Now there is a combined logic example. Event access control allow access if they had a ticket or are VIP and over 18. So we could do a lot of things. So if he has ticket or he's a VIP, if any of the one condition is true, it will get true and the age must be greater than 18 and we can print welcome to the event. This is how we can do. So shorthand is also there, ternary operator. So what we do in this, instead of writing 2 3 lines for if and elif, what we can do, we can write result is equal to value if true, if condition, else value if false. So this creates clean and readable code. It's simple, we can write in just one line. So for example, if is day is true, so light is equal to sun. If is day, if it is true, else moon, right? So traditional version was this, it would like take so much lines, else this moon would be only here. So we could just write in 1 or 2 lines. So this is the compact version, else it is the same. So I will ask you to do follow the traditional version because the shorthand is only useful when we are writing very short code and we are making it even short. But if you are writing long piece of code and there are many conditions in one line, it might get confusing. So wherever necessary, you can use the compact version, but it I would recommend to follow the traditional version. Now, components of a conditional, we have these conditional keywords: if, elif, and else. Now, there is a Boolean check whether it is true or not. Then we have the required syntax. First, there must be colon and there must be indentation, right? So these are all the. Now we have advanced conditional logic. Um, Now we will be seeing nested conditions, if statements inside another if statement, and some advanced indentation and complex decision trees. So we will be seeing all this in the next lecture, and I will see you over there. Thank you. Welcome back. In our last lecture, we mastered the basic decision um structures: if, elif, and else. Today, we tackle a more complex pattern, that is nested conditions. A nested condition is simply an if statement placed inside another if statement. Um, or it could be a else block too. We use this when a second check is only relevant when the first check passes. This creates powerful multi-layered decision logic, right? So, for example, the key concept of indentation is that Python's sacred syntax rule. Key concept is that indentation must be real there, and the rule is that every control flow statement, if, elif, else, for, while, requires the subsequent code block to be intended, typically four spaces. Now, the critical point here is that indentation is not optional, unlike many other programming languages. Python enforces proper indentation, and the indentation must be there, else your code would fail. Right. Now, if I talk about the structure of nested if statements. So here's the outer condition first, then there's an inner condition, then this runs, else this runs. So this only runs if A is true and B is true. This will run when A is true and B is false. So let's take an example. For example, when you entry logic, the age we have set to 25 and has ticket will be VIP. So if the age is greater than 18, so print age checked passed, right? You have checked that he is greater than 18, he can be allowed. But we have to check if the ticket has VIP or not. So print access to VIP launch if this is true, else you have to print general access to general area only. Now, if I talk about else, print entry denied underage. So we could also deny the entry if that is underage. So let us see with this example how we have to, indent it. So age here I am taking 25, and we have this has ticket is supposed to be, mm, let's say VIP, and if age is greater than 18, print age check passed. Now if I write over here, if has ticket, and we write it here as VIP. So we have to print over here, if the ticket is VIP, so he has access to VIP launch. Now, if he don't has a ticket which is VIP, so the condition must be else print access to general area only, right? Now, there is something, if the age is not greater than 18. So in that if block, I will print over here entry denied. So you can see the code. Age is 25, has ticket VIP. Now, if I run this, So age check passed. Here it is passed. Then he has the get VIP. So print access to VIP launch. This is how we use nested if else statements. Now let us talk about tracing the flow age check scenario. So if the age is 16, so this condition is false, it immediately jumps to the outer else block. Now we can get the output result entry denied underage, and the key insight is that when the outer condition fails, all nested conditions are bypassed, all nested conditions are skipped, only the outer else block will work. Now you could trace the flow. So we have age checked, then we have entered the second level, then we have ticket verification. So this is how you could do this. Now avoid a deep nesting. It is best practice whenever possible. Deeply nested code like 4+ levels of indentation becomes confusing and difficult to maintain. Although it's often called arrow anti-pattern due to visual arrow shape. So you will keep on indenting like this, and then you will write like this, something like this. So it will become an anti-arrow type pattern, right? So there will be a lot of things. So it will be although correct, but people usually avoid it. Now let us see nested logic versus AND operator. So what happens is that it is a sequential check and this is a single check. So it is good for independent conditions and this is good for uh, sequential dependency. For example, first we have to check A, then only we have to check B. Here we are checking both if A and B are present. So we have to execute like this. Choose the best approach that matches your logic requirements and readability preferences. Now you could also convert nested to logic. For example, if the score is greater than 80 and if the assignments are done. Uh, so first you check if the score is greater than 80, then you check if assignments are done. So you print pass. So instead of all this nested code, what you can do, you can use this simplified code and you can write if score is greater than 80 and assignments are done, print pass. So this is a cleaner approach which reduces nesting levels. So we should reduce nesting wherever necessary, and we could use this logic. Now when is nesting actually required, let us understand this also. So you absolute need nesting when the else block for the inner condition must be different from the else block for the outer condition. For our venue example, the outer else is age denied but the inner else is general access only. They are two completely different outcomes, so nesting is required, right? Else we don't usually need nesting. Now let us talk about the indentation pitfall, syntax error. So sometimes people don't use indentation properly, so you have to use that indentation properly. And the second pitfall is that logic error. Many times people place at something different things. So if x is greater than 10, print a. If y is greater than y, now print b. Else which if does this belong to so print c. So uh, don't make these like silly and stupid mistakes. This is pitfall 2. Now let us see what is the visualizing scope with mental guidelines. You have to use vertical lines. Imagine that you have these vertical lines, then if your code is intended, you are writing four spaces like this, then like this. So these vertical lines must be in your mind, and you have to understand the scope. Every intended block creates a new scope. Variables and logic within each scope have specific rules and accessibility. Now you also have to check the track flow if everything is going right or wrong. So it starts, it executes, and if scope ends here. So this helps to trace program execution. Now the pass keyword, your placeholder friend. For example, the pass keyword acts as a placeholder when syntax requires a code block, but you don't have a code to write. So to prevent error, what you can do, you can use this password. We will be studying this password in detail too. For now, uh, we can just understand that if we don't have a piece of code to write over there, if in any of the block, we can just write pass. Now here's the final check. Always check if the colon is there, if indentation is done, or the alignment, right? Now the conditional flow execution we have already understood. Condition, true path and false path. The next will be the world of repetition. Now we have accomplished if else statement and nesting. Next will be loops. For and while loops will be explained to you, and which is one of the like most important topic in Python and your building block of Python. So I'll see you in the next lecture. Thank you. Welcome back. In our last two lectures, we mastered the decision making with if else elif. Today we learned the second pillar of control flow, loops. Now let us understand what is a loop. A control structure that allows a block of code to be executed repeatedly without writing the same code multiple times. For example, if I ask you to print something like this 1, 2, 3, 4, and 5. So, what you will do? You will say that we'll write like this print, let's say 1, print 1 and 2, then 3, similarly, so on. And you can print the statement 5 times, right? But what if I ask you to write from 1 to 1000 or till 10,000? You have to write. So you won't be like using the print statement again and again, right? So for that, we have loops. In loops, what you can do, you could just set a condition. And so basically, a loop is a control structure that automates repetition. It allows us to execute a block of code multiple times, which is essential for processing large amounts of data without writing the same line of code over and over. So the key concept is that automation. We have to automate it. Now, there are two main types of loops, and these two main types say that we have this for loop and we have this while loop. Now, talking about both the loops. So, the for loop is used for iteration. It runs for a known number of times, typically moving through a collection like a list or a string. The while loop is conditional. It runs indefinitely as long as a specified conditions remains true. You use the one that best suits your goals. So first, now let us see about the for loop. So the basic syntax is that for any item in sequence, the code block will run and you will print the item, right? So the for loop is Python's primary tool for moving through collections of data efficiently and elegantly. We will understand through an example. For example, we have this list which is fruits: apple, banana, cherry. Now for a fruit in fruits, so we can write anything in instead of this fruit, right? So this is our first iteration. For fruit in fruits, print I like and this particular fruit. So for example, for fruits in fruits, so how will this loop move? So first it will go to apple, so it will print I like apple. Then the second iteration will point to banana and it will print I like banana. And in the third iteration it will point to cherry and it will print, let's say, print cherry, right? So let me just demonstrate also this to you. For example, we have this fruits. Let's say we have fruits. We have a list which says apple, banana, and cherry. For fruit in fruits, what we can do, we can print I like fruit, this particular fruit, whatever the fruit will be. So if I run this, um, it has, let's say, some error. Yeah. Now if I print this, so it will print I like apple, I like banana, I like cherry, something like this, right? Something is, we have to put a F over here, right? Yeah. So it will print that particular fruit. Uh, as simple as that. Instead of this, if we don't want the brackets, and we can also do like this, I like, and we'll keep a gap and we'll write fruit. So it will print properly. I like banana, cherry, whatever it is. So this is how we can do. Now, for example, we have this word code and we have to print every letter in this word. So how we can print it? If we have a word, let's say we have a word that is code, and for letter in word, print letter. So now if I print this, so it will be CODE. Every letter of this word will be printed using for loop, right? Now let us see some more examples. For this range function is very important. So we have understood how for loops work. Now we have to understand about the range. If you want to run a loop through a specific number of times, but you don't have a list to iterate over, you need to use in the built-in range function. Range function generates a sequence of numbers on the fly. Remember that stop value is non-inclusive. The sequence stops before that number is reached, right? So we have this function range, and we could also write like this: range stop. So it will go from 0 but not including stop. So for example, if I say range and I write 5, so it will go on from 0, 1, 2, 3, and 4. 5 is not included, right? And we can also go for start to stop. For example, if we I go for 1 to 4, so in this 1, 2, 3 will be included, 4 will not be included, right? And we also have this start, stop, and step. For example, I have to print from 1 to 10, and the step will be 2. So it will be 1, 3, 5, 7, 9. This is how it is going to work. Now we also have some range examples with simple range and start and stop. Let us see. For example, we have for I in range 5, and I put the colon and I write print I. Now if I print I, so it will be 0, 1, 2, 3, 4. Right. Now if I want to print from 1 to 5, so it will be 1 comma 2 comma 3 comma 4, something like this, right? And if I want to use step also, let's say with step 2, and if I want to print, so it will give me 1, 3, 5, 7, and 9. This is how it will work, right? Now let us talk about the while loop, which is conditional repetition. So for loop we have understood clearly, and we have also learned the built-in function, which is range, and on the basis of that we print the for loop. Now continuous execution. It executes a block of code repeatedly as long as the condition evaluates to true. Now the critical requirement is that the condition must eventually become false to prevent an infinite loop that crashes your program. Now, while loop syntax and flow. So the basic syntax structure is that while this condition is true, code block runs repeatedly must include a way to change the condition. Right. Now, I will show you some example. For example, the counter is 0 over here. Now, if I say till while counter is less than 3, print count is this much, right? And in every loop, what we are doing, we are increasing the count. So when the counter is 0, so condition is this: 0 is less than 3 and this is true. So it will print count is 0. Now here counter is 1 and the condition is still true. 1 is less than 3, it will print 1. Here it will print 2. And since when we reach this fourth iteration, which is counter 3, now 3 is not less than 3, right? So this will be false and loop exits over here. So if we use while loop over here and I show you, so it will be, let's say first add some counter value. Counter is equal to 0, and while counter is less than 3, what we can do, we can write print count is counter. And in every loop, what we are doing, we are increasing the counter by +1, right? Now let us see what happens. So it will be count is 0, 1 and 2, and at 3 it will exit at the fourth iteration because the condition will become false. So file will only work while the condition is true, and also it's good if you write the condition in these brackets, because if there is a lot of operations or something, so it's better you put into parenthesis. Now let's talk about while loop user input example. For example, user input is empty right now. So while user input is not equal to quit, you have to write type quit to exit, and whatever the user is inputting it, you can just print it that you typed this. So if you need to make user exit, you may need to make him quit, you could just put a user input quit. Until the time it is false, you can just print whatever you want, but when it is when he enters quit, the loop will exit, right? Now let's talk about the avoiding the infinite loop. So what is an infinite loop? So if you forget that critical update like counter +1, you create an infinite loop. The counter will keep on increasing if you don't put a condition over here, and the condition will be always true, and the program will run forever, freezing your system. If you ever get stuck, remember the universal fix: press Ctrl+C to manually interrupt the running program. This is the emergency fix, and on Mac what you can do, Command+C, so you can manually interrupt the program and stop it. So the common cause is that you forget to update the variable controlling the loop. Now when to use for and when to use while. So we have already discussed this, that when you are iterating over collections, lists, strings or dictionaries, you should use for. The exact number of iterations, working with sequences or ranges, processing each item in a data set. And when you have to use while, so it will be looping until an external condition is met, processing user input is valid. Basically till a condition is true, we have to use while, and when we have to iterate or something, we will use for. So loop review, the essential syntax: colon and indentation. It's important. You must remember this. I am reminding you in every lecture. Also, the nested loops. We will be studying this also, like we did nested if-else statements. There are nested loops also, like for loop inside a loop and inside another loop. So just like if statements, loop can be nested inside one another for more complex processing patterns. So the outer loop controls the primary repetition cycle, and the inner loop is executes every single iteration of the outer loop. So the total iterations will be what? Outer iterations into inner iterations. That will be the total operations, right? For example, the outer has 3 iterations and each single has 4 iteration. So it will be 3 into 4, that is 12 total operations will take place. Now we can see a nested loop example over here. So for example, we have this range for x in range, and for y in range, print x and y, right? So what will happen? First, this loop will run 0, then this will run for 3 times, then this will go to 1, and this will again go to run 3 times. So total operations will be 2 into 3, 3, that is 6 times. So 2 for outer loops, 3 for inner loops, until 6 total print operations. Let us see this over here. For x in range 2, for y in range 3, what you need to do, you need to print x comma y. And if I run this, so this will run something like this, and this will run 6 times. Total there will be 6 printing operations. Now, next up, we have controlling loop flow. Right now, our loops are run start to finish. But what if we want to skip an iteration or exit the loop early? In our next lecture, we will be seeing that how we can control our loop flow. So I will meet you in the next lecture, and we will be studying this loop control, which is break, continue, and fast um, buttons, which you can use for advanced iteration management. We'll explore techniques for skipping iterations, exiting loops early, and maintaining precise control over your program's flow. So I'll see you over there. Thank you. Welcome back. In our last lecture, we learned how to initiate loops using for and while. Today, we gain much finer control. We are learning these three powerful keywords: break, continue, and pass. Right. So, we have to see all the loop behavior in Python. How does it work? So, the break statement. The first and the most powerful is break. When Python executes the break keyword, it immediately and permanently stops the current loop. When the program exits that loop entirely and jumps to the first line of code that comes after to the loop's intended block. We use break when we have found what we are looking for and don't need to waste time on remaining iterations. So then we use break statement. For example, we have this names list and we have this target Bob. Now for name and names, we'll run a for loop. If the name is equal to target, we will print found target and we will break the loop over here. Else we will print checking name and then at the end we will print search complete. Right, this is how it works. So if we found Bob, we will have to break the loop. For example, I will just demonstrate you this. So for example, we have this list, let's say names. Now in names we have this list, let's say Alice, we have Bob, and we have Charlie. So in this list, what we can do, if we write, we have a target, let's say Bob. Now I will first run a for loop. So for name in names, if name is equal to target, what we can do, we can print target found, right? And when target is found, we will break. And at the end, um, let's say we will print search completed, right? Now if I run this, so this will be target found, search completed. So this is how we can use break. And let us now talk about the break flow. So first it will check the condition, then it will print the message and we can terminate the loop. Then the further program continues whatever is written after the for loop, right? Now let us talk about the continue statements. It means that we have to skip the current iteration. So what does continue statement means? So unlike break, continue does not exit the loop. Instead, when it executes, it immediately skips the rest of the code in the current iteration and jumps straight to the start of the next iteration, right? So continue just skips that particular iteration. Whatever inside is that iteration. We use this to skip over a bad data or irrelevant items, right? So for example, we have this data and if the number is less than 0, continue means skip remaining code for this iteration and it will only process positive number, right? So let me just show you this example too. And we have this, let's say we have this data which has this list 10 minus 5 to 1. Now if I write for num in data, if num is less than 0, we should just continue. right? We should continue, and um, we can print over here the num, whatever the num is. Now if I run this, so it will print 10, 2, and 1. It is not printing -5 because in that iteration, if num was less than 0, so we had to continue, we had to skip that particular iteration. So this is how continue works. So this is the continue flow analysis. We have the first number was 10. So the condition is false because 10 is greater than 0. So 10 will be processed normally. Then comes -5. So condition becomes true and print is skipped. For 20 and all the rest numbers, it will work and it will print. Now comes the pass statement, the null operation. The final keyword is pass. This is the simplest. It is a null operation, meaning it does absolutely nothing. Its primary use is as a placeholder. Python syntax requires a code block after a colon, like after an if statement or a loop start. But sometimes you want to leave that block empty to implement later. Using pass prevents Python from throwing a syntax error, right? So let us see some example too. So if there is some data 1, comma 0, comma 5 for num in data, if num is 0, pass to be implemented later, error handling, else print 100 by num. So we don't divide by 0. Zero division case we don't want, so we can pass this right now. Now there is a quick comparison. So break, it stops the loop, continue, it skips the code, and pass, it does nothing. Loop behavior is that it exits completely, in continue it is next iteration, and in pass it continues normally. So common use is that to find the target, it is continuous for invalid data filtering, and pass is for empty block placeholder. So while loop control, its universal applications that break and continue work identically in both for and while loops. So break and continue are same. We have to take some critical caution that using continue before updating the loop control variable can create infinite loops. So we just need to take care. So you always need to ensure that your loop control variable updates before any continue statements to maintain proper loop termination. Now safe continue usage. So this is how we could use continue and everything. Um, you can see this is a very simple example and you must try this on your own. Now nested loop behavior, break and continue can only affect the innermost loop they are currently inside, and the outer loop will continue. In whichever loop, whichever iteration we want to skip, we need to use that particular iteration, right? uh, we can use this also, nested loop also. So this is a nested for loop, right? Now if I use this, if j is equal to 1 and break, so it will only break in this j loop in which j iteration is working. The outer loop continues its remaining iterations. It will only exit the inner loop, right? So first iteration j run once, then inner loop resets and runs one again, then inner loop again runs. So it will be something like this, the output will be something like this. You must try this on your own and verify the answer whether it is working or not. So the best practices is that you should minimize break usage, structure while loop conditions to terminate naturally rather than relying heavily on break statements. Strategic continue. So you can use continue immediately after validation checks to keep main processing logic clean and readable. And you could also create a temporary pass. Now we are done for this lecture, and the key takeaways are that complete control, selective processing, and structural placeholder. So you have this now toolkit ready. So you have majorly understood all the basics of Python. So the complete toolkit is ready. You can now possess all the fundamental tools for iteration control in Python programming. Next lecture will be with nested loops and its practical applications. So almost the last lecture of every section is more application and practical based. So we will be doing something in the next lecture. So like we will be seeing some real world examples, and I'll see you over there. Thank you. Welcome back. We have covered the basics of the for and while loops and the control keywords. Today we put it all together with nested loops. A nested loop is when you place one loop entirely inside the code block of another loop. This is an essential pattern for handling complex iteration problems and multidimensional data. So these are the two loop levels, loop 1 and loop 2, the outer loop and the inner loop. So you know how to do these nested loops. So today's lecture, I won't be coding anything today. It is your turn to code yourself and practice, because in every lecture I'm coding, and the last lecture of every section will be kind of a workshop and some practical use cases. So I will show you the code over here, but you need to go and type yourself and practice it. Now total breakdown counting operations. If five are outer iterations and three are inner iterations, so it will be 5 into 3, that is 15 total executions will take place. This we have already studied in the last lecture. What you need to practice is that you need to practice use case 1, grid coordinates. So you could generate all the 2 by 3 grid system, all the coordinates. Like for example, outer loop will be 0 and 1, but the inner loop will be 0, 1 and 2. So the real world applications are that game board positions, image pixel processing, spreadsheet, mathematical matrix operations, and this is all could work. Now some coordinates example implementation. For example, we have this for x in range 2 and for y in range 3. We could print this. We have printed the same program in the last lecture too. Now talking about practical use case 2, multiplication tables. For example, we used to write like this, no, 2 ones are 2, 2 twos are 4, 2 threes are 6, something like this. So if we have to create something like this, so first we have to define the range, and then we have to create the inner loop, set inner loop for multipliers, then we can calculate and format. So this is the code, this is the outer loop. So since we need outer loop from 1 to 5, so we will put in range 1 to 6, and similarly for the inner loop too. Now the result will be I into j, so the multiplication table will be j, and we can print all the uh, you know table list of any particular number. So now there are multi-dimensional data structures, lines, lists of lists, nested collections representing tabular data, game board, or matrices. So nested loops are most commonly used to process nested collections. This structure is used to represent these matrices, tables, or board games like tic tac toe. You have must have played something like this, or any of the board game if you want to place. So this is really important for placing the coordinates. So placing the coordinates, you require two loops, nested loops, especially. Talking about the 2D lists for row in board, for cell in row, you could print like this and you could make such a 2D list. You must practice this and see what output you are getting. Practical use cases, you can also do data comparison, list a elements, then brute force approach, and you can then find matches. Now data comparison implementation, you have these two lists, list a and b. For num a in list a, for num b in list b, if num a plus num b is 10, you can say you found a match, two numbers that add up to 10. So you can do this. So for example, you will run through this list and you won't find like 1, you will add with 2, no, it is not equal to 10. Then you will add 1 to 3, 4, still not equal, still not equal. Then you will run loop again and again, and then finally this 5 plus 5 will be 10. So you could say you found a match that both numbers are 5 from the list, which sums up to 10. Now mixing loop types, while loop and for loop, we could see this over here. So for inside while, so for example, while is running, we have this data batch and we could run a for loop inside this while loop. So there are a lot of permutations and combinations you can work upon, and you could just do a lot of things. So you must also practice this code and see what if you are getting the right output or not. Now nested control, break and continue. We have already understood, like if you want to exit, break only exits the innermost loop where it is encountered. Exiting multiple loops use flag variables or structured logic to control outer loops or inner contexts. Now there are some alternative approaches to consider functions and exception handling, but that is for our next section, section 5, that is functions. We will be studying that over there. Now, performance consideration is that small data, acceptable performance for modest data sets, and medium data, noticeable delay with larger collections. Large data, you have significant performance impact. So nested loops, like see the time complexity increases. Time complexity is basically if you run a loop on your computer, how much time will it run to, how much time will it take to run the program. So if you create something like this n into n nested loops and you make the complexity to n square, it will be very difficult, right? So if the data is large, it will take significant time and energy. So this was the iteration tools summary. We have done for loop, we have done while loop, break, nested loops, if else statement, everything. So now your core building blocks of Python is ready, and we are midway to our course. We have completed almost half the sections, all the half sections, 4 out of 8 sections, and the journey is going great till now. So you have done control flow mastery, and you must practice all these code in this. You must write them. Next section, we are organizing code with functions. Current achievement we have done the Python's grammar and control flow structures. Next we are moving to functions and problem solving. Learning focus will be that creating modular reusable code through function definitions, right? For example, in this we learned that for loop automates, and in functions we will learn how we can reuse the code again and again, right? So I will see you over there. Thank you. Welcome to section 5. We are shifting our focus from writing code that runs sequentially to organizing that code for large projects. This starts with functions. So functions, let us study about it. Code reusability. What is a function? A function is a simply named reusable block of code that performs a specific, often complex task. Think of it like a coffee machine. You press the brew button, that's the function call, and the machine executes 10 complex steps, the function body, to give you your result. So you could analyze this by coffee machine analogy, and you just press this button and automatically this coffee you get it, but in between there are 10 steps or maybe a lot of steps. So you just have to press the button and you'll get the result. Now let's talk about why use functions. So functions are foundational because of the benefits they provide. Most importantly, reusability, which embodies the dry principle. Don't repeat yourself. Dry principle means don't repeat yourself. Write once, call the function whenever needed throughout your program. If you need a task done 10 times, you write the function once and call it 10 times. They also promote modularity. It means that breaking huge program into small understandable chunks, making your code readable and far easier to debug. So it has readability and it has abstraction. So that's why you should use functions. Now let us talk about the defining of function, basic syntax. So the function is defined using the def keyword, right? So def function name, and whatever you write inside this function name, it is also intended. The body of a function, the actual code, is intended, and underneath This looks very similar to our if or for blocks like we used to do in loops and control flow section. Now there are some basic rules for functions. Let's summarize the rules. Start with def, give it a descriptive like snake case name, right? Something snake case format is something like this, like calculate total. We generally use such in Python. And finish the definition line with a colon followed by an intended code body, right? Also it must includes parenthesis after the name even if empty, and colon or and indentation are really important. So let me just show you some example how you have to do. First you have to define a function, then you have to call the function. Defining a function does not run the code inside it, it simply stores the instructions for later use. To execute the code you must call the function using its name followed by parenthesis, right? So basically you have to create something like def any function, you have to put parenthesis this and write your block of code. So this will store, and when you have to call the function you have to write func. We mean this by. Now what happens, see there is an example. We have this welcome message function, and then we have this print user system login version 1.0, and we call this welcome message. So let me also show you how we can do this. So we define def welcome message, we are writing in snake case, and then we write our block of code, that is print, let's say user login system, right? Something like this. And then I want to print one more line, that is version 1.0, right? Now if I want to see if I have to call the welcome message, I will write the name and then I will put parenthesis. So I have called the function. Now if I run this, so it is giving me the output, right? Now if I call this again in the next line, and so what will happen, the function will run 2 times. So as many times as I want to run the function, I can run it. Now let us talk about the flow of execution with functions. So the flow is a 2-step process. Step 1 is the definition. Python sees the def and skips the code storing in the memory. So whatever we write in def, it does not execute, right? And then what happens, it stores in memory. Step 2 is our call phase. When Python reaches the call, it pauses its current execution and jumps to the function's stored location, runs all the code in the body, and then exactly returns to the line after the function call. For example, we have a function here, let's say any def function name, something like this. We have this. Now here, if I have written name, or maybe somewhere below here name, then what will happen, this when this line will come for execution, it will go here to this function, it will execute everything, and then it will come back again over here, right? So these are the 4 steps how the flow of execution works. Now function naming best practices, we have to avoid the use such as print, func1, and something camel case. We don't have to use like this. Camel case is basically when you write in small letter and the second word, the first letter of the second word is capital. So instead of that we generally use snake case. These are some good examples, you can look at it, and you should use such kind of examples, because such kind of names for functions, because they are really great. So, and you have to avoid those reserved keywords in functions. Now the local scope. What is a scope? The region of a program where a variable is accessible and can be used. When you define a function, you create a new scope. A variable created inside a function is a local variable. The key rule here is that local variables are only accessible inside that function. When the function finishes executing, all its local variables are destroyed, right? So local variables are only inside a function. So for example, if I have written any function, let's say def, and we have used anything like a is equal to 10, so this a variable is only in the function. If we use a outside this function, it will not be valid. So life cycle, Local variables cease to exist when the function finishes executing. Now, what is the local scope? For example, we have this def greeting and we write a message here, hello local, and then we print the message. Here the message will be printed because the message variable here is local, because this message variable is inside a function, and when we call the function we will get. But if I write over here print message, so there is no message defined in this block of code, it is defined in a function, so local variable finishes, right? So this was local variable. Now let's talk about the global scope. Introduction. Conversely, a global variable is defined outside any function. At the top level of your program, global variables can be read from inside a function, but if you want to modify them, there are special rules we will cover later to prevent accidental changes. So we have reading access from anywhere in the whole code, and we could read it from over here, as the name says, global. Now here you can see global scope example. Here the system status, this variable is outside any function. It is a global, it has a global scope. Now if I write over here and I have to use this variable inside any function, it can read global, right? But it wasn't possible in the local scope. So this is how it works. Now let us talk about functions as simple abstractions. So you can hide complexity with the help of functions. For example, you have 10 lines of database connections, 5 lines of data validation, 8 lines of processing logic, and then you have to print. So you don't need to show everything to user, and you could just call the function over here, and all these lines will be automatically working over here. So you can store this in your code, but you don't need to show it every time, right? So it is good for abstraction when you want to hide complexity, or you could encapsulate complexity. This is a topic of OOPS which we will be covering in section 7.2. Now let us talk about doc strings, which are function documentation. Now let us see what are doc strings. Multi-line strings using triple quotes, for example triple and like this, and we have a lot of things written in here. Now the purpose here is that describe what the function does, its expected inputs and its output clearly. And the best practice to use docstring for any non-trivial function to help other developers. You could put your documentation, it's like a multi-line comment. Now here's a docstring example. You could write like this. For example, we are calculating the area of rectangle, so we want to return length into width, but we have explained here why we have done length into width. We have told the arguments, and then what we have to return, what we are doing, our purpose and everything. So this is a docstring example. You could either use single triple quotes like this, or you could use double triple quotes, like any of this will work. Now the pass keyword. Finally, remember the pass keyword. If you are structuring your program and want to define a function but haven't written the code for it, use pass as a placeholder to prevent Python syntax error. Where you don't have anything to write, just write pass over here, because it means that we'll add implementation later. So it acts as a placeholder, and then we do this function implementation, and we use pass just to avoid the syntax error, else our function will be empty. Now next up we have making functions useful. The current state function are statics. They perform some actions every time they are called. Next lecture we will be learning what are parameters, return values and advanced scopes or functions. We'll learn to pass data into functions and get results out. Our goal is to transform functions into dynamic, flexible tools that can handle different data and produce varied outputs. Right? So that's all for this lecture, and I'll meet you in the next lecture and we will study this topic. Thank you. Welcome back. We know how to define a function now, but to make it a productivity tool, it needs to handle dynamic data. Today is arguably the most important function lecture, as we cover the 3 pillars of data flow. passing data via parameters, getting the results by return values through return values, and managing variable access using scope. So let us understand what are parameters versus argument. So a function needs input to work. The variables we define inside the parenthesis of the def statement are called parameters. They are placeholders. When you call the function, the actual values you provide are called arguments, right? The arguments value are then automatically copied into the parameters for the duration of the function's execution. So we have a parameter and we have a argument. Now for example, parameter definition in action. Here, name and age are the parameters defined in the function. When we call this greet user alex28, the string alex becomes the argument assigned to a name, and 28 is assigned to age. The function then runs the print statements using those specific values, right? So instead of name over here, it will go alex, and instead of the age, it will go 28. So here name and age are parameters, like what are the parameters, and the value of these parameters which we run through the function are known as arguments, right? Now let us understand data flow with parameters. So first there is function call, arguments passed alex28, then assignment is done, name is equal to alex and age is 28, then execution happens. Function runs with assigned values. The automatic assignment process happens every time you call a function with parameters. Now let us talk about the return values, output from the function, how to get our results back. So the purpose is that send complete results back to the calling code. Keyword return tells Python what to send back. Immediate stop. Function execution ends when return is reached, right? So if we are writing a long line of code inside any def, for example, inside any def, if we are writing long line of code, then when it encounters return and whatever the value is, so it will return the value, and here the function will stop. Now let us understand what is return value. For example, we have this def add a comma b and result is a plus b, return result, so it will return the result. Let me show you this also. For example, we have this function def add a comma b, and now we put the colon and we write result is equal to a plus b. Then what happens? We ask it to return result. Now our function is completed. Now if we want to call this function, so what we can do, we can write sum of nums is equal to, we have to add 10 and 5, let's say, for example. Now I want to print this, whatever the sum of nums is. Now if I run this, so it will be 15, right? We get the 15 answer as 10 and 15 are both added. So this is how function works. Here a and b are our parameters and 10 and 5 are our arguments, right? Now let's move forward and understand the critical difference between return and print. So print will always display output to console. It is for user interaction IO. Function continues running. You cannot store the printed value. Whereas return, it sends to the calling code. It's for program logic. Function immediately stops and value can be stored and reused. So this is the basic difference. So you use return for data processing and print for user communication, right? Now let us talk about the multiple return statements. Function can have multiple return statements. Only one will execute per function call. Function will stop at the first return when it encounters. So this creates different exit paths based on the conditions within your function. So it could have multiple return statements, but these are conditional. For example, we have this function which is def check age, and if age is greater than 18, return true. It will stop here if the condition is true, and outside the if block, it will return false only if only reached if age is less than 18. So first it will do the input check. Function receives age parameter. Then it will check the condition. If age is greater than 18, then it will return the result. So these are like two choices, two exit paths from where it will return. Returning multiple values. Python allows returning multiple values by separating them with commas. Behind the scenes, Python creates a tuple containing all the values. Think of it as a packaging multiple items together, then unpacking them at the destination. So this is how you could do. Now multiple return example, we have already seen, like we have this def get user data return bob comma 35. So it returns a 2-item tuple. So for this, what we can do, we could use either user, or we could print years. So we could do like this. Also, understanding local scope. Local variables created inside functions, including parameters, exist only within that function's scope. Now let us talk about the temporary existence. These variables are destroyed when the function completes execution. There is isolation too. Cannot access function's internal variables from outside the function. Global variable, we have already done this global and local scope in the last section, or last lecture I mean. So you could modify the global variables too. Functions cannot directly modify global variables without explicit declaration of intent. So how you can do this? So for example, the total score is this over here. Now def add points, you want to add points to the total score. So global total score, we have to declare the intent to modify first. So we just have to write global total score, then we can add the points, and everything is global over here, so we can write this. Let me show you also this. For example, we have this total score over here to be 0, which is a global variable. Now I create a function that is def add points, and inside this we have these points. Now here I write global total score, right? I have declared this. Then I can add total score plus is equal to whatever the points are. Now our function is over. Now I could add points globally. Let's say I want to add 10 points. Now I can print total score, right? So I have written this. Now if I run this, so see, as you can see, the total score was 0 at the beginning, but I have modified it inside a function, and then my output is 10 over here when we add those points. So this is how we could modify the global variable. Now we have seen the data flow summary is something like this. First we have a input phase, arguments flow into the function via parameters. Then we have processing phase, function executes logic using local variables. Then we have the output phase, results flow out via return statements, right? So pure functions, first input, there is no side effect, and it returns only. So next lecture we will be studying default arguments and keyword arguments to make function calls even more flexible and readable. So I'll meet you in the next lecture, and we are going good, and I'll see you over there in the next lecture for default arguments and keyword arguments. Thank you. Welcome back. In our last lecture we covered parameters and return values, making our functions dynamic. Today we focus on flexibility. By default, Python requires arguments to be provided in a strict defined order. We are going to change that by making some arguments optional and allowing us to pass arguments by name, which greatly reduces errors, right? So let us see about default arguments, making parameters optional. So first, default arguments. The definition: a parameter assigned a default value in the function definition, right? A default argument is a parameter that is assigned a value right in the function definition, like level is equal to user, like something like level is equal to user, right? This means if the person calling the function chooses to skip that argument, Python automatically provides the default value. If they provide an argument, the default is overridden, right? So this is how we could use the default argument function. For example, we are the level of user is this, and argument can be omitted if we set role Alice. So Alice role is user. Now what we can do, we can also set Bob's role as admin, so Bob's role will be admin. This is how it works. So what's happening here? The function works perfectly with one argument because level has a sensible default. When we provide both arguments, our value overrides the default. The default argument rule is that in our set role function, level defaults to user when we call it with just Alice. Right. Now here's the crucial rule for default arguments. Parameters with default must come after parameters without default. If you violate this, Python will throw a syntax error. Now let us talk about some keyword arguments. This means when you have to call the function, you explicitly state the parameter name, parameter is equal to value. This gives you two major benefits. First, you can provide the argument in any order. Second, and more importantly, your code becomes self-documenting as the reader immediately knows what each value represents. Now we'll see some keyword argument examples. For example, we have this name and age arguments. So we could write like this: name is age years old. So for example, we have order is changed, but it works due to keywords. Like for example, we set age to 35 and name is Charlie, so we can write it will print Charlie is 35 years old, right? This is how keyword argument works. Now let us see some mixed argument rules. You can combine positional, order based and keyword named arguments, but there are important rules to follow. First, it is order rule. All positional arguments must come off before all keyword arguments. No duplicate rule. A value for a parameter can only be specified once in the same function call. Practical use of default arguments. In the real world, defaults are perfect for function configuration. Settings a user might not care about, like defaulting a log level to info unless a serious error needs to be reported. It saves the caller time. Now let us see about the practical use of default argument we have done. The configuration functions, faster development, and this. Now let us talk about the practical use of keyword arguments. So keyword arguments shine when a function has many parameters. Imagine a plotting library where you have to set the title, color, and line thickness. Using keywords makes the code highly readable, almost like English instructions, and prevents you from misplacing a color value into the title slot. Now, there are some mutable default traps. Look at this. This call appends 1 to the empty list here, right? So the first call appends 1 to the empty list, resulting in list containing 1. The second call, which should start with a new empty list, instead uses the same list object and appends 2 to it, resulting in 1 and 2 in the list. So this is almost never intended behavior and leads to very hard to find bugs. So these are mutable default traps. Now you can avoid it. You can always set the parameter to none. So none is really important. If you set the parameter to none and you create a brand new object, mutable object like an empty list, so this ensures that every call gets a clean slate, right? So this is how it works, and this was a short lecture, and that's all about this. Now we can review. We have this, you can use param is equal to default value in the function. There are some placement rules and there is some purpose. Now there are some keyword arguments. The syntax is param is equal to value in the function, and there are some ordering rules. There are also some purpose. Allow arguments in any order and greatly improves code readability and safety. Now you can combine both types of flexibility. Def create user name active is equal to true. You can pass this, and create user Dan create user name is equal to Eve, which is active and false. Now flexibility and control summary. You now control the input to your functions completely. Position for rigid order, defaults for optional settings, and keywords for clarity. This is essential for writing robust, scalable code. Now next up we have recursive thinking. We have covered function syntax and flexibility. In our next lecture we tackle an advanced but fascinating concept, recursion basics. We explore a function can call itself to solve a complex problem by breaking down them into simpler reusable steps. I'll see you over there. Thank you. Welcome back. Today we tackle one of the most conceptually advanced topic, that is recursion. So let us understand what is recursion. So recursion is when a function call itself. It's a method for solving complex problems by breaking them into simpler, identical versions of the problem. Think of it like a Russian nesting dolls. Each doll is a miniature copy of the whole set. And to get to center, you have to peel one layer at a time. Now let us understand why choose recursion. Because it has elegance and problem solving. So for certain problems, particularly those involving mathematical sequences or data structures like file trees, the logic is simply cleaner and more intuitive when expressed recursively. It allows us to solve large problems by defining how to solve the very last smallest step. Now the two essential rules which you must take care in recursion. First is the base case and second is the recursive case. So you have to define both the cases. To avoid the dreaded infinite loop, every single recursive function must have two parts. First, the base case. Base case, this is the non-recursive part. It tells the function when to stop calling itself and return a final value. Second, the recursive case. This is the part where the function call itself, but it always calls itself with a slightly smaller or simplified input, moving it closer to the base case. Let us take an example now. So for example, we have this factorial example. So 4 factorial is basically what? It is 4 into 3 factorial, and 3 factorial is what? 3 into 2 factorial. So as you can see, every time we are calling this factorial function with a smaller unit. So these are all the recursive cases where we call all the factorial, and this one where it tells that 1 factorial is equal to 1 or 0 factorial is equal to 1. So this is the base case. Here we have to stop our function. So we will be using recursive case in these three, but we will be using this base case in the fourth, which says that when the function is supposed to be stopped. Right. Now let us talk about the factorial code implementation. So we have to create a function like this. So the base case is something like this. If n is equal to 1 or n is equal to 0, you have to return 1. Else for recursive case calls itself with smaller input. So what you have to do, else n into factorial n minus 1, then we can print the output. So let me just show you over here. For example, we create this def factorial n, right? Now let us first define the base case, that is if n is equal to 1 or n is equal to 0. Now we have to return 1 over here. Else, now we write a recursive case over here where we will write return n into factorial of n minus 1, right? These are the cases. Now if I want to call this function, we have just defined the function right now. So if I want to call print factorial, and let's say I want to print the factorial of 4, and if I run this, so this will be 24, right? Now let us see the tracing the factorial flow. So we have already seen this. First it is 4 into factorial 3, then it is 3 into factorial 2, then it is 2 into factorial 1, then when factorial 1, so it returns 1, that is the base case. Now results unwind. Now it goes back, like for example it goes here 1 into 2, here happens, here now happens 2 into 3, then it is 6, then it goes up and it says 6 into 4. So then we get the answer 24. So it unwinds also, right? Now let us take another example, which is simple countdown. So our goal is to count down from a number until 0 is reached. Then we have to print go. So the recursive case prints the current number and calls itself with n minus 1. This clearly demonstrates the input shrinking towards the base case. So the base case is when n is less than or equal to 0, where we print go, and then it stops. So this is the code. First we have the base case in the function. If n is equal to is less than or equal to 0, you have to print go. Else when you print n and you call the recursive case again, and here we can print it. Now let's see def countdown. Let's create a function def countdown, and here we have something n. Now if n is less than equal to 0, we have to print go. This is our base case. Print go. Now if we talk about else, print n. So now what we can do, it is countdown. Let's say it is n minus 1. Right now if I want to print countdown, let's say 3 2 1 we have to print. So what we can do, this is outside the function. Now we are calling the function. So now if I run this, so it is 3 2 1 go. This is how recursion works. Now let us talk about the danger stack overflow. So the problem is that if we forget the base case, so what will happen, the function will call itself forever, leading to what's known as an infinite recursion. This fills up the computer's memory or call stack, eventually leading to a recursion error. Python sets a hard limit around 1000 calls to prevent a catastrophic crash. Always double check your base case. Now let us understand what is the difference between recursion and iteration. So recursion uses function calls and iteration uses for or while loops. Recursion is more elegant for tree-like problems and iteration is better for memory efficiency. But recursion has higher memory usage, but iteration is often has faster execution. Recursion can be slower due to overhead, but iteration is more straightforward for counting. Right. Now let's talk about the performance consideration. So we have to just keep in mind memory usage, execution speed, and when to use what. Now the recursive pattern is such that you have to define the base case, you have to define the recursive case, and you have to ensure the progress. So lock in this pattern and you will get the results always right. Now functions journey, Sarmi, we have defined the function and we have done the data flow, how it happens. We have also done problem solving, when to use iteration, when to use recursion, and how we can create functions. And we have also seen the flexibility, default and keyword arguments for versatile functions. So next we have our mini project, that is calculator app. So in the next lecture we will be building a calculator and seeing how we can use functions, and it is a basically practical application based lecture, the next one. So I'll see you over there. Thank you. Now let's talk about our mini project, the calculator app. So how we are going to build this. So this is the final and our exciting project for the function section, how we can build a calculator. So the project goal is to build a functional command line calculator that takes two numbers and perform mathematical operations with elegant error handling. The core concepts will be functions, parameters, return values, while loops, if logic, etc. Now what we will be doing, project structure is to make these functions add, subtract, multiply and divide, and we will have a helper function get number for reliable user input. Now main logic is continuous while loop managing user interaction. So first we have to get number prompt. So we have to get from the user what numbers are we getting. Then we have to use the function. Like this is very simple. If we want to add two numbers and we have to create a function, so this can be def add n1 and n2, and return n1 plus n2. So you can do like this. Similarly, for subtraction and multiplication, you could do return n1 minus n2, and for multiplying, return n1 into n2. Now you could also divide by this, but if there is 0, if n2 is 0, so we cannot divide by 0. So you just have to make sure, for error prevention, you have to write like this: error, if n2 is equal to 0, return error cannot divide by 0, and return n1 by n2. This is how we could do. Now talking about the main loop structure. So while true, you could select one is for addition, second is for subtraction, third is for multiplication, and fourth is for division, and q is for quit. So you could choose any input choice from the user, and you could ask him what he wants to do. Like, for example, if he wants to add two things, so he could choose 1. If he wants to subtract, he would press 2 and enter the choice. And if he wants to multiply, so he would choose 3. And if he wants to divide, he would choose option 4. Now, for example, if he doesn't want to calculate, and if he wants to quit this function, so what he can do, he could just press q. So here what we can do, we can write if choice is equal to q, break. So you could break the loop also, right? Now there are various methods to do this. Either we can do through this, or I'll show you one case also where user can put the number and operators too. Now handling user friendly choice, you could do like this, or you could directly take operation from the user, what he wants to do, addition, subtraction, multiplication, or something. Now our main loop logic is that you have to get two numbers, and you just have to perform the functions over there. Now let's move forward and see how we could do this. So the full program review is here, that you have to first the loop starts, then the user selects the number, then input collection is done, function execution is done, then result is displayed, and loop continues. There is one more method by which you could build a calculator, which I will be showing you right now. So these are all the reviews how you could do this. Now let me just show you over here. So for example, we have this simple calculator, print over here, and print operations, addition, subtraction, multiplication, and division. Instead of doing that 1 2 3 4 thing, we could directly take input from user. For example, we could write num1 float. He could enter first number, then we could enter the operator and the second number. Now what we can do, we can, if he wants to perform any of the calculation, for addition, we could return this result. So we have stored the result this. For subtraction, multiplication, division, and so on. For division, we just have to make sure he doesn't divide by 0. So if num2 is 0, we have to throw an error, right? So result num1 by num2 will only be done if num2 is not equal to 0. Exclamatory marks means not. And apart from this, if he chooses any other operator, we have to write invalid operator and then print the result over here. So this is our whole code. Now if I run this, so enter first number, let's say 3. I've entered. Now it is asking me to put an operator. I add this and I write 2. If I print, it will give me result 5. So 3 plus 2 is 5. This is how we have built our mini simple calculator and using functions. So this is a good mini project you could build, and you could also follow the things which were in the slides. So there are multiple ways to create any of the program or any of the project. So you could choose which suits best for you, right? So we have created the project. So section 5 is now over and we have mastered functions. Great. We have just 3 more sections to go. You have almost covered all the basics of Python. Now the course moved towards a little bit advanced sections. So this is how you could learn anything, function, scope, recursion, everything. Now talking about the next section is also important and a little bit advanced, which is file handling adventure. So the current state is that your programs lose all data when they close. So section 6 is that you could work with files for data persistence. So first topic will be file handling basics, and we will be learning everything over there. So I'll see you over there in the next lecture. Thank you. Welcome to section 6. We are moving into file handling. Up until now, when your calculator or word counter closes, all the data is lost because it only lived in the computer's temporary memory, or which we call RAM. Everything is lost. Today we solve that by learning how to give our programs persistent memory, saving and loading data from files on the hard drive. Now let us talk about the 3-step file handling process. First we have to open the connection, then we have to perform operations on it, then we have to close the connection. So now how to open the connection? The open function, the built-in open function in Python is a tool to establish that connection. It takes two main arguments: the file path, where the file is, and the mode, which tells Python what you intend to do with the file. When you run open, Python returns a special object called the file object, which is the tool we will use for our all operations. Now let us understand the step 1, which is understanding the open function. So purpose is that to create a file object that represents the connection between your program and the file. So this is our basic syntax, which is file object is equal to open. We have to write the file path and the mode. So these are the two key arguments, file path and mode. Right. Now file modes declaring your intentions. First you have to read mode, then it is write mode and append mode. So read mode, it is the default mode. It opens files for only reading. Important, if the file doesn't exist, Python will throw an error. Now let's talk about the write mode. It opens files for writing, creates the file if it doesn't exist, but there is a warning that it completely overwrites the existing content. And then there is append mode. So A is safer for adding data, as it writes new data to the very end of the file, preserving the old content. So depending on your intentions, you could use the file mode. Now you can see this, your first open example. What you can do, you have to create like this: a file handle is equal to open. You have to put the file name and you have to write. Now you have to print file handle. So whatever the file handle would be there, it will come over there, right? Now the last step, the crucial close method. It's very important because it has the purpose of closing and what happens if you don't close it. So basically when you have opened the file, you worked on the file, so after that you must close this. Your changes might not be saved if you don't close this. The file could remain logged and the system resources stay occupied unnecessarily, making your computer little bit slower. So this is the simple syntax: file underscore object dot close. So whatever the file object is, close function, use that and close it. Now closing files, a practical example: file handle is equal to open notes.txt and write mode. Your write operations would go here and then you can close the file also. So the best practice, the with the statement. So the with statement automatically close files even if error occurs during execution. Now this is industry standard that you must close this. Your operations go inside the intended block. As soon as the indentation ends, the file is automatically closed by Python. You never have to write .close manually. So it is a cleaner code. So you should remember this. Now if we use like something like this with open file, and we do the same thing, we write the file path and the mode as file object. Now everything is our intended code here, and whatever when we write our outside outside the indentation, the file will be automatically closed over here. Now with statement in action, so you can open any file like this with open data.txt, reading mode as F. F is our file object, file is open and ready for operations, right? You can write something like this and your read operations would go over there. Let me show you also this. For example, we have something like with open data dot txt, and let's open in reading mode. First we have to also create the file. So in this we have to create a new file which is going to be data.txt. This is a text file, and here we write Python is a great language, right? We have written something in file. Now if I write over here something like this, with open data.txt in reading mode as f. Now if we write print file is open and ready for operation, right? So if we write over here, now what will happen, we'll write over here print, and then we will write file connection automatically released, right? Something like this. So this is outside our intended block, and the file will be automatically closed. If I run this, so both things will happen and the file is ready to read. Now we don't need to use f dot close, else we will we have to write something like this, then f is equal to open, and we don't have to write this. And whenever we work on the file, and then after that we must use this f dot close. So instead of writing f dot close, we can use the with statement. So even if you forget to write f dot close, so it's not needed, right? Now file paths, where is your file? The relative path and the absolute path. By default, when you use a file name like scores.txt, Python looks for the file using a relative path in the same directory where your Python script is located. If the file is elsewhere, you need to provide the full absolute path starting from the computer's root, like from the C drive, something like this, or from Mac. So if it is in the same folder where you are running your script, so you can run this. Else, if it's somewhere else, you have to give the absolute path. Now let's talk about the file mode. Quick reference. So we have understood read, write and append mode, and in read, file must exist and it does not create a new file if we don't have a file. But in write and append, if we are writing a name of a file, and if that file doesn't exist, so it will create a new file thereover, whether in that folder or in that absolute path. So in reading, the old content is preserved, and in append also it is preserved, but in write mode it is overwritten, so you need to be careful. Now text files versus binary files. So basically there are two types of files. First are text files in which we read, for example .txt, .csv, .py files, and binary files are such that required for non-text files like images, videos or executable programs. Now you have to add b to your node for binary files. So for if you are reading in binary, so you have to use the rb. If you're writing in binary, you have to use wb, and if you are appending in binary, you have to use ab. So we will only concentrate on text modes using R, W and A throughout this section, right? Now let us talk about write versus append, understanding the difference. So write basically completely erases your existing content and it starts fresh. Your 100 and 200 disappear forever. For example, we have a list something like this. Now using append mode, it keeps existing data and adds new data after 200. Your original scores remains the same. So in append mode, whatever we write, for example if you want to write 300, so it will write over here and this will be kept. Whereas in write mode, this will be erased completely, and then from the starting we will write something. So you have to choose carefully based on whether you want to preserve existing data or not. Now let's see the preview file operations coming next. So we have some reading methods, .read, .readline, .readlines, and we have a write method. So we will be discussing this also. So basically reading methods, .read reads entire file. Read lines, if you have a lot of lines, so read line will only read one line, and if we use read lines, so it will read all the lines. This is the method. We will be discussing this in next lecture. And there is a writing method too, which writes text data to your file. Now you have to remember why closing is essential. So it frees system resources, it flushes write buffer, and it prevents file locking. So now the section 6 learning roadmap is very simple. We have these four functions, which is file handling basics, reading, writing, and appending. We will be doing this in next lecture. Now in the third lecture we will be seeing handling file errors safely, and in the last lecture we will be building a project which is a simple diary app. So in next lecture we will be doing reading and writing. So I will see you over there. Thank you. Welcome back. In our last lecture we established the crucial with statement for safely opening and closing files. Today we focus on step 2, operating, the actual reading and writing of the data. These are the methods that transfer information between your programs and the hard drive. So step 1 is to open the file, then we have to operate on it, whether we have to read, write, or append data using specific methods. Then we have to close the file. Right, so let us now first see writing data with .write function. So our purpose is that the write method sends string data directly to your file. So for example, if we write our file object .write, and we can write the content string over there. So the key rule is that it accepts only one string argument. You must handle line breaks manually. So whatever, if you write like lot of lines, so in the file it will go like in a one single line. So you may have to make sure that you have to use these line breaks over here, right? Now handling new lines in write function. So what we can do with this is that with open report.txt in write mode as f. Now you can write over here f.write user login successful. Then you have to create a new line, and then you have to write time. So basically in file you will be having something like this. Your file will be written. For example, let us see over here. If I write with open, I haven't created a file right now. No file is there, report.txt. Let's see if it creates a new file or not. So if I write over here, write as f, then I put the colon, so it is indented. Now if I write f.write user login successful, right? As you can see, right now I have no file over here, which is report.txt user login successful, and then I have to create a new line over here. So new line I have created, and then we write f.write, which is time 12:30 p.m. and then I again create a new line. It's not needed, but I am still creating it. Now if I run this, so let's see what will happen. So the program has been run, and now a new report.txt file has been created, and let's see what's inside the file. Inside the file it is written user login successful, time is, so we have successfully written in our file. So write mode automatically creates a new file if you don't have a file, and it, whatever we have written in this, for example, f.write user login successful, it writes in the file. This is how we can write in a function. Now let's talk about converting data types for writing. So the common error is that you are attempting to write numbers or other data types directly. That will cause a type error. The solution is that you have to use a string function to convert any data type into a string before writing. So how you can do this? So for example, you have a score something like 95. So you will write with open scores.txt in append mode, and if you want to write something like concatenate these two strings, so it will write something like this, score 95, but you have to convert it into a string. We have to write str score, right, something like this. Then this will be written in our file. So we have to convert the data. We don't have to directly write the numbers and or the floating values. Now appending data to files. Appending uses the same write method but requires opening the file in append mode. The A. Python automatically positions the file cursor at the end of the existing content before writing new data. So how you can append, for example, you have this file, let's say log.txt, and you are using append mode as f, and then you write f.write new log entry. So this is your old data and a new log entry will be done. Let me show you this also. For example, we have a file, let's say uh, log.txt. We have such a file, and here I have written over here some old data, right? For example, now if I go over here and I write that with open log.txt, and we write it as f, and over here we write new log entry, but we have to write this in append mode, right? Let's write it in append mode. So with open log.txt in append mode at f, and f.write will be new log entry. Now if I run this, so my program has successfully run. So now if I run this again, so we have got here old data and new log entry. So this is how it will work. Now let us talk about the reading data from the files. So we have three different functions in read mode, which is .read, which is .read line, and which is .read lines. So now let's look at getting data out of a file which requires read mode, which is R. We have three main methods, these. Now if we have to read the entire file, we will use .read method, right? And full text we can do like this, f.read. Then we can print total characters and whatever the length of the full text is. Now it is best for small configuration files, complete data analysis, and simple text processing. Now you could also do line by line reading with .read line method. It is perfect for processing very large files without loading everything into a memory simultaneously. The file cursor automatically moves forward after each line .read line call, ensuring you progress through the file sequentially. For example, you have a lot of data in this. So if I run the read line first, so it will read the first line first, then it will read second line. Right, so there is a strip method also. It is commonly used to remove unwanted white spaces and new line characters at the end of the string. So we could also read line from there, and we could also print the first line or the second line if we want to. So if we have read it, so we can extract the data from it too. Now you could also read all lines with read lines. So you have to use f.readlines, whatever the file object is, and then what you can do, then you can print total lines and length of lines list. So you must try this on your own and see what will happen. And over here lines list, if we do, and we write a 0 over here in the index, so its indexing is done on the basis of lines. So if we write 0 index number over here, so first line will be printed. So a list of strings where each string represents one line from the file. Each string includes the new line character. Now the most Pythonic approach is that the file object itself is an iterator, making it perfect for direct use in for loops. The best practice is that the approach is memory efficient and follows Python's philosophy of clean readable code. So Python's file reading could be done like this, we have already understood, and it is memory efficient and it has clean syntax. So you have to understand the file cursor also, where the Python's internal cursor, the pointer, moves through the file content. So if you are reading the operation, the cursor advances through the content. If you are at the end of the file, or you could also reset it with the seek function. So seek function is basically if you write reset with dot seek 0, so it moves cursor back to the beginning. Now we have this read versus write summary. So in read there is only are read lines. In write, you could write like this, write or append, and the method is dot write. Both it returns strings, it accepts strings, and read gets data from the file, and write sends data to the file. Next up, we have error handling. What happens when files don't exist? How you can prevent any program crash, or how you can try the try except block pattern. So we will be seeing this in next lecture, and I will see you over there. Thank you. Welcome back. We have mastered reading and writing, but now we must address the reality of working with external resources. File operations are inherently risky. Your program might try to read a file that the user deleted, leading to a file not found error, something like that. Or it might write to a logged file which says permission error or something. So if we don't handle these, the program simply crashes. Today we learn the essential skill of handling these expected failures gracefully using the try except block. The try except block is Python's mechanism for error management. So whatever the risky code is, you can write something that follow the try except block. The philosophy is try the risky code. You can try the risky code over here, try, and then it is intended. For example, opening a file, and if it does not works, if it fails, catch the error and run this safe. So fallback plan, instead of crashing, you put the risky code into the try block and the recovery code inside the except block. The flow is very straightforward. Python executes the try block first. If it succeeds, the except block is skipped entirely. If an error occurs during the try block, Python immediately stops that block and jumps straight to the matching except block to run the recovery code. Right, so first you enter the try block, then you check for errors, and then you handle the exceptions. So for example, we have this error, let's say file not found error. So this is the file name secretdata.txt. Now if I open in this read mode and read, so if instead of this, the program should not crash and write file not found error, we will simply print this line, error, the file is not found. So this approach prevents crashes and provides helpful feedback to users about what went wrong. Right, so instead of crashing the whole program, it will just print a line and it will execute the rest of the code. Now, handling multiple error types. You can include multiple text blocks to handle different error types with specific responses. Python checks except blocks from top to bottom, so order matters. So you don't have to catch only one type of error. You can include multiple except blocks to handle different failure types differently. You can tell the user file is missing versus permission denied, giving more specific feedback. Python check these except blocks from top to bottom. Right. Now the multiple error handling, you could do like this. You could try something like this, and if file not found error is there, permission error is there, or exception as an E is there, so we can print different line. So exception as E acts as a catch for all any unexpected errors. Always place this last. Right, so if any error which you cannot think of could occur by this, so you could place it at last and then it will work. Now let us talk about the finally block, which is optional. The purpose is that the code runs always whether the try succeeded or an except block executed. Now the placement should be, must be always placed at the last except block. The key use is that essential cleanup operations through with handles closing the file for us. So programmers used finally to ensure files were closed, and it is typically used for cleanup or logging that must happen regardless of the outcome. So it has a guarantee basically which executes regardless of the success or failure, ensuring critical tasks are completed. Now we can see a finally block example. So in this structure, no matter what happens inside the try block, the final message cleanup complete will always execute. This one. So it can try, then if there is error, so it will print this, but finally it will print this. This always runs. Now, practical use, safe input conversion. The file handling isn't only the place for try except. Remember the value error. When we got user types instead of instead when a user types a word instead of a number, we can use try except to solve this and ensure we get a valid input. So we can also use for the input thing too. So we wrap the risky line code int in user input conversion inside a try block, right? Something like this. It forces the user to write the valid input thing which he should write. So accept value error. So invalid input, please enter a whole number, something like this. So now the logic flow of safe input is that user input. User enters invalid data, for example 10. The conversion fails, int fails, raising a value error. Now the error is handled, except block runs, shows helpful message. Now the loop continues while true keeps asking for input. The success is that valid input converts successfully, function returns. Now the error naming and clarity. The best practice is that you can use something like this: accept exception as E. The variable E is an object containing the error details. Printing E is highly recommended because it gives you the developer precise information about what went wrong, which is invaluable during debugging. Now let's combine with and try except. With statement is that it guarantees files are closed safely, preventing resource leaks and system issues. Try except block is that guarantees programs don't crash when external issues occur during operations. Now here's a full safe file reading example. You must try this on your own. When I usually type, there is no error, so it's something like that, but you must use these try and except functions. So now also let us see when not to use try except. When you don't have to hide poor logic, avoid using try except to cover up simple mistakes like incorrect variable names. Use for expected failures, perfect for user input, file IO, network operations, and external resource access. The golden rule is that you must use try except for genuinely unpredictable external factors, not for fixing programming errors. So this was our complete file handling toolkit. We know how to open and close, we know how to write data, we know how to read data, and we also know about the error safety, how we can do this. So with open as f dot write, f dot read, f dot read lines, and f dot read line, many ways to read the data from the file. And then we have error safety also, which is try except block. The next lecture will be building a diary application. So we will create a file based diary app which remembers the user's entry between sessions, and we will use a lot of things, and I will see you over there. So we will be building a diary in next lecture. Thank you. Welcome to the final lecture and project for our file handling section. Our goal is to create a simple diary app that runs in the command line and stores all the user entries in a single text file called diary.txt. Now this project is our ultimate test of the file IO skills that we just learned. Now the plan is, the core functionality of the plan is that first we have to create a main loop. We will organize the app around 3 core steps: running a main loop with options, creating a specialized function to write new entries, and creating a specialized function to read all the past entries. Crucially, we wrap up our file operation in try except blocks for complete error proofing, right? So we will be using these 4 steps, and then now we have to now set up the getting the date. To make entries useful, we need a unique timestamp for each diary entry. Python's built-in datetime module provides perfect tools for this. So what we can do, we can import this datetime module. What happens through this is that, for example, now is equal to datetime.now. So it basically gives us the current date and the current time. So whatever we write our diary entry, so diary entry requires at what time you are writing. So for example, if it is 27th October and 2024, So it will write this, and let's say you are writing at 4:50 p.m. So it will first store this time and then it will start writing the diary, right? So this is how you can import the date time section now, and then you can format as a clean string, and you can now write the timestamp. So this is how you could set up the date. Don't worry, I will be showing you the code also. Now the function 1, that is write entry. Our goal is to get entry text from user and append it to diary.txt prefixed by the current date and time. So for example, see the write function, we have to use it in append mode, because we don't want our previous data to be erased off or completely be overwritten. Our goal is to write forward whatever the old data is present, and then we have to append every data in the diary. So this is our write entry function. We have done this, and here in input it will be storing your type, your entry, right? Now next we will use a save file write on the next slide. So what we have to do, here's the safety block. We wrap with the open, right? We will start with the with open in a try block. We use append mode A so we don't accidentally delete old entries. The write operation adds a new line first, then the timestamp, then the user's entry. Our general exception as E catches any unexpected error like a permission problem and prints a helpful message instead of crashing. Now we have to read the entries also. For example, if a diary is created and a user wants to read his or her old entries, whatever he has written, so we need this function read entries too. So our goal here is to read all lines from the diary and display them to the user in a clean format. Now the tools we will be using is R mode for reading and try except for file not found error handling. If the user hasn't written any file yet, the file won't exist. Now this is the code for save file read implementation. We will be skipping the code for now. I will be showing you the code too. Now here comes our main loop structure. So we have to create a function. The name of the function here is main app, and while it is true, what we can do, we can print a menu. The first option says write entry, the second says read entry, and the third option says quit. We have to take the input from user, which choice he needs. Now the main loop uses if elif statements to handle the user's choice. If the choice is 1 or 2, we simply call the respective function, outsourcing all the complex IO logic. If the choice is 3, we print a goodbye message and break to exit the while loop cleanly. So this is the code. Here is how we can exit it by using the break statement. Now let us test the write functionality. What we have to do, scenario 1, if we have to create a new diary, file doesn't exist. So the open diary.txt in append mode safely creates it automatically. And if there is an existing diary, the n/n ensures the new entry starts on a new line for readability. Now we also have to test the read functionality. Scenario 1, if there is an empty file, our logic if not content.strip handles this gracefully with a friendly message. And the second scenario could be there could be a missing file. We could get an exception, that is file not found error. So we will use try and except for this, which will prevent crash and guides the user appropriately. Now let us talk about the power of functions. Now you can see how the main app function is, and we can do the clean main app and the easy updates. Now this is the final code assembly. First we have to import the statements, then we have to define some functions, then we have to build our main application using the while loop, and then we have to call the function to call our main program. So this is how we have done. Now let me show you the code over here. So from date time module we have imported date time, right? Now we are writing this write entry where we will be taking input of the entry, whatever the user wants to write over here. Now whatever the exact date and time will be there, that will also be printed with it. So here first we will with open diary.txt, and we will append it as file, and we will also write the time and the entry in new lines, right? We will write over here, and then it will print entry saved successfully. Now if we want to read the entries, we have to try with that. First we have to open, then we have to write, it will be printed whatever is written in the diary. For this we also have an exception over here, which is try and in except block file not found error. So if there is no file, and if we want to print this file, so it will, instead of crashing the program, it will print no diary entries found. And this is our main loop, while true, and here we have given options like write new entry, read diary, or exit. Now choice here is that you could input choose an option. If choice is equal to 1, you could write the entry. If choice is equal to 2, you could read the entries, and if the choice is equal to 3, it is for exiting the loop. It will just print goodbye and it will break. If the users enter any number apart from 1, 2, or 3, it will print invalid choice and it will say try again. Let us now run our function. So there are 3 options. First I will select option 1. So it will say write your diary entry. So I will write Python is a great programming language. So it says entry saved successfully. Now let me check my file. I have our diary.txt over here, and it must have saved. Now if I want to read my diary, so here it is, Python is a great programming language. Basically the file is saved somewhere else, right? So this is it is saved in another folder, that's why. So we could read our diary here, and we could also write any new entry. If I choose option 3, and so it will exit the program and it will print goodbye. So this is how we could use this, and we have built our small project, our mini project, which is a diary. So you must be now understanding how well we can do this. Now here it is, file handling mastery, the review. Safety first. Use of try, except, and with is now second nature for robust code. Data persistencies should also be there. Data is now saved and recovered across program runs seamlessly. Mode mastery, use correct A for append, and that's all. Congratulations, you have mastered opening and closing files, reading, writing data, and graceful error handling. Now you have completed 100% of the file operations. You have completely achieved the mastery. Now next we have, in next section, it is object oriented programming, and we will be studying all this over there in OOPS. So I will see you in the next lecture. Thank you. Welcome to section 7. This is a major turning point in the course. We are shifting from structured programming, where we focus on the list of instructions, to object oriented programming, to OOPS, where we focus on building programs around things or objects. Think of it as moving from writing a recipe to creating the actual chef to perform the own instructions. So you could understand the chef analogy. Now let us talk about what is the difference between structured versus object oriented programming. So structured programming focus on actions and functions, whereas object oriented programming focus on entities and projects. This focus on data and function exists separately. Here in OOPS, data and functions are bundled together. We have such functions, for example, write entry, calculate total, something. In object oriented programming, it is like user, car, bank account objects, etc. Like following a cookbook step by step. And in OOPS, we have intelligent tools that know how to use themselves, right? This is how it works. Now for first is our core concept one, that is class, the blueprint. Now what is a class? A class is not the actual object. It is the blueprint or the template used to create the object. It defines two things: the properties that all objects of this type will possess, and behaviors that all objects of this type can perform. For example, the car class defines that all cars have a property called color and a behavior called drive, something like this. So we have properties and behaviors. So as this is the example of a car, for it defines all the car have properties like color and model plus behaviors like start and accelerate, something like this. Now here's the core concept 2, object, which is the instance. So in OOPS you have to take care of two things, which is class and object. So class was our blueprint and object is our instance, right? Now from blueprint to reality, an object is a concrete instance created from a class. It's the actual thing built from the blueprint. Now many objects can have one class. You can create unlimited objects from a single class. Each object has its own unique data but follows the same structure. Now there are some concrete examples too. The car class is the plan. Your actual blue Honda and your friend's red Tesla are two subject object instances, right? So like we have a class, let's say car, but the object, or maybe it could be a red Tesla. So this is how you can understand this. Now let us understand all the properties and behaviors. So properties are the attributes and behaviors are the methods. So properties are name, age, color, size, weight, price, status, location, ID. Behavior are drive, login, calculate, save, delete, update, start, stop, pause. These are some behavior methods. Now for example, if we create a dog class, right, the blueprint that defines what all dog objects will have. So properties could be such that name, breed, age, weight. These are the properties of the dog class. Whereas there could be some behaviors like bark, fetch, sleep, eat, right? So dog does this thing, but it has properties such that. Now there are some benefits of OOPS, why you should choose object oriented programming. So it is a real world modeling. OOPS is popular because it helps us model the real world better, making programs easier to think about it. It also promotes massive code reusability. You can create new classes based on existing ones. And it makes maintenance easier because related data and logic are all in one place. The four pillars of OOP. Now we will be studying that. The four pillars of OOP are encapsulation, abstraction, inheritance, and polymorphism. So they are encapsulation is today we are focusing on encapsulation. So the encapsulation means that the act of bundling data and the methods that operate on data together. So today's focus is going to be encapsulation, the most immediate benefit. Encapsulation ensures that a data's object's data's properties can only be accessed and modified through the object's own method, not directly outside the code. This protects the data integrity and prevents other part of the program from accidentally messing up with the object's state. So object states is to be kept safe. So for this we use encapsulation. We will be seeing some examples too. For example, we can transition to Python code. We could define the class. In Python we create classes using the class keyword followed by the class name. Now the basic syntax is that we have to write class and class name. Now for example, class body goes here, properties and method. For now, if we are not writing here, we can use pass over here. We have studied pass. The pass statement is a placeholder that allows us to create an empty class structure without errors. Now let us create our first class. For example, we have created our class student and we are making student blueprint. So what we have created, a simple class definition that serves as a template. Now, right now it's empty, but it's ready to hold our properties and methods. The naming convention is such that student uses Pascal case. Each word starts with a capital letter. This is Python's standard for class names. Now creating objects, that is instantiation. The process creating an object from a class. We call the class name like it's a function to create new instances. For example, if we have to create a new object, so we write the class name over here. This is the syntax pattern we can see. Now, instantiation in action. So these are we are creating two separate student objects instances, student 1 and student 2. In both we just have to write the class and put the parenthesis. So student 1, if we write student and parenthesis, so it creates the first student object and assigns it to the variable student 1. Student 2 is creates a second completely independent student object assigned to student 2. These are two distinct objects. Now how do we have to work with the object attributes? Dot notation, the key to object properties. Syntax pattern is such that object name dot attribute name is equal to value. We will be seeing some examples too. For example, student 1 dot name is equal to Dan. This is how we could assign some attributes. Student 1 dot score is equal to 88. Student 2 dot name is Eve. Student 2 dot score is 92. So here in student 1 object, what is stored? The name is stored as Dan and score is stored as 88. Student 2 object, name is Eve and score is 92. Now accessing attribute values. If you want to print any of the students name or the student score, anyone if you like, you could print like this. So we can also read data, use object attribute to access stored values from any object instance. You could also display the results, combine with f strings or print statements to show object data in a formatted way. Now next up is that we have to make this automatic. Current limitation is that we are manually assigning the attributes after creating objects. It is clumsy and error prone. We need a better way to set up our objects automatically when they are created. Now next lecture we will be studying all the constructor method, so I will see you over there. For now it's the same thing, right? So I will see you over there. Thank you. Welcome back. In our last lecture we learned the concepts of class and object. Today we write the code that brings our blueprints to life. We're going to define methods, the object's behavior, and understand the most critical concept in OOP, the self parameter. Just to quickly review, we define the dog blueprint using the class keyword. We create concrete objects or instances by calling the class name like a function such as dog1 is equal to dog, something like this. Now we have to define the methods, which is the behavior. A method is simply a function that lives inside the class definition. The most crucial rule is that every method must take the special parameter self as the very first argument. You can add other parameters after self if the method needs more input. So for example, we have a class over here, class name. Then we write we can define methods by def method name. Then we can write over here self, and then we can write param1 and param2. So, and inside this is the method body. Now the self parameter, the key concept. What is self? It's a reference to a specific object instance that the method is being called on. The flow: when you call dog1.bark, Python automatically passes the dog1 object as the self argument. Also the naming convention. Though you could rename it, the convention is always self stick to the standard. Now how we could there's an example, the bark method. Here's the simple method. It takes only self when we call dog1.bark, right? So the output is woof woof. So def bark self, so takes self only, it will print this. Now if I run over here dog1.bark, so the code inside runs it. Simple behaviors are defined such way. Now we could see how we could access attributes with self. To actually make the object useful, methods must be able to access the object's unique data. To access or create an attribute from within a method, you must prefix it with self dot notation. This tells Python use the name attribute of the object instance I am currently referencing. Now the method and attribute example are such that we have let's say class dog over here. The set name method takes the new name and assign it to self.name. Now the bark method can access the name using self.name and print a personalized message. The data and the behavior are now bundled. So this is how we could first create a class dog. Then we could do def set names self new name self.name. Now here it would be new name assigns name to this object, and when we say let's say def bark self, so here will be self name says woof. Now tracing the flow, two separate objects. This example clearly shows why self is essential. When we call dog a dot set name max, self is dog a, and only dog a dot name, this dog a dot name gets max. When we call dog b dot set name Lucy, self is dog b and dog b dot name gets Lucy. The two objects remain completely independent. They are both different, and self refers to here dog a and here it refers to dog b. Dog a dot bark and dog b dot bark. Now we will be seeing how we could add parameters to methods. So there are these three things. Always start with self. The first parameter must be self. Now second is that you have to add parameters. Include any additional arguments your method needs. Use them in the method body. Access parameters normally attributes with self, right? This is how you could do this. Methods are flexible just like functions. They can accept input after the required self parameter. In this example, the count parameter holds the number of treats we want to give. Now here is a parameterized method example. Here is the class dog, and we could create a method that is def give treat self count. Self.treat count is equal to count, and we could print this also. Now assuming dog a name is max, so we can write like this: dog a dot give treats 5. So now this will give this output from here. The self name is max over here, and the treat count will, let's say we have defined it as 5. So the output here will be max got 5 treats. Now method can return values. Don't forget that methods are functions, so they can and often should use the return keyword to send a value back to the caller. This is essential for calculations. Method return example. Let's see an example how we can return it. So for example, we have the class dog and we have this human age self. Now we have to return self age into 7, right? So dog years might be, the actual age might be 4. Traditional conversion factor, we can convert it by a multiplier, let's say 7. So I can say it is 28 human years old. So how I did it, I just write a method over here, and in this method I wrote return self age into 7. So if I use this function def human age self, so what will happen, anything I put into this self will be multiplied by 7. Now benefits review bundling encapsulation. Now you have successfully achieved encapsulation. We have bundled the self name and the logic bark into a single dog object, which is a cornerstone of OOPS. Now the best practice is to, for method naming, it could be snake case, or you could use action verbs also. Now let's take a final check on self. You must define self as the first parameter in every method. You must use self.attribute to reference object inside any data method. And you must not pass a value for self when calling the method. Python handles it automatically. So here's the review method call flow. First, the caller, for example, dog1.bark. So Python finds the bark method and passes dog1 as the self argument. Now here's the third method, uses self to access data specific to dog1. Result is that action is performed on the corner object. Now next up we have automation, and we will be studying this init, constructor and attributes. So we will learn about the special method that automates object setup when it is first created, making our code much cleaner and more professional. So I will see you over there. Thank you. Welcome back. In our last lecture, we successfully defined methods and used the self parameter to access the attributes. However, our setup was clumsy. We had to create the object and then manually assign its name and age. Today we fix that by introducing the init constructor, the most important method in any class. So, for example, what was our problem? Our problem was to manually set attributes dog.name is equal to max after object creation is inefficient and error prone. Objects might exist in incomplete states leading to bugs. So the solution is this init constructor. We will be studying about this in this lecture. So we have to first understand this init method. What does this mean? So the role of this is to initialize for new objects. It sets up for the object's initial data and attributes automatically. Talking about the syntax, defined like any method but with double underscores before and after the name. So these are two underscores and then you have written init, then two underscores. The rule is must take care self as its first parameter to reference the instance being created. Now let us talk about what is the init syntax in action. Just like any method, init must take self as its first parameter, which represents new object being created. All other parameters, name, age, etc., are the inputs we require from the user when they create the object. Inside the body, we assign those inputs to object's permanent attributes using the self.attribute is equal to parameter. Right. So for example, here self.name is equal to name, self.age is equal to age. So instead of this, what we can do, we can use this function init, and then we can write self, name and age. So it automatically assigns input to the object's attributes, right? So now you can notice how self represents the objects being created while the parameters capture the data we want to store in that object. Object creation flow. So first what we have to do, when you call like dog Lucy, 3, dog 1 is equal to dog Lucy, 3, object creation is done. Python creates an empty dog object in memory ready for initialization. Auto init call. Python automatically calls init passing the empty object as self and your arguments. And then the attribute assignment is done. So for example, instead of using this self.name, self.age, init automatically uses it and creates it on new object, completing the initialization. Now let us take an initialization example. So for example, first we write something like this, class user, then we write def init self username email, then it automatically assigns this. Now we can also set a default attributes such as self is logged in false, and then object creation and setup in one line. For example, user1 is user, Alice code is the username, and alice@example.com is its email. Now if I want to print the username of the first user, I can simply write print user1.username and the output will be Alice code, right? So this demonstrates how init combines user inputs with default values to create fully configured objects instantly. Now let us talk about parameters versus attributes. So the parameters are temporary variables in the init signature like name and age. They exist only during initialization. But in attributes, they are permanent data stored on the object, always prefixed with self dot, like self.name, self.age, something like this, right? Now let us see about the default values in attributes. The direct assignment is that attributes can be set directly inside init without needing an input parameter. Common use cases: status, flags, counters, timestamps or constants that every object needs. So we can set default values in this. As seen in is logged in, you don't need a parameter for every attribute. Attributes like status flags or counters that should be the same for every new object can be set directly inside init to a fixed value. This ensures all objects start in a predictable state. Instance attributes explained. Each object gets its own copy. Any attribute created using self dot is an instance attribute. This means every object gets its own unique copy. User 1 and user 2 each have a separate username variable that only they can access. This is essential for distinguishing between objects. Now let us see adding methods to the class. Once the data is set up in init, all the other methods in the class can rely on that data being present. Every method needs self to access the attributes set up by init. So every method needs self to access them. What you have to remember is that self is the gateway to accessing objects data from within any method. Now let us see methods using attributes example. So if you have created def init something like this and you write here self name and balance, then it auto assigns this self dot name is equal to name, self dot balance is equal to balance. Now if we set self def deposit, so self amount, now self dot balance will be, it will add to the amount. Now we can, if we want to print new balance, we can print the name and the balance like this. Now initialization and call method, so you can write something like this: client is equal to user, the name of the user is Bob, and the balance is right now 500. But if the client deposits 100 rupees, the balance for Bob will be now 600 rupees. 600. Now how the deposit method seamlessly access both self.name and self.balance to perform its own operation. So this is how we can automate things. Now why init matters? Init ensures every object is created in a valid complete state from the moment it exists. Now the required data is that it guarantees all essential data like username, ID is present when the object is instantiated. Error prevention prevents incomplete objects that could cause runtime errors or unexpected behavior. Without init, it is the risky approach because unsafe manual setup is done. User 1 is equal to user 1 dot name Alice, and user 1 dot email is this email. So what if you forget this or this? So without init, you must set attributes manually, risking incomplete objects and hard to debug errors. Within it's a safe approach that we have seen, and for documentation it is the best practice for class doc strings. You can describe the purpose and responsibilities of the class, what does it represent, and init docstring also document the required input parameters, their types and what they represent. Now there are some default arguments also, as we have seen. If you want to do available is optional, defaults to true. So if any of the book is there, it is set to available. The title is first set and then it is set to available, right? And if you want to change the availability status, we can manually change this. Else by default the status will be available, right? Now we are achieving encapsulation like data plus methods and encapsulation example. So this is a fundamental principle of object oriented programming, keeping related data and behavior together. So next up is shared data. What's next coming up? So next lecture will be going to be about class attributes and static methods. So we will be exploring new concepts, explore data that is shared across all objects of a class. So I'll see you over there and we will be studying this new thing. Thank you. Welcome back. So far, every attribute we have created has been an instance attribute, unique data attached to a specific object using self dot. Right. So previous focus was on instance attributes. Today's concept will be about exploring class attributes for shared data and static methods for utility function. Let's take a quick review about the instance attributes. We use init using self. Each object has its own unique copy and they could be modified independently for each instance. For example, user1.count is completely separate from user2.count. Now let us understand class attributes. What is shared data? So a class attribute, the definition of this is that it is a data that is shared among all instances of a class. You define it directly inside a class of a body outside of any method. If any object changes this attribute, the change is reflected in all other objects instantly. This is perfect for things like constants or counters that need a global reference, right? Now let us see some example. What does class attribute example means? So for example, we have a class car. Class attribute could be shared across all car objects. So wheels is equal to 4, instance count is equal to 0. Now we have created this definite self and color. Self dot color will be color, and car dot instance count we will increase it via class name. Notice how wheels and instance count are defined outside of any method. They belong to the entire class. So every car has 4 wheels, right? And whatever the instance counted, we can increase it. So we can just declare these are like you can understand like some the global variables, but here inside the class. Now accessing class attributes. So car 1 could be red and car 2 could be blue. But if you want to print the wheels, every car has 4 wheels, right? So these are the attributes. So if I want to print these wheels, so this is defined outside any method, and we could use this as a class attribute. Now the use case is that after creating car 1 and car 2, the car dot instance count class attribute is now 2. This is a very common and powerful OOP pattern for tracking the number of objects you have in your program. Right. Now let us see the difference between instance and class attributes. So the location of instance is it is inside init, and class attribute is outside all methods. Prefix is self.name and class attributes is class name.name. The scope is unique per object and class attribute shared by all objects. Mutability changed via self, and class attribute is changed via class name. Now let us talk about the static methods. What are the utility actions? What are static methods? Methods that belong to the class but don't operate on specific instance data. They are utility functions related to the class. So the key features are: do not take self as parameter, required the static method decorator above the method definition. Now this is the static method syntax. For example, we have this class utility. Now add the rate static method. Now def validate input data, and it performs general checks, doesn't need selves. So what you can do, we can return data is alpha. So the static method decorator tells Python this method doesn't need access to instance data via self. Now we could also call some classic method static methods. Since static methods don't need an instance, you usually call them directly using the class name, like the utility.validate input name. This makes them behave like a grouped utility functions. Now let us see the use case of data validation. So input validation and utility functions. Static methods are ideal for validation. Before you even create a user object, you can call user isValidEmail test@mail.com to check the data. It is related to the user class but doesn't need to access any specific user's attribute. Now let us talk about the static method example. So here's the validate username method. It checks the username length and character type. We call this before we try to instantiate a new user. If it returns false, we don't need to proceed with the object creation, right? So we can this is a static method, and we can create it before the user objects. So it can check the length of and character requirements. So it would return length name greater than 4 and name if it is alum. Alum is our function which tells us if it is alphanumeric, right? Now static versus regular method. The table clarifies the difference. If you need self.name or self.score for your method to work, it must be a regular method that takes self dot. If it's a general helper that only needs its own inputs, make it static. When to use static methods, let us see. So when we have to build some logical connection, then we could build. If we have no instance data, and if we want a cleaner code and we want to avoid unnecessarily self parameter when not needed. So shared versus unique data for init uh, is done using self. Now shared data is class attributes defined outside methods accessed via class names. And shared actions could be the static method decorator, and no self parameter is needed. So we have covered almost all this, all about oops. Now when to use self. Method needs self when it uses any data unique to the object instance like self.name or self.balance. Then we need to use self. Now when should we use this static method? It's a general utility that only uses input parameters and doesn't access instant data. So next is going to be the final lecture. Not the final lecture. We are covering the last topic of OOPS in the next lecture. That is going to be inheritance and method overwriting. So how we could build on classes and how we could use inheritance. So we will be seeing that in next lecture. So I'll see you over there. Thank you. Welcome back. Today we dive into inheritance, the third and the most powerful pillar of object oriented programming. Inheritance is all about code reusability. It allows us to set up a hierarchy where general classes share their properties and behaviors with more specialized classes, saving us massive amounts of time and ensuring we stick to the dry principle, don't repeat yourself. Right, so this our dry principle is very crucial, and inheritance is also based on it. So inheritance has basically parent and child classes. So the parent class is the base or the superclass, the general class whose properties and methods are inherited by other classes. It contains common attributes, defines shared behavior, and forms the foundation. Talking about the child class or the derived and subclass, the specialized class that inherits from the parent's class is gains parent's attributes, adds unique feature, and can override parent methods. In this relationship, we have the parent class, which is the general entity like an animal, but the child class or subclass is the specialized entity like a dog. The relationship is that the child is a parent, a dog is an animal, and it gains all the basic animal characteristics for free. Now let us see the inheritance syntax. Like we have this class parent, and then we have class child, and in this parenthesis we write the parent. So here we are writing pass just to make sure that it doesn't crash. So this is the syntax. This is the line. This line is the link that establishes hierarchy. Now let us see some example. For example, we have this parent class, which is class animal. Now def init self comma name. Self dot name is equal to name, and def eat is self. Now what we can do? We can do self dot name is eating something, right? Now child class inheriting from animal. Class dog animal, def bark self, print woof. So in this code, the animal parent class defines the name attribute via init and a general eat method. The dog child class inherits from animal and add its own unique behavior bark. Right. Now let us see about the inheritance and action. Look at the call. When we create my dog, we pass buddy to the animal init. Even though the eat method is defined in animal, we can call it directly on the my dog object. This is the magic of inheritance. All methods and attributes from the parent are instantly available to the child. Now let us talk about method overwriting. The definition of it is that defining a method in the child class that has the exact same name as a method in the parent class. The effect of this is the child's version of the method replaces it overrides the parent's version when called. Sometimes the parent behavior is too generic. For example, animal.eat just prints a general message. A dog eats kibble differently than bird eats seeds. Method overwriting is the solution. We define a method in the child class with the exact same name and signature as the parent's method. When the method is called on the child object, the child's version runs instead. Now let us take an example of overriding. So here override eat in the dog. We have this class dog, and in this, when we are overriding eat in the dog class. Now when we call new dog dot eat, when we call this, so basically what happens is that Rex is rapidly devouring kibble. The more specific dog focused method runs, replacing the general animal version. Now let us talk about the super function. What is its purpose? It allows the child class to call a method from its parent's class. So the most common use of super is inside the child's init method. The dog needs to handle its unique breed attribute, but it also needs the animal to handle the shared name attribute. So we use super dot init name. The syntax is something like this: super dot method name arguments to hand off the name setup to the parent, and then child handle its own specific attributes. So here's an example. So this is how we do this, right? Now let us trace the superflow. Let us understand how we can trace the superflow. So first step is that we have to dog max and lab is called. Then step 2, dog init runs. And step 3, super.init name executes animal.init max. Now self.name max is set by the parent. Dog init finishes by setting self.breed is lab. So this is how inheritance work. Multi-level inheritance. Classes can inherit from classes that are already inherited from another class. So animal is the base class with name and eat method. Then comes the dog, inherits from animal, adds bark method. And when puppy comes, it inherits from dog from its parent, gains methods from both dog and animal, because it has its features, and this will be having the dog features. Like puppy will have dog features, and since dog features have animal features, so puppy will have both these features. Now here's a multi-level example. For example, class puppy dog, then we can def sleep self, puppy is sleeping. Now we can do like this. We can inherit from animal, inherit from dog, unique to puppy. Now the benefits of inheritance is that the main key takeaways are code reduction. So you write the base logic once, and then there is consistency. You ensure all child objects share the same core attributes. Also flexibility comes. You can change the behavior using overriding without disrupting the rest of the application. Now let us take a final check on overriding. So when you override a method, make sure the name and the number of parameters you accept are exactly the same as parent's method. Otherwise, Python may not recognize it as an override. So we have completed oops. So we have done classes and objects, blueprint and instance creation. We have also done encapsulation, data production via self and init. Also, we have done inheritance, code reuse via parent-child hierarchy. So next we have our Capstone project, which is our student report card application. So we will be using oops and developing a student report card application in which we have to we have to hide something, or we have to show something, or there's a specific attribute which is common among all the students. So we will be doing all this in the next lecture, and I'll see you in the next lecture. Thank you. Welcome to the final lecture of our oops section. Today is our Capstone project, building a student report card app. Our goal is to use the class structure to a model, treating each student as a single object that manages its own list of grades and calculates its own performance. This is the ultimate test of your OOP understanding. So first you have to plan the modeling the entity. We will define the student class first. We use the init constructor to initialize the student's unique attributes like their names and their grades. We will then define specific methods for adding data, calculating averages, and presenting the final report. Right? So let us see. So step 1 is defining the student class. We begin with the basic blueprint called the capitalized class name. I have included a doc string which is good for practice and describing the class is intended to. So we could also, write this blueprint over here, how this works. And then we have to just define this class student. Then the init constructor. Basically what happens is that the purpose sets the required name parameter and initializes grades as an empty list. Key point is here that this creates instance attribute with default values for every new student object. So this is how we do a def init self name self dot name is equal to name, self dot grades is list, and self dot is active is equal to true. Now our step 3a, method for adding data add grade. So this is our function, how we can write. This is a method. So basically what happens is that if score is between 0 to 100, we could append the score, else we will print that score must be between 0 and 100. This method ensures only valid grades 0 to 100 are added, preventing data corruption. Then we could also get average, something like this. It's not necessary that we get this or not. Also there is now method for reporting grade letter. So it depends on what the marks the student gets. If he gets more than 90, we will do A. If he gets more than 80, we will do B. If it gets more than 70, we will do C, and else we will return D. So we will be replacing this numbers by the grade letters depending on which they occur. Now the method for final output, how to get the report, we will also be creating this. We will not create exactly same what there is in slides. I'll show you how the whole code too. So we are just seeing the steps what all we have to do in the project, and you must try this building your project on your own, which will enhance your skills, and you will see some practical real life application of all the things that we are studying. So step 4 is to we have two independent objects, students S1 and S2. So this is like Marie Curie and this is like Alan Turing. So because of our init constructor, we create and initialize both in one clean line, and we know that their grade lists are completely separate. Now let us test S1 Marie Curie. We could test by adding multiple store and verifying storage, if it is storing in a list or something like this or not. For student 2, we could also do the same, and then we have to display the report. So let's now see the code. So here first we have this class student over here. Then we have def init. In this we have self, name, and roll number. Now self dot name will take the name, self dot roll number will take the roll number, and in self dot marks we will store the marks. It is an empty list right now. So now we can add marks. So self dot marks, for every subject we can enter the marks. Then for total marks we will return the sum of all the marks values, right? Now we can also do for percentage, right? We have this total marks, and then we will divide by the length of the self marks. Like the percentage is what? For example, the marks are out of 100. So if 4 subjects out of there and someone has scored 390 out of 400, so we can simply divide by 4 and we could get the percentage. Now talking about the def grade, we have done this grading depending upon the marks, like A greater than 90, A plus, greater than 80, A, something like this. Then we have to display the report. So if we have to display the report, we will display like this student report card. Then we will self dot name, self dot roll number, we will show the name and roll number. Then we will for every subject and marks we could do this. Then total marks will be calculated from the above function, and percentage would be calculated, and grade will be calculated too. Now we have to see the example usage, which is if name is equal to main, and we could input the student name and roll number. So here we could input this, Now we could input enter number of subjects. So how many subjects are there? For example, if there are 3 subjects, so this will run till 3. 0, 1 and 2 will be the index number of those subjects. And for subject, this is subject input enter subject name, then we will have to enter the marks. So we will convert this marks into float, which is enter marks in subject. Now student dot add marks subject marks, and here is student dot display report. So this is how we could do this. Now let us run the function. So it is asking me enter student name, so I will enter over here Harsh. Now the roll number, let's say I set as 1. Enter the number of subjects, let's say I am entering 3 subjects. Subject name is, let's say first is maths, and enter marks in maths, let's say I enter 98. Enter subject name. Now I will enter science, and the marks in science, let's say it is 90. Then I will enter the subject, let's say computer science, and in computer science he has 95. Now when I press enter, I will have this report. Student report card, name is Harsh, roll number is 1, subject and marks we have got it over here. Then we have got the total marks, we have got the percentage, and we also have got the grade. So this is how we can use classes and all the concepts of OOPS, the object oriented programming. Whatever we were studying from the past 5 lectures is applicable here, and this is the most practical use case you could see of OOPS, and it is used in various places, like when you write very big code. So classes and objects are used just to make sure all the data privacy and encapsulation, data doesn't get corrupt, and for many reasons we use this. So this is how we use this, and we complete section 7 with this. Now we have completed all the basic and some advanced topics of Python. So this is all for this course. In the next section, section 8, we will be building some capstone projects. So I'll see you over there. Thank you. Welcome to the section 8 of this course, and this is going to be the final section, and we will be building some capstone projects. So our first project is going to be snake water gun game. So first we have to import this random module to use random function. I'll tell you why it is used. Now let us talk about the snake water gun game. So first let us write all the intro. First we create this function which is game, and here we print snake water gun game. Now here are the rules. Snake drinks water, so snake wins. So basically there will be 2 players in this game. First will be the user and second will be the computer. So both users will choose either snake, water or gun, and snake, if user 1 has put snake and user 2 has put water, so snake will win because snake drinks water. And gun kills snake, so gun will win, and water rusts gun, so water wins. So we have only 3 choices: snake, water or gun. Now there is computer. Computer we have imported will give random dot choices from choices. So computer will randomly select from snake, water or gun. For this we have imported this random module. So now from user we will ask you must enter your choice, either it's a snake, water or gun, and we will lower it in case the user uses capital S, capital W or something like that. So we will lower it to uniform the case. Now if user not in choices, so print invalid choice. If the user has entered any of the something else apart from these 3, so we have to write invalid choice. Now we have to print what the user chose and what the computer chose. So computer will choose it randomly. Now if user and computer chose both the same, then we will print it's a draw. Elif we will use the win conditions. So if user is equal to snake and computer is equal to water, or user is equal to gun and computer is equal to snake, or user is equal to water and computer is equal to gun, so we will write you win because these are all the winning things from this. Else we will write computer wins. Right now, if you want to run the game, we will write if name is equal to main, and if someone wants to play again, he will press y, and while play again, we can lower the y too. We will call the game function again, and at the end we will again ask, do you want to play again, yes or no, something like this. So this is the code. Now let us run this. So it has told me first snake water gun game, and these are the rules, and now I have to enter my choice. Let's say it is water. So you chose water, computer chose snake, so computer wins. Now do I want to play again? Yes. Now I will choose snake. So computer also chose snake. Now it's a draw. Now if I play again, so now this time I'll choose gun. So computer also chose gun this time. I'll play now again. Now I again chose gun. So computer chose water this time, so computer will win. So it's not fixed or something. Computer also chooses randomly. So this is a pure luck based game. So this is how you can also create your own program, something like this, and you must go and type it in your computer and write this, because we have done all the things, and this is how we could make. So this is how it works, and it's really great. Now in the next lecture we will be building another project which is going to be the perfect guess. So I'll see you over there. Thank you. Hello everyone, welcome back to the second lecture, and in this we are going to create a perfect guess game. So we will import random again, and then we will print welcome to the perfect guess game. Here we will use random module, and from random module we will be using this rand int function from this module, which will choose a random number between 1 and 100. So rand int is basically a function inside this random module which chooses a random function between a particular range. So guess is right now none, and attempts are right now 0. So while you cannot guess the number, so it works on try and accept method. So for example, guess will ask you to enter your guess between 1 to 100. Now your attempts will keep increasing. So if you guess your guess is less than the number, it will print too low or try again. So it will tell you in what range are you playing. And if it is more than your number, so it will tell you too high, try again. And else it will print perfect, you guessed it in these many attempts. Except value error, if you don't put a valid number, if you don't put a number between 1 and 100, then it will be problematic, and it will do like this, and at the end it will write thanks for playing. So this is a very simple code but a great project. So if I run this, so it is telling me to enter your guess, right, from 1 to 100. Let's say I enter over here 30. So it is saying too high, try again. So let me check for 15. It is again saying too high. So I am now sure that my number is between 1 to 15. Now let us check with 5. So it's saying is too high again. So let us check with 2. It is saying too high. Maybe the number is 1. Yes, the computer number was 1. He chose a random number between 1 and 100 to be 100. And this is, so it told me that you guessed it in 5 attempts. Thanks for playing. Now if I run it over again, now I again play, and let's say write 50. So it is saying too low, try again. Let me try for 73. It is saying too high. Let me try for 65. It is saying too high. So the number is somewhere between 50 and 65. Now if I let's say 57, so it is again saying too high. Now let me check for 52. It is too low. 54, let's say, too low. So the number might be 55 or 56. Yes, it is 55, and we guessed it in 7 attempts. Thanks for playing. So this is how this is a great game, and you could build it using, see, these are simple concepts. First we have just to use those random module, and then we have this guess, and we have these attempts also. While guess is not equal to number, we can use this try except using error handling, and we could build our project. So that's it for this lecture, and I hope you are enjoying these building this project. Now the next is going to be the final lecture of the section and the course, which is to create a to-do list app which is going to be text based. So we will be creating something like this in the next lecture. So I'll see you over there. Thank you. Welcome back to the final Capstone project. This comprehensive application brings together everything you have learned in this Python course. You will build a command line to-do list that cleverly saves and loads tasks to a file, demonstrating real-world programming skills. So this program synthesizes classes, maybe oops, and file handling, persistence, lists, collections, and functions modularity. So the master plan is that to integrate the algorithm. First we will make some functions, and then we will use those functions. So there's a list, empty list, which is tasks, and then we have show menu, and here we have this to-do list menu. So here we have few options. We can add task, we can view task, we can mark task as done, or we could also delete the task. And if we don't want to use the diary, we could exit the task too. Now we create a function over here which is def add tasks. So here what happens is that in add task we input enter task. So we could also append the task, and by default, see, we learned this in oops. By default we are going to keep done as false, because if we are entering a new task, so obviously it is not done yet. And so here we will print task added successfully. We just have to append a new task in the task list, which is this empty list we created. Now if we want to view the tasks whatever we have created, so if not task, if the task is empty, so we will write over here no tasks yet, and we will return. Now if you want to print your task, if there are tasks available, so for I and t in enumerate task 1, we will print the status done if t is done, and if it is something else we'll write pending. So we could print the task and its status. We could also mark done. In first we will view task, then we will enter task number to mark as done. So if the task number is between 1 and whatever the task length is, we can mark it as done. Else we will print invalid task number. And if there is a value error, so we will ask the user to enter a valid number. So this is how we could mark a task done. Now here are some a function to delete the task. So we have this view task. We could try to delete the task too, same as we were marking done the task. So it would first show us all the tasks, then it would ask the number, which number we want to delete. So similarly we can delete it as similar to that function, the mark done function. The basic difference is that we were there marking done. In here in the last line we will be saying that we are popping, we will be removing this function. Removed is equal to task dot pop. Now comes the main loop, which is while true show menu. We have a choice input which chooses an option between 1 to 5. If the choice is equal to 1, we would add task. Choice is 2, we would view task, and if choice is 3, we would mark this choice as mark done, and if the choice is 4, we would delete the task. Now there are some choices like 5, we could exit also. In exit, if the choice is 5, we will break the loop and exit. Now if I run this, now I have a to-do list menu and 5 tasks. So if I want to add a task over here, so it will say enter task. So let's say our first task is to study. So here it has given me task added successfully. Now if I want to add another task, bracket came, so see, it said invalid choice, try again. Now if I write over here 1, so it will say enter task. Now let's say another task is gym. So this gym task is also added successfully. Let's say we have to add another task, and let's say studying is done, gym is done, and let's say the third task is to go for a walk in the evening. So now we have added three tasks. Now let us view the task. So we will press option 2 and we will view the task. So as you can see, study is pending, gym is pending, and walk is pending, because we have by default chosen here to make it false. The done will be false when we add a task. Right now, if we want to done mark task as done, so we will choose option 3. So now it is asking me which task, enter task number to mark done. For example, if I have completed studying, so I will enter the task number 1. So task 1 is marked as done. Now if I view my list, so it will show me that task, study is done and gym and walk are pending. For example, if I have to delete a task, let's say option 4, so it again gave me a list. Now if I want to delete the task walk, today I'm not in the mood of walking, so it will delete it. It will show me that walk has been deleted. Now if I view my tasks, so it will only show me study and gym. So whenever you see something like an app like Notion, or a simple diary, a to do app, the notes app which you use, and you mark somewhere done or not, so those are based on these structure only. So this is how they work, and this is how everything works, and our to do list is created. So this is done and it is beautiful, and this was the final lecture of the section and the course. So I hope you would have understood, and if you really liked the course and you are watching till here, please give a good review about the course. And thank you for attending the course. You are till here, and usually most of the students don't watch like complete courses, since I have the stats. So you are here, that's great. Now you have completed all your basics and some advanced topics of Python like hoops and everything. Also, we have built projects. You can check out my other courses too. I make courses on tech and a lot of things, so you can check it out whenever you want, and I'll be there with you always. Till then, bye bye, take care, goodbye, thank you.